There we go. Good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome into .NET Conf. Focus on F Sharp. It's so good to see you. We've got a full day of programming here for you. This is of course another one in our series of .NET Conf focus events, a full day that's focused on a technology, a series of tools around .NET that we think are going to make you a better developer, a better programmer, and improve your experience with .NET. Now, there's a lot going on around the entire event here. There's a lot happening that I want to make sure that you know about, that you tune in and find out about. Now, there were a bunch of slides at the start here, but I want to make sure you know that we've got a handful of sponsors that are available that have made some swag available, some digital swag, some real swag that you can get your hands on. You can get more information about those right here, focus.netconf.net/swag. And there's great stuff there from a bunch of sponsors. Like I said, digital content that you can get and get running to show your support for .NET. Now, a couple other things that are going on. There's a mod the .NET bot website that's set up as well. There you go, mod.net-bot.net. You can go there and you can make your own .NET bot that you can turn into a wallpaper. You can even 3D print a .NET bot and have that available for you. So make sure you check that out. .NET Conf 2021, our full 3-day event is coming up in November 9th through 11th. We just opened the call for content. Go to .netconf.net and you can check the call for content there. Submit your sessions for consideration for the big event that we have coming up in November. We're going to be announcing the launch of .NET 6 at that event. Tomorrow here on Learn TV, if you're watching on Learn TV, it's right here. But if you're watching Learn somewhere else, YouTube or Twitch, make sure you check out, we have a full session that's going to be walking through the very basics of F Sharp called Let's Learn .NET, all about F Sharp tomorrow. We've got a couple of Learn sessions that are available, Learn modules available on learn.microsoft.com that you can check out to walk through and learn how to get started with F Sharp. We encourage you to check those out. All right. I think that's enough rambling from me here. We've got our friend Don Syme coming on here, who's going to kick things off for the day and talk to us all about the great stuff with F Sharp. Let me bring on Don Syme. He's a language designer for F Sharp. There's Don. How you doing, Don?
Hello, Jeff. And it is great to be here at .NET Conf, Focus Day on F Sharp. And I'm very excited for the day of content we've got going. We've got lined up today, so thanks for having me on.
And I'm looking here in the console. You've got a whole collection of great speakers to help you with this keynote. I'm going to step away and let you kick things off.
Thank you very much, Jeff. And yes, let's get started with the keynote for the day, which is called the F Sharp Bonanza. And many of you will know I'm the originator and designer of the F Sharp programming language. I'm an F Sharp community contributor, and so are the wonderful guests we've got coming on today. And instead of giving a hearty technical talk, you can find many, many different technical talks from me online. You can also find talks about the history of F Sharp and many other things. But today I want to do something different, because one of the reasons I so love F Sharp is about the community of people who are using it and contributing to it, the amazing companies that are using it to do all sorts of different programming around the world, and the people who are educating others and teaching and everything else that is going on. And I just want to, in this bonanza, not talk about the F Sharp language so much. I'll just talk a little bit about it, but let them come and share some of their experiences with using F Sharp and why it's making a big difference for them in there, whether it's a commercial context or anything else that's going on. First of all, 3 big themes you will see coming out in both in this Bonanza keynote and throughout the whole way we talk about F Sharp, about what are the characteristics of F Sharp as a language, what has it always been aiming for. And these are the things which we started F Sharp to deliver, to give you succinct programming, to give you robust, and I mean robust, correct code, and to give you performant programming in conjunction with interoperability, great libraries, part of the .NET ecosystem, part of the JavaScript ecosystem, and so on. So these are three big themes where you're going to be hearing a lot about today. And we'll return to those at the end of the keynote. And I think many different speakers throughout the day will be touching on these themes about, what is F# like to use as a language? What's the experience of it? So a question people ask is is like, what is F# good at? What is it kind of good for? What is specifically, which particular part of programming is it good for? And there's this wonderful answer to this question, which I want to draw out. And the answer was done by Dave Thomas in the F# community. And he said F#'s good for programming. F# is just good for all sorts of different kinds of programming activity. I really want to say that it can be used for an exceptionally broad range of activities, but there are some particular kinds of programming which you're going to be hearing a lot about today. And I just want to quickly call them out, and that is F# is great for web programming. You're going to be, I think the first three or four guests we have are going to be talking about using F# for web on the client side or on the server side. They're going to be talking about it for microservices, and they're going to be talking about it for JavaScript programming on the front end. And F# is also fantastic for cloud programming. There's many different dimensions to this. Some of them are based around web programming as sort of a foundation. And then, the microservices I mentioned can be seen as a form of cloud programming. And it can be about cloud delivery. And F# is actually excellent for AI, ML, and data science programming as well. And I just wanted to, F# generally, good for programming. I wanted to draw out those three: web, cloud, AI, ML, and data science. And now, but in terms of characteristics, just to fill in that kind of, what is F# good for, and to kind of populate it with some words that you can use to tell your friends about what is F#. They say, what's that F# thing? And I said, what's it for? And they say, well, maybe you're working in Java and it's a little bit there's a little bit too much ceremony in all your code, and you'd like your code to be more like Python. It's really good for succinct programming. It's really good to kind of get that crisp, clear solutions to your programming problems. And it's also very good for robust and correct programming. And this is more aimed at those of you who are perhaps more familiar with Python. And, Python's great. It's really succinct and can be really very, very clear in its expression. But it partly because of the lack of strong typing and a lot of some other characteristics, well, it can have kind of issues. Sometimes at kind of keeping that succinctness while also being correct. And during the day, for instance, we'll be hearing from, or during this keynote, we'll be hearing from people who've moved from Python to F# in order to get the best of both worlds, in order to get that succinctness in programming and to get that correctness and robustness as well that comes from strong typing and some other technical features. And it's also excellent for performant programming. Its performance characteristics are exceptionally good. You're right up there, C# and Java kind of performance, while keeping that succinctness and also delivering on that combination of features, a combination of characteristics which underlie what we're delivering with F#. You can find out all about F# at .NET/F#. But to summarize, F# is good for programming, web, cloud, AI, data science, ML, and many other characteristics, many other kinds of programming. Just to give you a little bit of orientation, how do you get started with F#? Well, F# is everywhere. It's available in the .NET SDK. You can just go to .NET.Microsoft.com. You can install the .NET SDK extremely easily, whether you're on Linux or whether you're on Mac or maybe you're on Windows. And you get the command line tools. You can start doing .NET New Lang F#, .NET Build. And these tools are available absolutely everywhere. And you can be using Visual Studio Code as your editor. And you can be using plenty of other tools tooling choices. And the Getting Started material will take you through all that. If you want to get started on the web backend, there are several choices. You can use ASP.NET, for example, ASP.NET Core directly. There, you can also use a wonderful system called Giraffe that gives you this ASP.NET micro web framework for building rich web applications. You've got the URL there. This is hyper functional server-side programming. There are some other choices, things like Falco, and some other kind of choices for doing F# on the web backend. And lots of the people we have in the Bonanza today have been using this. But also, you can do F# for the web front end using JavaScript, or using a system called Fable or a system called Web Sharper. And I've given you the getting started instructions here for using Fable. And this is F# in a, many of you might be thinking, F# is a .NET language. Why is he talking about JavaScript? And so, no, F# is a JavaScript language as well. And you can live in the JavaScript ecosystem using it a lot like people use TypeScript. And you just do, you're in the node, you can use node packages, you can do npm install, and you can use F# as a JavaScript language. This is tooling provided by the F# community, fable.io, websharper.com, and go in and join in. They're very exciting projects and you'll be hearing more about those in the later talks during the day. If you want to do full stack, there's a great getting started a system called Safe. There's some other options around as well, but you can do .NET New Safe template, install the templates, and just it's a very straightforward, and bang, straight away you're in there with a back end in F#, a front end using Fable in F#, and very simple deployment through to Microsoft Azure to actually get it live. And some of you will know that later in the day I'll be doing a session, it's a pre-recorded session, with Guido van Rossum, the designer of Python, and he will be actually, he doesn't know this, but the programming he will be doing in that session is with SafeStack templates. And so he's actually doing F# JavaScript programming, F# .NET programming, but it's really, really simple to get started with this system. It's one of the best full stack systems in existence today, I believe, in terms of its technical characteristics. And it's used, we'll be talking about how it's used in practice in just a moment. So F# for data science and ML, you've got F# in Jupyter notebooks, in .NET notebooks, in Visual Studio Code. On the left here, beautiful programming experience for doing this explorative data science ML kind of programming. You've also got ML libraries through ML.NET and many other library choices. You've got great charting libraries with the people at Plotly delivering .NET libraries and great F# experiences for using the Plotly charting tools. And so head over to .NET Interactive and .NET/ML and get started with those. Finally, there's a whole learning to code kind of experience, code.visualstudio.com, learn to code. You can get started with it's a single click install for a full development environment with Visual Studio Code, C#, F#, .NET Interactive notebooks. So if you want that single click learning to code experience, get involved at code.visualstudio.com, learn to code. Okay, so with that, I would like to bring on the very first of my special guests in our section, which is called F# for a Better World. And we are bringing on, so I'd like to ask Jeff to bring on my first special guest, who is Tejas Vishwanth, and who is the founder and CTO of Chaldal Engineering. And Chaldal is the largest, so first of all, hello, Tejas Vishwanth, and welcome to .NET Conf Focus Day on F#.
Hi, Don. Thanks for having me here.
It is a total pleasure. I'll just flick you over so I can see your face on my screen. You see you infinitely stretching into the background there, and wonderful to have you. I know you're joining us from San Francisco today. If that's right.
That's right.
And I will, if Jeff has got, I won't be sharing my screen on this section, and Jeff can just bring you and me up on the screen if that's what he wishes. Thank you very much, Jeff. So Chaldal, it is the largest e-commerce company in Bangladesh, if I'm not right. And you've told me, I know Bangladesh is about 150 million people and some of the world's most densely populated cities. So why don't you tell me a little bit? Firstly, I think we've talked about this before. And I've been to Bangladesh, which is relatively rare. I went in 1994, and I've read a lot about the history of Bangladesh, and I understood Bangladesh back then was in a dire situation. And for me, it is so exciting to know that technology and programming, and even programming in F# and .NET, is playing a core role in the Bangladesh economy today, if I understand things correctly. Would you say that's fair?
Yeah, that's fair. We are one of the most prominent tech firms in Bangladesh right now, and we are F# first. So what you're saying is absolutely right.
I mean, I never. For me, that's just an amazing thing to know.
Well,
to know that
F# is like such a great language. I think it it deserves to be up there. So
yes, I've actually played with this idea that one of the ways, programming is a competitive thing in the end. There's different countries around the world all need to kind of retool to become more productive. And right. I personally think that through embracing tools like F#, economies actually get a productivity boost to kind of, and I think of it in the sense of like retooling in the way that, say, the German economy really cares about retooling its automated industry,
right.
or and here we have a third world economy and retooling with modern programming tooling.
Right.
And so tell us a bit how Chaldal got started. Tell us about the kind of work you're doing. Right. And I know you have both commercial and non-commercial work, if I understand correctly.
Right. Yeah, of course. So we started back in 2013. At that point, my co-founder and I were working in a fintech startup in Silicon Valley. And, life was changing very rapidly here. Like we had an app for everything at that point. And at the same time, we were both from developing countries. I from India, my co-founder from Bangladesh. And there was this massive tech vacuum that was building up in these places. And when we were there, we always used to notice that, hunger and poverty were more distribution problems. There was no real scarcity in many of the resources.
Wow.
Yeah. So
wow. So you see hunger and poverty as an organizational information and logistics.
Exactly. There's enough food in the world to feed everybody. It's just that the systems are just not built well. For example, perishable supply chains in developing countries, there's just no transparency in how they are run. They're just run by many layers of middlemen, and nobody knows what happens. There are massive price fluctuations. The farmers get hurt, the consumers get hurt, quality is bad, and nothing is predictable. So this is one of the problems we set out to solve. And with technology becoming so easy and accessible these days, this is one of the things that actually which made sense for us to pursue at that point. So in 2015, we launched the world's first 1-hour delivery service for groceries in the city of Dhaka.
So you're saying the world's first 1-hour delivery, which I know we have here in
grocery delivery.
London now as well. Are you saying that was first done?
Yeah, we did it so we were inspired by what happened in Manhattan, where Amazon set up a 2-hour delivery service back in 2015 in January. And then we were like, hey, why can't we do this over here? And then we decided to set up the world's first 1-hour grocery delivery service. We used a network of micro warehouses so that was way back in 2015, right before we got into Y Combinator, and then and this eventually led to a series of investments from the World Bank.
Wow! That's just an amazing and inspiring story. And so tell us a bit about why you chose F# to build out your technology stack, and what sort of advantages it's been giving you.
Yeah. So, when we started off back in 2013, we had a massive vacuum in technology services. So we had to actually build out a lot of things ourselves. We had to build out mapping, we had to build out compliance, HR systems, accounting, payments. So what we had were a lot of complex systems and a lot of back office tech-driven processes. And this eventually led to a lot of complexity in our code. And one of the things you have to understand about developing countries is it's very expensive to raise capital. So a similar company of similar size in a different place would be able to raise $50 million and hire a team of 100 engineers, and we would only be able to raise $5 million and just afford a team of 10 people. So eventually, but the problems we were facing were exactly the same. So eventually, it just got a bit tiring because we would just every new release would bring in a whole bunch of bugs along with it. So I was trying to find a way to to gain an edge over our peers. We were forced to innovate at that point. And I came across Scott Lashen's wonderful website. It was life-changing, I must say.
And this is F# for funandprofit.com. And Scott will be speaking next, actually, giving an intro to F# session. And yeah, so this was your entry into the world of F#.
And he introduced this concept of modeling your problem domains really well. And F# has a fantastic type system that allows you to do so. And when you do that and you make your illegal states unrepresentable in code, you just make away with do away with a large class of problems which you'd otherwise have. So
so my understanding is you're actually using F# on the front end as well, and you talk about it here in some notes I have here. You're able to churn out cross-platform mobile apps and web apps using F# and using Fable on the front end, if I understand correctly.
That's right. So we use Fable. So we bring our models all the way to the front end using Fable, and then that compiles down to JavaScript, which is targeted on the, we use this tool called React XP, which is a abstraction on top of React Native for mobile apps and React Web for web. So we have one code base, which then targets all the UI platforms at the same time.
Wow, that is amazing. Well, in the name of time, I know we've got a lot of guests coming on today. You're going to stay on, Tejas, and I'd like to bring on my second special guest, who is Kelsey Tripp, who is a Director of Engineering at Imperfect Foods. And if we have Kelsey coming on, hello, welcome to dotnet Conf, Focus Day on F#, Kelsey, and lovely to see you piping your name there using the F# piping operator into your Twitter handle, Tripp. Welcome, Kelsey.
Thank you. Thanks for having me.
Total pleasure. Now, you're both in San Francisco, but in some ways you're at different ends of the economic spectrum. We've got Bangladesh, third world country, with its, Tejas is talking about farmers, refugees, and refugee camps and other things that his company is working with, and profit and non-profit. And you, so tell us a little bit about your company, Imperfect Foods, what it is and what your mission is.
Yeah. So at Imperfect Foods, we're primarily we are based in the U.S. right now, and we're reimagining grocery delivery for a kinder and less wasteful world. Our mission at Imperfect is to eliminate food waste and build a better food system for everyone. And we do that through offering sustainable and affordable groceries through weekly deliveries, which allows our customers to, save time, save money, and also save the planet.
Wow. So, in fact, both of you are, in a sense, improving efficiency in food distribution and food reuse. In different economies, different settings, different scales in some way. I think Childhood's a very big established company in Bangladesh, and you're more of the kind of sort of smaller startup kind of platform kind of thing, if I understand, Kelsey. So, but you, Kelsey, also chose to use F#, and if I understand correctly, you're using F# mostly on the back end and in a microservices kind of architecture. Is that correct?
Yeah, that's right.
So explain a little bit more about what that means in practices. Microservices is a word that gets thrown around a lot by different settings. What's it practically speaking mean for you in F#?
Yeah. So our software engineering team builds the e-commerce platform and also the internal supply chain and logistics tooling that supports our mission. And so with that, we're moving a lot of data around between various internal and external systems. And so we've built out a number of event-driven services that each are handling a particular concern. So for example, we have one service that's dedicated to managing our product catalog, another one that's handling customer orders, another one for providing real-time inventory availability. And F# is our language of choice for all of these backend services because of, type safety, scalability, and all of the good stuff that, we're going to be talking about throughout the day.
And Kelsey, you in the notes you sent me earlier, you talked about you and your team as being pragmatic practitioners of functional programming. Now, I haven't talked about functional programming much along the way so far in the talk today. I've talked about succinct and robust and so on. And I know a lot of people, functional programming is, of course, one of the primary things supported by F# and is one way to leverage F#'s features. So you talk about yourself being functional programming and pragmatic. And for some people, those words don't go together, right? People think of functional as being some weird thing that mathematicians do or something like that. But for you, it's a pragmatic choice to deliver a company. You're betting your company on it. So, but tell us, why is functional programming pragmatic for you, or why is F# the natural choice to do pragmatic functional programming?
Yeah, great question. So, I should say, I borrowed that phrasing of pragmatic functional programming from one of our great backend engineers. But we leverage a lot of the functional paradigms both in F# and also in some cases in JavaScript. Our front end is built in React, and we do have a handful of Node services as well. But in general, I think our team takes a really practical approach and tries to use the right tool for the given job rather than kind of having a strict one-size-fits-all mindset. But so that's why F# is really great because it provides all the benefits of functional programming like immutability and composition, but also has the flexibility of being able to leverage the broader .NET platform. And of course, as we'll talk about, the performant nature of it is excellent as well.
Wow, that is great. All those things line up with kind of what I've been saying, and that's really great to hear. So Tejas, just in the last couple of minutes that we have before we move on, tell us some of what have been your biggest challenges. I mean, it's really hard for me to imagine. You've got a technology company, you've got all the challenges of being in a I've been to Dhaka. It's a chaotic city, so quite often. So are you spending most of your time tracking down bugs, or are you spending most of your time like tracking down real world problems in warehouses or supply? I know you use this interesting micro warehouses kind of model for your network. What are your biggest problems day to day?
Well, actually, our problems is we don't have too many problems on the tech side ever since we moved on to F#. So yeah, so we used to have a lot of problems, just like building out large scale systems. We had to build out so much code, and we would have so many bugs. So these days, the biggest problem is just like teaching F# to new fresh grads from universities, and but we have a mentorship culture in a company, luckily. So we're able to onboard somebody within 3 months, teach them the concepts of functional paradigms. And, even the funny thing is, even when they go back to write regular imperative code after that, they actually end up producing much better code. So it's like they get like a nice OS upgrade for the brain,
Wow, that is F# making people better programmers. That's good to hear. Okay, I'm sorry. In the name of time, we have to move on. I wish I know we will be inviting both of you to future F# events with keynotes or similar things. So I personally will look forward to having you along sometime soon at other F# events, and it's been so lovely to have you both here on the F# Bonanza today. Thank you very much. And with that, I shall switch back to my slides, and we shall just talk, if my slides are showing. They are indeed. And I will talk about 2 other examples of making the world a better place with F#. And thank you very much to Kelsey and Tejas. So the first is we've just, of course, live in the time of COVID. And I want to talk about something that has been done with F# that has been making a big difference in one particular country, which is the country of Slovenia in Europe. And it is the COVID-19 Tracker Slovenia. It's a community-run project that collects, curates, and publishes COVID-19 data for Slovenia. Came to life in March 2020 and serves around 500,000 to 1 million daily users, which, given the population of Slovenia, is actually a substantial chunk of that country's population are using this. It's an open source project. It's actually a polyglot project. There are, I think, many different contributors to this. It's got Python for data capturing. It's got C# for the data APIs. It's got Vue as a single page application framework, and it uses F# Fable for the data wrangling and visualization on the front end. So F# for JavaScript. And F# has proved to be a good solution. The majority of people contributing to the code have actually never used F# before, and yet most of them were able to quickly find their way in the code and develop their own visualizations with little or no orientation and very few bugs or runtime problems. The next company I will mention making the world a better place with F# is called Machtmit, and they are in the north of Germany, and they are operating a platform which is itself operating 2,300 charging points for electric vehicles in northern Germany. And the platform allows drivers to start and stop charging transactions and to pay with PayPal, credit card, and so on. They've been live for over a year. Business is booming, and they are able to triple their monthly sales in that first year. The platform is 100% F#. It's actually using the safe stack architecture. It's effectively a safe stack application that you'll see Guido van Rossum of Python will be using that architecture in about 3 hours' time. And it uses ASP.NET Core 5, Azure Functions, Event Hubs, Azure Cognitive Search, Azure Storage, and the front end is Fable Elm-Mesh with React. And the comment from Mark Mitt is that the F# ecosystem is mature now. And with that, I'm going to bring on my next two special guests, and I will stop. The first of those is Edward Ostrovsky, who is Associate Director at a very large and iconic American company, Walmart Global Tech. And Edward, welcome to F#.NET Conf, and lovely to have you here. Thanks for joining us today.
Yeah, thanks, man. Really excited to be here.
Okay, thank you very much. A couple of audio problems there. I hope it's okay. There was a little bit of something going on, but let's see. That's how we go. So I understand you. I mean, you are. Can we just do another test there, Edward? I am getting very bad audio coming through. I can't hear you. Let's try that again. One more time. So unmute you now. Okay, you are on mute now. If you can unmute.
What about that?
That is good. I've got
okay.
That is good. We can hear you. Thank you. Okay, so I understand you are growing a team at Walmart, and you've actually been hiring a lot of F# developers lately. So tell us about the team you lead, what size you are, and how you fit in the Walmart business. Hang on, we have audio problem again. Okay, Edward, I think with the audio, one more. I did hear you for a moment.
Let me try this one.
Let's try that.
Okay.
All right. So let's see.
That.
Tell us about the team you lead, what size you are, and how you fit in the Walmart business.
So I lead a team called Thor that is a warehouse management system in Walmart, and it powers 10 fulfillment centers around the country. These fulfillment centers account for 25% of Walmart's e-commerce business.
Wow.
And the main set of FCs powering Walmart fulfillment services. We have 25 engineers in the US and India.
Wow. So you're the sort of the software base for those big fulfillment centers that are just, a major part of delivering out Walmart's sales across the United States. That sounds fascinating. For me, interestingly, again, it's in that logistics and organization kind of programming, making that whole business. We've seen a company in Bangladesh, we've seen a company in San Francisco, and now we're seeing one of the biggest companies in America using F# to help improve efficiency, program a more efficient world. So tell us, what sort of programming is involved in order fulfillment? Server side, client side, database, what's going on?
We're a full stack system. Our entire backend is in Azure Kubernetes and is fully F#, and the front end is TypeScript and React.
Great.
Our architecture is event sourcing using Event Store. We have usages of Cosmos DB, SQL Server, Azure Tables and Queues, Elasticsearch.
Wow.
It's whatever is appropriate for the system at that time.
That sounds. Now I remember I've seen a talk, I think, from about the use of event sourcing in a predecessor company which was acquired by Walmart called Jet, and I remember that the use of event sourcing was really incredible in its conjunction with F# for making a robust event sourcing system. In particular, those that you could replay the entire history where necessary, and the like. Is that the kind of techniques we're talking about?
Yes, absolutely.
So that's why. So tell us about your main concerns as a dev manager. Are you interested in code quality? We're talking about F# teams, people, about, it's not just about the technology. It's about how programmers communicate. And is it about code reviews? Is it about careers? Is it about ensuring recoverability? What keeps you awake at night? Logging the system? What is it?
All of the above. Building a software is more than just writing a piece of code. You have to define a name for some definition of done that includes all the buzzwords like quality, maintainability, readability, highly tested, well documented, all the proper monitoring. And that motivates me to help each person, especially if they're starting out in their careers, to learn more than just the coding part of our jobs.
Okay. So a big part of what you're doing is making sure they're not just coders, but they are quality software engineers delivering on all of those aspects of a software base for the company.
Yeah, the better they think about the whole process, the more ownership they take and they grow. And then I don't have to be as hands-on as possible, and they can be at my quality bar.
I see. So you kind of have a holistic or well-rounded view of the developer, and F# is part of that role. So tell me about how you found it hiring F# developers. I know you've been doing that recently. What are their typical backgrounds? Do they learn F# on the job, or do they already know it? What are you seeing?
I've hired some F# enthusiasts, but most of the people had like no experience with functional languages, F# or even .NET. Most people come from a object-oriented background in Java. So we just basically assume that for the first few weeks or even months sometimes that they're just going to be learning and ramping up on the job.
Okay. Well, that's interesting. So, I mean, from what we heard for that the Slovenia COVID tracker, people are just able to come in and pick up F#. It's actually good for learning. It's easy to learn.
Definitely.
Yeah. And I think that that must be one of the advantages of keeping your code base clear, well documented, is that people are picking up those practices as they work into the job.
Right. So, when we first hire people, we throw them into our onboarding documentation, which I've spent a lot of time improving. And it first introduces to our system, our business, and our tech stack, but then quickly just tells them to go through F# for fun and profit.
Right. Second time we've heard that today. F# for fun and profit. It's a site for learning F#. Yeah, great.
And then we used to hand them before the pandemic a copy of Domain-Driven Design Made Functional. So another shout out to Scott.
Mm-hmm.
But now they just get that as part of the O'Reilly subscription that Walmart gives us. So
great.
So we use those to ramp people up. But
so in the notes you sent me, you talked about the three, you've kind of been developing these theories, the 3 phases for learning F#. Quickly run me through those, and then we'll bring on our second guest in this section.
Sure. So I found that looking at people's code reviews that they go through these 3 phases. The first one I call fighting the compiler. Basically, at this point, they understand the syntax, but they don't get maps, binds, or monadic functions correctly. You see that they're wrapping and unwrapping types just to make the red lines disappear, and the code is just really hard to read. Once they get past that, the next phase I call learning the tools. What they get is they're not really understanding how powerful a match statement can be, or they use a choose where a filter would have been better, or using an array instead of lists, even though they iterate over the whole collection each time. To fix that, it's just repetitive feedback over the code reviews and explaining why the other thing is better rather than just saying, do it this way.
Interesting.
The last one is thinking functionally. Most people with object-oriented backgrounds will be skeptical when hearing about the merits of immutability or type safety. I never thought I had a problem with those things before F#. You need a really great example of something they're currently working with that helps them see that light. For example, it can be a challenge to convince them that state transitions through types in a DU help make code cleaner and more readable than filling in some missing option properties on a type, like you would in object-oriented.
Yep.
They'll end up with the same general set of functions, but it will be much more self-documenting. Some folks try it out. Other times I just have to do it myself and show them the results. It's really hard to teach that last part to the team because they need to work on a task that sets that up for them, and not every piece of work they do will lead them down that path.
I see. So F# is giving you the tools to capture the complexity in things like state transitions as information gets enriched in a pipeline, but or as things develop. And it's giving you the tools, and then there's a learning phase that the team needs to go through, and new people about how to deploy those tools in the right way to capture the complexity of what's going on.
Yeah, definitely.
Yeah, that's great. I'd love to, we'll be coming back to these topics, I'm sure. Thank you so much for joining us today. And stay with us. Fascinating insights, because we'll bring on our next guest in this section of growing and building out F# in the enterprise. We'll bring on Edward. If Edward could stay, that would be great. And we have Vageef Abalov will be joining us now. And we have Vageef. Welcome along. Lovely to see you. Welcome along to the show.
Hello.
Tell us, Vageef, introduce yourself and tell us who you work for, and we'll continue.
Yeah, I'm Vageef Abalov. I'm Russian, living in Norway, and have been working for several years at various projects at NRK. NRK is a kind of, it can be compared with BBC in England. It's a Norwegian broadcasting corporation working with radio, TV, and some public services like weather forecast, election result monitoring. So it's quite a broad domain.
I see. So we've gone from the area of food delivery to the area of a major TV media company with,
Yes.
a wash with that. So should I be thinking you're like writing video codecs or something in F#? What are you doing? What are you writing?
In our small team, where I'm working mostly, we writing services to upload to the cloud media files. It's of different qualities, so people can render on different devices at the best qualities. And of course, it's 24/7. It's also news clips, so everything has to work all the time. It should be very performant. Yeah, and we're using F# and Akka.net, so it's actor model-based system.
Okay, Akka.net for Activate. That's great. That's one of the many different programming models for doing cloud and distributed programming in .net and with F#. So tell us a little bit about the profile of typical programmers using F# at NRK. How long do they take to get up to speed, and do they find it easy to learn?
I checked yesterday at GitHub and found that we have 67 repositories qualified as F# repository, which makes F# quite popular language in organization after, of course, JavaScript, C# and Java. And with so many repositories, it's probably hard for me to speak on behalf of various teams. But I think what may be common with different teams is that we have quite complex domain. And it's quite important to get type definitions right. As you had a slide about F# being good for correct programming. I recently watched a presentation that studied half-life of different software entities. So for example, half-life of software developers in a project is about 3 years, which means that in 3 years, statistically, half of the team will be gone or replaced. But half-life of code lines is 13 years. So maybe contrary to our expectation, we think that we continuously improve our code. It's we as a team, but not we as individuals. So it's somebody else who will be maintaining my code. And then it's very important to get code right. And I think that F# is an excellent choice to, with strong typing, to properly describe such complex domains. And probably that's one of the main reasons that different teams choose this language.
That is absolutely wonderful to hear. Now, we are running short on time today. I'm so glad, Vageef, that we had the news from NRK. I know it's a great example of using F# in media. I think all these really complex, the complexity of our modern world is media and logistics. And we have two great examples of how F# is helping to solve those problems, and two great examples of deploying F# in the enterprise. And Edward, your experience as a developer manager in working with an large F# team over a long period of time now is really interesting for us all. And I know the F# community, and in fact the .NET community, will be coming back to you. And I think you will be love to have you at future F# events talking more about your experiences in those particular areas, which are so crucial for the actual rollout of F# in enterprise situations. And Baggy, thank you very much as well for coming along.
Thank you for having me.
Yeah, pleasure.
Thank
you. So that was Edward, and then Baggy from NRK TV in Norway, full stack in cloud and media with F#. I will very quickly run through some other companies. Here's a wall of logos of companies which are using F#. And we have a few. I'll call out a few of the stories just very briefly. We have Software Park, this one down the bottom in the middle. Software Park choose F# because it allows them to codify domain logic clearly and concisely. The GPS aggregation product that they started building 18 months ago is already processing nearly 8 million signals for 60,000 devices across Europe every day. They're promoting the use of F# has significantly increased the number of quality candidates actively seeking to work for them. So they report F# as a bonus in hiring great developers. The next I'll call out is Rocket Mortgage, right in the middle, and it is the USA's largest mortgage lender. And they use F# to create microservices again, which we've heard about on .NET in an event streaming platform. So again, we see that event streaming on the back end to pool loans to sell on the secondary mortgage market. And today they process tens of millions of events every day across dozens of services with a minimal infrastructure footprint, with F# being an important driver in that. CalTime, I will mention at the top in middle at the top here, and they have built a service for attendance, time tracking, and absence and shift planning. And F# allows them to keep the code simple, even in complicated business cases. Also mentioned CN Group, who have been applying a functional first approach to customer projects in .NET, and they use Fable and SafeStack, which we hear about, and they deliver most importantly on higher customer satisfaction. And finally, Olo provides world-class software as services for online orders and delivery in the restaurant industry. The engineers love working with F#. It's been a real asset in attracting high-quality engineers. So in this last section, I'm going to bring on 4 very special guests. And we have 4 guests. The first is Kevin Schneider, who's a researcher from Technical University of Kaiserslautern and is using F# for maths and stats. And the next is Ambika Eshwa, who's a student, and wonderful to have Ambika along. He's a student and functional programming enthusiast from Rutgers. So welcome, Kevin, and welcome, Ambika. Lovely to have you both along.
Thanks for having me.
And we'll also bring on Dr. Faisal Waris, who is an AI and ML machine learning researcher doing data science with F#. Hello, Faisal. Welcome along. And finally, we'll bring on Darren Platt, who's the president of a biotech company called Demetrix, based in the Bay Area. And welcome along, Darren. And in this section, we have the themes of this section, of those original themes about F# being for succinct, robust, and performant programming. And we've asked you on together because in some ways you all represent different aspects of this thing of why do those characteristics attract people. And let's begin, first of all, with you, Ambika. And I'd like to hear, you're a student and you've been attracted to F#. And tell me, if you had to pick out those characteristics, succinct, robust, and the like, which of them appealed to you for choosing F# as a focus of your work?
I think robustness and succinctness in that order.
I see. So it's the... what is it about robustness that you're trying, that when you think about that? What are you trying to program up? What sort of things are you working with?
A lot of what I do is just hobbyist experimentation, right? I've written like small programming language implementations, lots of parsers, tools for working with databases. And a lot of what I find is that, F#, the way it's designed, the way the compiler works, makes me a better programmer. It forces me to be more robust.
So tell me, why don't you do this in Python?
Okay, so what I found was that when I started using functional languages, when I started using F#, I was able to keep the succinctness that Python gave me, but I was able to write way more robust code in a very beautiful way. It was allowing me to be very expressive, but it was forcing me to make better decisions. And it was eliminating tons of runtime errors I was getting with Python.
That's fascinating. Now, Darren, I know you work in bioinformatics, and in fact, you are an ex-Python developer, but you use F#, if I understand correctly.
Yeah, first of all, I want to just say thanks if Guido's out there for Python. I adopted in 1994, and it was an amazing step forward. And I'd say eventually I got tired of making the same mistakes. That's what Ambika was talking about. You run some code, you find out after 3 hours that, there's a type error on the last line and you get the wrong answer. And F# is just a better Python. If you're doing complicated code, it runs faster, it checks stuff at compile time, it's type safe. I really think you can have all the good things about Python and also just get a lot of benefits on top of it. It's also just kept on moving. The JavaScript backend means you can do full stack programming on it now, which is awesome.
Yeah, I think that is an interesting new dimension. That's wonderful to hear that's, and this is not from a hobbyist perspective. You're using this in a bioinformatics company.
I should actually, I just give you the tagline. My day job is making cannabinoids, the active ingredients in cannabis, in yeast. So we have fermenters that produce all sorts of wonderful and useful molecules. And so we do everything from very complicated algorithms, DNA design, to tracking about 1 million bits of liquid moving through a lab every sort of on a yearly basis. So really complicated, and you often hear like F# is good for science and finance, where you have really complicated things and it's expensive if you make a mistake. And I would sort of flip that around and say, is there an industry where it's inexpensive to make mistakes that are expensive? And F# just helps us avoid a lot of those at design time, at edit time, rather than a year into production when you find the results are wrong.
This event is actually really having this conversation. It's actually changing my perspectives on where F# is finding a sweet spot in industrial settings. We have it in education settings. Ambika talking about how it's helping her become a better programmer, and Darren, you're talking talking about the robustness qualities, and I think performance qualities as well are also
absolutely. I also, back when I was a Python programmer, I used to play this game where I would write something in Python because it was quick to write it, and I'd set it loose on a big pile of DNA sequence, and it was going to run for 2 days. And then I would try and rewrite the algorithm in C++ and see if I could finish faster than the Python had executed. So it was like a trade-off between I can get the algorithm right quickly or I can get it to run quickly. But it was hard enough to get the C++ to work that sometimes the Python was faster. And I always assumed that was a trade-off. I could write code quickly or I could have it run quickly. And F# was the first language where it's like, actually, I don't feel the need to rewrite this because it's fast enough, for almost every application that I don't break out C++ or Rust or something to optimize anything. It's just damn fast. And then if it's a little slow, it's so easy to write parallel code now that I can just grab 32 threads and scale it up without all of the kind of problems you normally have in a lot of languages introducing parallelism, because it's well designed.
Well, that is great to hear. Now, let me ask my two. Let's start with you, Kevin, and please introduce yourself. Kevin, I understand you're in Germany at the Kaiserslautern Technical University. Tell us about your group there.
Exactly. So we are basically doing fundamental plant research there. So something a little bit on the lines, as Darren just said, helps us there as well. But I think what makes us unique in this case, or why F# helps us with our unique problems, is that in fundamental research, you don't always know what is right. Even if you get some results, you can't know if they are right, because no one else did that before, some experiment, something like that. And if you have a language where you can't accidentally, for example, add integers and strings, that already helps you to minimize the errors that you could have during your data analysis pipeline, for example. So this is why we love F# for research, basically.
So you're saying your F#'s correctness, robustness kind of properties are helping you get your research right?
Exactly. Or at least it helps us to eliminate sources of incorrectness.
Stop you getting it wrong. Now, tell me, you are involved in FS Lab, and you're going to be giving a talk later on today. Thank you very much for being a part of the conference. And so tell us a little bit about what is FS Lab and F# stats as well.
So FS Lab is, I think you introduced that term, actually thought of as this center of gravity for data science in F#, basically. So we providing a space where projects can align to each other to form a data analysis stack. Think of like, if you're coming from an R background, like Tidyverse for F#, for example. And yeah, I think I will, or at least I hope I will be able to show later this day that all the tools are there to be productive in data science with F#.
Okay, so if you're interested in data science in F#, I talked about F# being useful. We've seen it for web and microservices, and we'll be hearing a lot about that. If you're interested in data science in F#, please come along to Kevin's talk later in the day. And let me introduce my last very special guest, who it's a pleasure to finally meet you face to face, is Dr. Faisal Waris. And please introduce yourself, Faisal.
Hi, Don. I am Faisal Waris. I work as a data scientist at a large telecom. I've been using F# ever since it came out. My first language when I started my career was Smalltalk. It was object functional at that time with tail call optimization. But it went away with Java, and Java was never satisfactory for me, and I was looking for something better until I discovered F#, and that was it then.
I see. Now, you've been doing amazing work recently where you've been doing AI and ML programming with F#, and I saw this incredible result that your F# code is actually shorter than your Python code by a couple of lines. So basically, they were the same for this graph convolutional model neural network.
So I ported a Python model called a graph convolutional network over to F#, over to TorchSharp. And what I found was that the lines of code in both cases was just about the same. But F# was actually 10 times faster for the data pre-processing side. Now, for model training, they're both the same because they both leverage the C++ library underneath. But F# was way faster than Python. And that's an important factor these days because we're encountering ever-increasing data sizes, a more complex pipeline. So type safety and performance is really key in data science these days.
Okay, so you've got Darren doing bioinformatics, getting those performance qualities for the data processing over there. You've got Faisal, you've been seeing those in the machine learning space, which is a very competitive space for tooling. And I was really pleased that the succinctness properties, we often talk about succinctness and correctness with F#, but to see those performance properties really of .NET and F# and .NET really coming to the fore was wonderful.
Absolutely, yes. I'm also using F# as a front end for Spark now with the .NET for Apache Spark, so that's quite helpful as well.
Yes, so it's a great, we haven't talked about it in this keynote, but F# has a wonderful big data story now with F# on Apache Spark. And you can see the samples on the .NET for Apache Spark homepage and head over there. And we might be having some more about that later in the day. With that, we do have to wrap up. I want to say a huge thank you. I wish we had more time. I know we're all going to be meeting at various F# community events one way or the other going forward. And it has been a pleasure to have you all on today and to talk about these themes and to just get the feeling for how they play out in your different domains. We'll be hearing more from Kevin later on in the day. Thank you, Darren. Thank you, Ambika. And thank you, Faisal. And with that, we will wrap up for the day. So just if we're back on screen with my slides, I believe here, Then we have some learning resources. So you can go to docs.microsoft.com/learn. You can go to .net/F#. There's also an excellent course done by Kit Eason called the Udemy F# from the ground up course. That is a paid for course, but of a small amount. But you can also go to docs.microsoft.com/learn and look at your first steps in F# and or .net/F#, and there are great resources available for learning. With that, I will end my keynote and hand back over to Jeff. I want to say thank you for joining here today. You can ask your questions live. I'll be back on later on the day for the session where I'm teaching Guido van Rossum, the designer of Python, will be learning some F#. And back over to you, Jeff. Thank you very much.
Oh my gosh, Don, so much to boil out of there, and I love that key fact. F# is good for programming. Take it where you want to go.
It's great.
Oh my gosh, so many cool things. Thank you so much. I look forward to seeing you later today when we bring on our friend Guido. But we've got another guest joining us that I'm going to excuse you for a minute.
All right.
We're going to bring
Thank
on.
you very much, Bile.
All righty, we'll see you. And I'm going to get ready to bring on Scott Vlashin is joining us here. Let me see if I can grab Scott. There we go. Hey, Scott.
Hi, Jeff. How you doing?
Good to see you. Now, I heard a number of the folks in that keynote talk about F# for fun and profit.
Yep.
And I understand that's your website.
That is my website, yes. And so I started that about 8 years ago now. And I was learning F# myself. And I thought, while I'm learning, why don't I sort of write up what I learn as I learn it? And it turned out it was very useful for me. It kind of forced me to be, to kind of dive into things. But it turned out to be really useful for a lot of other people as well. And that makes me very happy. I'm glad that a lot of people find it useful. Yeah.
Oh, that's terrific. So you're going to be going over some of the basics here for us to get folks started.
Yep.
All right.
And I'm
share your screen.
just going to share my screen. Here we go.
There we go. And what's going on there? Let me try. I'm getting some visual artifacts coming through. There it is. Fantastic. All right, Scott, the stage is yours.
Okay, thanks so much. Right, so this is the first sort of technical talk of the day, and I'm trying to think what can I do in 20, 25 minutes that can be useful for everyone. So I just thought I'd just cover the basics of F#. What do you need to understand in order to watch the rest of these talks today? And also, if you just want to start playing with F# yourself at home. Obviously, I can't do too much, but I thought what I'd do is I just go over the syntax. I'd go over the use of functions as the sort of building blocks of things. I'll talk about pipeline-oriented programming, which is a sort of different way of programming than you're used to if you're an object-oriented programmer. And I'll talk about F#'s composable type system. Now, F# supports all the object-oriented features that C# does and object-oriented languages have. But in addition, it has another type system, which is the composable type system, which is really, really good for domain modeling. And I think I can just give you a glimpse of that too. So I am going to just go into a demo mode now. I'm going to be using VS Code. I'm using the Ironide extension, which is the standard F# extension for VS Code. And the code is on GitHub. For anyone who's watching this later on, you can download it and follow the talk later on. So let's start with Hello World. So I'm just going to create a new file. And I'm going to call it hello.fsx. And there we go. Now, F# actually has a number of different ways to work. I am going to normally show you the sort of interactive way of working, but you can do interactive code, you can do scripting like Python and Ruby, and you can also compile a bunch of F# files into a single executable or a library, which is just like you would with C# or Java. So you've got a choice of different ways of working. Like I said, I'm mostly going to use the interactive mode, and what you do here is you can just highlight individual little bits of code and hit Alt-Enter, and I think Alt-Enter is actually the same keystrokes in VS Code, in Visual Studio, and in JetBrains Rider, which all have really good support for F#. So I'm going to hit that, and it's going to start up an F# terminal down here, and it says the name equals world. Okay, and now I do the next line, and there it is. It prints that line. So okay, very exciting. But there you go. This interactive F# code. Often when people are working with F# code, we actually kind of play around with things interactively. And then when we're happy with it, then we kind of put it into a compiled format for deployment. Now let's try the script one. I'm just going to change it so it reads it from the console. So now I'm going to go over to a command line, and I'm just going to say .NET FSI hello.fsx. And that should run this as a script, just like a Python or Ruby script or Perl script or something. And it should ask me for my name. And there it is. And there it prints out hello, Scott. So that's basically, you could, that's just a few minutes just to get started with F# for playing interactively. Now, let's start with some syntax. Okay, so obviously there's more to F# than that. The first thing you want to do when you're learning a new language is how do you define variables? How do you define functions and so on? So in F#, it's the let keyword. Let something equal something else. So here you have let x equals 42. Now in F#, the defaults are very different from most other languages. Everything is immutable by default. Most things are not allowed to be null by default. So no nulls, no mutation. That's sort of the default way of doing things. So this x, once you've assigned it to 42, you can't really ever change it again. Now, if I do this interactive thing where I do Alt-Enter and I show it down in the interactive terminal down here, you can see it says x:int equals 42. So let me explain how to interpret that. So x is a value, colon, every time you see the colon, it's something to do with a type. So type :int means it's of type integer, and of course it's equal to 42. Okay, well that's straightforward. Now what about functions? So what's interesting is in F# you use the same keyword for functions, let, because functions are things just like strings and ints. I mean, it's a functional programming language. Functions are treated just like every other thing. So here I have a function called add. Now a couple of things I want to point out is, first of all, we use spaces. It's got two parameters. We use spaces. We do not generally use parentheses and commas like that. That's not really the standard way of doing it. Sometimes you might do it that way, but in general we don't. The other thing, there's no return keyword, right? I don't need to say return. That happens automatically. And if I do Alt-Enter on that, there it is. It's interpreted this as the function add. I'm looking down here and it's x is an integer, y is an integer, and the return type is an integer. Okay, and if I want to run the code, again, when I call the function, I put spaces between the parameters, not normally commas and parentheses. So if I add 2 and 3, it says the answer is 5. Now, sometimes you do put the parentheses, comma thing. That's typically when you're calling object-oriented code, for example, the .NET library. But normally inside F# we tend to use the space type thing. And there's a reason for that. It's because we can miss off certain parameters and add them on later on. It's a very cool feature called partial application, but I'm not going to have time to talk about that today. Okay, now what happens if you have a little bit more of a complicated function and you need to have a big block of code? So in F#, just like Python, blocks of code are done through indentation, and you do not need the curly braces. So, this piece of code belongs to this function. These 2 lines of code here belong to this function. These 2 lines of code here belong to this function. So it's pretty straightforward how you do it, right? I mean, you don't need the curly braces to decide how it looks. And if you can define, inside your main function, you can define sub-functions and so on. And again, you can just indent, or if you have like a for loop or something, you can just indent for that as well. So everywhere you'd use curly braces, you just use indentation instead. So if you want to convert from a C language to an F# language, you basically follow these instructions. You use let. You basically indent how you normally would, and everything's going to work, right? You don't have to do anything weird. But you do have to delete the curly braces, delete the return, delete the semicolons, and delete all the type annotations because they're mostly not needed. So F# is a lot more succinct than a standard C-type language. So let's try it on this one. Here's like C code for that same thing that I had above, which is squaring something and then doubling it. So I'm going to use let, and I'm going to put equals. Okay, get rid of the curly braces, get rid of the return, get rid of the semicolons, put a let there. Get rid of the parentheses, and I can get rid of the int there because it's going to figure out there's an int automatically. That's how you do it, or how you convert C to F#. So the syntax is obviously different if you're used to a C star language, but it doesn't take that long to get used to. Most people can learn it, in a couple of days. It becomes more comfortable. Now, if you're coming from Python, of course, Python and F# are sort of cousins. So you just have to replace some of the keywords. Def becomes let, and the colon becomes equals, and you need to put lets in. There you go. That's kind of the Python turned into F#. Really, really similar. If you're used to Python syntax, then F# syntax is really easy. Right, now, I just said that we don't use curly braces. Almost certainly in the rest of today's talks, you're going to be seeing curly braces. So what is going on there? I'm not trying to lie to you here, but I just want to show you why you would use these curly braces and what circumstances they show up in. And they show up when you have, the curly braces don't show up on their own. They normally have a word in front of them, like this one says async. So this, when you see async followed by some curly braces, everything between the curly braces is a special block of code that we call a computation expression. And inside that computation expression, you can change the behavior of the compiler. So you can change how assignment is done. You can change how loops work. You can change all sorts of kind of interesting things. So for example, in the async computation expression, we've overridden the let, this is the special syntax, let bang and do bang, and we override it so it becomes basically the same as await in C#. So if in C#, if we had some async code, we wanted to do an await on it, we'd write something like that. In F#, we use the let bang and the do bang. Now, the async expression is not part of the F# compiler, it's just a library that you can use. And there's all sorts of things you can do with computation expressions. You can use it for async, and you can use it for tasks. You can use it for like query expressions in C#. You can use it for generating, collections. You can do validation, error handling, testing, code generation, all sorts of things where you want to sort of change the default behavior of something. So I've got some examples here. This is a sequence. So this is a sequence computation with an SEQ. And every time in this block of code, you can generate sequences in all sorts of nice ways, like using loops and so on. Here is a query expression, query with curly braces. And inside the query expression, you can do, the queries where, for student in this database, filter them and sort them and select them and stuff. And so, and like I say, this is not hard coded into the F# compiler. This is anyone can write one of these things and just use it from a library. So all these things are actually just are accessible, easily accessible through just importing a library in F#, and you can write your own. Right, so if we have a more complicated situation where we have a function calling another function, which is a very common situation. If I said, for example, I want to square something and then I want to double it and then I want to add 42 to it or something, in most languages, you would write it like this. You'd have these nested functions with nested parentheses. In F#, we actually would not write it like that. We would use what we call the pipeline operator, and it looks like this. It has this vertical bar with the angle bracket. Now, if you're used to Unix pipelines on the command line, it's exactly the same thing. It's taking the output of one thing and piping it into the input of the next thing. So, for example, I'm taking this x, and I'm feeding it into the square function, and I'm taking the output of the square function, I'm feeding it into the double function, I'm taking the output of the double function and feeding it into the add42 function, and so on and so forth. And you can chain more and more functions together to make bigger and bigger pieces of code. So this is the most common way of making bigger pieces of code from smaller pieces of code. And obviously, as they get too big, you might want to like put them on new lines. And so you can end up your code kind of looking like this, where there's a vertical pipeline rather than a horizontal pipeline. So this is very cool. Now, if you're used to LINQ in C#, you'll probably be familiar with this way of working, because LINQ works exactly the same way. So this is actually LINQ in F# because F# supports .NET stuff. So this is the LINQ select method, the LINQ where method, LINQ select, and so on. And we're just kind of transforming a list of numbers into various other things. And here I am multiplying each number by 2, and here I am filtering where the numbers are less than 6. Now this syntax here, the fun x arrow x times 2, that is the F# lambda syntax for lambda expressions or anonymous functions. And it's slightly different. Each language obviously has a slightly different way of doing it. In F#, we decided to use the fun keyword because fun is really important to have in F#, right? It's super important. So in F#, however, we would not use the LINQ approach because it's already built in with the pipe. So we would use this second approach much more than the link approach, which is basically exactly the same thing. I'm taking these numbers, I'm feeding it into this map function. I take the output of the lists and I feed it into the filter function. I take the output of the filter and I feed it into another map function, and so on and so forth. So I can build chains of functions in the same way that I would use if I was using link. So there is a difference between using link and using the F# pipe, however, because I think that the pipeline approach is actually a little more flexible. You don't need to create extension methods all the time. You can take any old function from anywhere in your code and stick it in the pipeline. So I've got two new functions here, one which just multiplies all the numbers together, and here it kind of logs it to the console. And I can just stick them at the bottom of the pipeline. Right here I'm putting the product one in, and here I'm putting the console one in. And as long as the output of the previous function matches the input of the next function, and they can be connected together properly, then it works great. And if the inputs and outputs don't match, you'll get a compiler error, which is very nice. So you're not going to make any silly mistakes that way. So this actually brings me up to talking about solid, right? So solid is these object-oriented principles, and you don't normally think of them as sort of functional programming principles, but they actually work really well with functional programming. For example, the single responsibility principle. Well, that is exactly, you can't get more single responsibility than a function. A function just does one thing. So the one I want to just quickly mention, though, is the open-close principle. So the open-close principle says basically you can add new code to something, but you shouldn't change existing code. Don't touch code that's working. You can add code around it, but don't mess with the code that's working. And that fits really, really well with this sort of pipeline approach to doing things. So let's say that I have my, this little piece of code I had here where I'm multiplying things by 2, and I decide that I really want to like productize this and, start have a unicorn startup based on this feature. How would I kind of make it more serious? Well, I would want to load it from a database, and I'd want to, save it to the database and add logging and so on. So this is what I'm doing. I'm just adding some extra stuff in front. I'm loading it from the database. I'm deserializing it. I'm doing my pure domain logic, serializing back again and saving it back to the database. And one of the things you might notice about this is it also fits really well with the onion architecture or the clean architecture, the hexagonal architecture. All these architectures have the idea that your core domain is in the middle, and anything which is to do with I/O or anything which is sort of non-deterministic goes on the outside. And functional programming, this fits perfectly. This is my I/O stuff, my non-deterministic stuff. It's very hard to test this stuff. My pure domain logic is very easy to test, to do unit tests. And then again, I do some I/O stuff. So I do an integration test would be the whole thing would be the integration test, and the middle bit would be the bit I would unit test. And of course, because it's a pipeline, I can do some other things. So let me add some logging. Okay, I want to log everything. So I don't have to change any existing code. Right, I'm going to follow the open-close principle. I'm not changing any code. I'm just adding new things to the existing code, but I'm not touching any of the original code. And I mean, I can do anything. I can literally put anything. Let's say it's really important that nobody is allowed to multiply by 2 unless they're authorized. So I'm just going to add an authorization step into this process. So as long as the inputs and outputs match, they all stick together. Now you'll see, I think later on, you'll see some web applications designed in exactly the same way. You take the input from the web, you check the authorization, you maybe deserialize it from JSON, you do your domain logic, and then you put it in the database and stuff. The web apps can be written in exactly the same way, because a web app is really, a web API is actually just a giant function with an input and an output. Okay, one more thing about syntax before we get onto the types. And I just quickly want to talk about how type inference works. So here is a function called add2. And notice that I've specifically said this is an integer, and I specifically said that the output is an integer, and so on. Now, this is another function which looks really similar. It does basically the same thing, but I haven't had any type annotations at all. And yet, it's figured out that this is an int and an int function. So both of them are exactly the same kind of function. They both have integer input and integer output, but one of them I annotated and the other one I didn't. And I don't normally need to annotate my functions. I would annotate them with types if it's like a public API and I want to do documentation, or it's like an interface or something. But in the middle of our code, we often don't bother to do the type annotations because it's just extra noise, right? So let me show you how it actually works, because a lot of people think it's sort of somehow it's magic. It's not actually magic. It's really easy to understand. So here is a very kind of silly function. It's called do something. There are two parameters. There's an f parameter and an x parameter. And the question is, what is f and what is x? And I haven't said anything about what it is, and yet the compiler has sort of figured it out. So the way the compiler thinks is like, well, okay, this is an int, 1 is an int. I'm adding x to 1, so x has to be an int. And F# is very strict about this. You can't add floats and ints together. So if you're adding something into an int, it has to be an int. Now, this y here, this is being added to a string. So y has to be a string. Okay. Now, f here is a function, and the input is x plus 1, which is an int, and the output is y, which is a string. So f must be a function that has int as input and a string as output. And if I test this, lo and behold, there it is. It says f is the f parameter is a function, the x parameter is an int, and the output is a string. So it's basically working just how we expect. What's nice about the type inference is it's dynamic. If I change this to a float, now if you can see the kind of tooltip thing here, it says it's now a float. Or if I change it to a string, now the input is a string. Or if I change this to an equal sign, so the output is now a Boolean. Are these two things equal? And if you look over here, you can sort of see that it's a Boolean. So it's really nice that it's sort of, very dynamic. It saves you a lot of time. Now, one other nice thing about the type inference is if you actually are if you're using this code, like here I have an int string function, and of course this has exactly this type that we want. It's going to turn ints into strings. So I can pass this in as a function parameter. Now, as soon as I change my code over here, I now get an error over here because it says, okay, this is not valid anymore because you're giving me an int string function and it's now wanting a float string function. And this is one of the nice things compared to something like Python is, you're getting compile time, you're getting immediate feedback if you've made a mistake. You don't have to wait until runtime. You don't have to even run any unit tests. It won't even compile if it's wrong. So you're getting, what I like about F# is it's got the sort of succinctness. It's concise. It looks like a scripting language because I don't have any types, but it's actually got this type checking that a statically typed language has, like C# or Java. So you're getting all the benefits of a static type language, but without all the noise of having all these extra types everywhere. And I'll just quickly go into a little more detail on that one, because people think of, not typing. It's like, I don't want to, it's less typing things out. Well, that's one thing, but like I said, the big benefit is actually less noise and more focus on the logic of what's really going on. So I've got an example of some C# code and some F# code. Now, this is the C# code for the group by method in the link library. And you can see there's the actual name of the method. And there's all this other stuff. It's an enumerable containing a grouping, which has two parameters, a key and a source and stuff. Now, the F# code doesn't have any of that. It just looks a lot easier to read. Now, it's just a statically type check. It's exactly the same type checking going on in both cases, but you just don't have to have it with the F# code. It just looks a lot nicer. It looks a lot friendlier to work with. So that's everything you need to know about the syntax and the sort of pipeline approach to programming. Let me just finish up with some types. So as I said earlier, you can do OO programming in F#, no problem. It's got really good support for OO. In general, though, we use the other type system that F# has, which is called the algebraic type system, or I prefer to call it a composable type system, because the way you work with the types in this one is you build up bigger types from smaller types, just like using Lego, right? So you take two things and you make a bigger thing out of them. So the first kind of type, or the first way of combining things in this composable type system is using AND. And this is really common when you're talking about things. You say first name and last name, right? Or you say email and address, or ID and description. So this is a thing, and it's got an ID and a description. So we use the keyword here is type, not class. And we use curly brackets or curly braces to define a record. Now, this is nothing special. Like almost all programming languages have a sort of struct, right? It's a struct. It's a class without any methods. It's nothing. It's really not unique to F# by any means. So, but I'll talk about another one in a minute, which is a bit more unique. So here we have our record type, and if I want to construct one, I construct it in a very similar way to the way I define it. So when I define it, I say :int. So that I'm telling you that's the type of int. But when I construct it, I just say equals. So I'm actually assigning a value to the ID field, and I'm assigning a value to the description field. Now, in F#, these records are immutable. You can't change them. So the only way you can change it is actually make a copy of it and change one of the fields as you make a copy. And the way you do that is using the with expression in F#. So I take the original one, and I want to change the ID. So I'm going to use this with. So it's the exact copy of the original one with this extra field change. Now, you might say, that's a lot of copying going on, right? All this immutable stuff is going to slow you down. It's going to be a performance problem. Actually, it turns out it's not really a performance problem in F#. First of all, with a generational garbage collector like .NET has, young objects that die quickly are actually collected very efficiently. So if you make a copy of something and the original one gets killed, that's actually more efficient than having an object that sticks around for a long time. But in general, C# and F# there's compiler optimizations and various things that go on that make it quite efficient. Now, if you're really into serious performance, you can do structs in F# just like you can in C#, and that puts things on the stack instead of the heap. You can do all the things like spans and all that stuff, the zero allocation stuff that you can do in .NET. You can totally do it in F# just like you can in C#. So that's nice. One more record thing I want to show you is this. Sometimes you see a curly brace followed by a vertical bar, and that's an anonymous record. So that's a record where there isn't really a type definition. You're just defining the type definition on the fly. So I'm saying this is a name and an email, but there's no proper type associated with that. That's very good when you're kind of exporting things to JSON or something like that. You don't really want to create a special type just to hold this complicated JSON. You can just define it on the fly. Now, the other type of composition in the F#'s type system is what I call a choice type, and it's when you combine things using the word or. So I would say a primary color is red or yellow or blue, right? Red or yellow or blue, and you use the vertical bar to mean or. And the technical word for these things is discriminated unions in F#, but I like to call them choices because it's a choice of these three things. Now, you might say this looks awfully like an enum in most other languages, and in this case, yes, but the difference is that in F#, these choices can have data associated with them. So here we have a color, and there's three different choices. It could be a primary color, it could be an RGB color, it could be a named color. If it's a primary color, it's one of these things. If it's an RGB color, it has the data associated with it is this RGB struct, which I just defined up here. And if it's a name color, the data associated with it is a string. So in this case, it's more like having sort of three subclasses, right? Each subclass has its own little data, and they all inherit from the same thing. It's not really like subclasses, but you can use it in a similar way. The difference in F#, of course, is this is 4 lines of code rather than having 4 different files with lots and lots of stuff in each thing. It's like literally it's all in one place. And I actually really like F# for doing domain modeling, business type domain modeling. And I'll show you, I'll just finish up with an example of this. Let's say you have requirements to take a payment method. And you say, okay, we take cash, or we take PayPal, or we take cards, right? Now, for PayPal, we need an email address. For cards, we need a card type. There's different requirements. Now, most people, if you wanted to implement this, you'd probably say, well, I have a abstract base class, or have an interface class, and I'll kind of create 3 subclasses that implement that interface. In F#, we wouldn't do it that way. We would probably do something like this. So here we have our payment method down here, and there's 3 choices: cash or PayPal. Right, I'm using the word or. Cash or PayPal or cards. And if it's PayPal, we need an email address. If it's a card, we need credit card information. Okay, so what's the credit card information? It's a card type and a card number. So I'm using the word and, right? So that's another way of building up things. That's the record type. And okay, so what's a card type? A card type is a Visa or a MasterCard. So by using choices, by saying and things and oring things together, I can actually build up a really sophisticated domain model in a few lines of code. And what's really nice about this is actually you can show this to non-programmers, and they can actually understand this. They can actually give me feedback. Did I miss something? So this is very, very clean, very easy to understand, but also very, very strict type checking, right? This is my domain model. I can't possibly, if I program to this domain model, I can't kind of have any errors. So I think that's pretty much all I have right now. So just to finish up, here's some things you can look at if you want to get moving on F# yourself. I would start at fsharp.org. There's a lot of good data there. That's the F# the kind of focus for the non-profit, the community side of F#. The Microsoft docs are good. I would recommend, if you're into F# is to join the F# Slack. You have to join fsharp.org, but it is free. But that gives you access to the Slack, and there's really lots of good information. People are very beginner friendly there, so don't worry about asking silly questions. If you're on Twitter, the F# hashtag is the place to go. If you tweet F# hash F#, you'll probably get lots of feedback from people. And finally, there's lots and lots of blogs and videos. For example, if you Google my name, if you go onto YouTube and look for my name, you'll see all my videos. And if you go to, following me as Isaac, and if you look for his name on YouTube, you'll see all his videos. There's lots and lots of good stuff out there. So have fun with that. Thanks for joining. I don't think we sort of run out of time for questions, but do ask your questions on Twitter, and I will get back to you on Twitter. Lead you to anything. So,
oh my gosh,
thanks very much.
Wow, so much really good stuff that you covered there. And I'm seeing some comments from folks out in Twitter that are excited to try out some things, some great feedback and commentary from folks. I'm going to share my screen here real quick so that I can share and show a little bit of what folks are saying about. There we go. All kinds of stuff folks are saying out there under .NET Conf. Hashtag .NET Conf. You can ask your questions out there. Folks like Scott will answer your question. We've got some other moderators that'll help pull some of this together. Some great comments that I want to call out here real quick. Like Angel writes, Lambdas and F# are fun.
That is true. Fun is very important.
Absolutely. There was a really good question that came in from Vineet. Can we make mutable functions in F# since functions and values are the same thing?
You can't make a you can assign a function to a mutable value. So you can have mutable values in F#. You have to ask for it with the mutable keyword. But it's really weird. I mean, it turns out when I first started learning F#, I thought, well, how can you do anything without mutating values? That's just ridiculous. You can't possibly program without that. It turns out that you can. And it's actually really cool. Once you get the hang of it, it's actually amazing. And in fact, mutability becomes almost like a code smell. Sometimes you need it for performance or various things. But in general, if you see the mutable keyword, that means that you can probably rewrite it to be better than that. So it turns out you can actually write whole applications without using mutability anywhere. And that's awesome.
Very cool. Well, you're right. We are out of time. Thank you so much, Scott. Like I said, there's questions out there under hashtag .NETConf. Folks can ask, and we'll be triaging and sending them along, bringing in our speakers to answer out on Twitter and hopefully here on video. Scott, I hope you have a great rest of your day.
Thanks, Jeff.
And I will dismiss Scott. Take care.
See you later. Bye, everyone.
And let's get ready. Let me bring on our next guest. Our next speaker is going to be joining us here. This is Isaac Abraham. Let me bring on Isaac. There he is. Hey, Isaac. Let me see. You are on mute on this. There we go.
Myself. How you doing, Jeff? Great to see you.
It's so good to see you. My gosh, I haven't seen you since MVP Summit 2 years ago. Thank you so much for joining us today.
Great to be here. Super excited to be taking part in it today. I love these. They're so enthusiastic and full of energy.
Oh yeah. Oh my gosh. And you're going to be talking about a topic that I'm really interested in. You're going to be talking about web development.
Exactly. Yeah. It's like most people don't think about that when we think about F#. It's all back end and data science. But I want to show and maybe get people enthusiastic about doing web apps in F# as well.
Oh my gosh. Let me bring up your screen here and I'll give you the stage. Thank you so much, Isaac.
Brilliant. Thanks, Jeff. So so modern web apps with SafeStack. So really what I want to do in the next 20, 25 minutes is just get you excited and maybe open your eyes to seeing web applications in F#, something you may not think is really possible, and just really show you just how far we can take it. So what is SafeStack? Really the first question. So SafeStack is what we think is the best way to write functional first web apps. So apps that take advantage of all the stuff that Scott was just showing. I was so happy he's just done his talk because it saved me so much work having to talk about some of the language constructs. But if you think about all of the stuff that he's done, and then how can we put that into the web, but still using those nice things like immutable data, union types, records, and all of that. So I'm going to jump straight in with a really quick demo, just for a minute or two, and then we'll jump back to some slides. So let's jump into my browser. So this is a web app that's hosted on Azure on the app service. So if you're using Azure already, app service is pretty much the default place that we would use web apps. And this is an app written in F#. And it basically lets me search for properties that have been sold in the UK. So I can do things like type in a particular city, I can hit search. That's going off to Azure Search to actually get some results. I can do things like hitting here and doing searching and sorting and so on and so forth. I can do things like click on a button and get a modal dialog. And I've got some Google Maps integration here where I put a little pin on. I can close that down. I can click on a postcode. So for those of you in the US, that's like a zip code. And I can do things like show me only properties within a particular geographic radius, 20 kilometers of that one. And then I can click on map and it will show me all of those. I even get things like typing here. So here I'm typing in a zip code or postcode. And as you see the search button, if I type in an invalid postcode, I'm actually getting, as I type, some validation is happening here. So this is not actually going back to the server. This is not something like Blazor where we're going back to the back end. This is actually doing validation in the browser. And yet this entire app is in F#. There is not one line of handwritten JavaScript at all on the front end, and there is no C# on the back end. So what I'm just going to do is jump back to the slides and just talk a little bit about what is really going on there and how is that made possible. So what is SafeStack really? So the acronym is basically four things. Saturn, which is a server-side web technology that sits on top of ASP.NET Core. So if you're an ASP.NET developer today, then this is effectively exactly the same runtime, the same high performance, the same reliability, the robustness that you would expect, but with a lovely F# layer written on top of it. And the A stands for Azure, which is, it can, to be honest, be anything, but we recommend Azure as like the platform services and how to host. We think it's a really good place for .NET. The F stands for Fable, which is a technology that compiles F# into JavaScript. So you can write F#, basically the standard F# that you saw Scott writing, but yet it will run in the browser. So it takes away that whole sort of fear of, I'm an F# dev, how do I write code in the browser? And then Elmish is this beautiful pattern, which I'll show you a bit more about in a minute, that is really a functional programming model for the web. So you may know MVC, or you may know MVVM if you're a WPF programmer. So Elmish is a pattern called MVU, which you may be seeing more of, to be honest, in .NET 6 with things like Maui using it as well, which is a really nice programming model for functional first development. So why would I want to use SafeStack? So firstly, it's super productive. You can focus on F#. You don't have to worry about JavaScript in the browser. You can also share code between your browser and the server. So you can write a type once, a record, and have it emit to JavaScript in the browser, but still run as .NET on the server. So you don't have to map between the two yourself. Happens for free. And you can also write code, validation logic, like the postcode validation I showed you before. You can have that on the client and the server without you having to do anything. I think we're getting to this word fun quite a lot, as Scott sort of alluded to earlier, but it's a really enjoyable way of writing applications. Really rewards you, lets you focus on getting stuff done. It's really flexible as well. So unlike some other libraries and frameworks, Safe is not a walled garden. You can use any JavaScript library that you want out there. You can interop with it very easily. And on the server, you can use any NuGet package because F# is just .NET. So you can use any C# NuGet package as well. And it's a safe bet that that is not intended to be a play on words there, but it's really mature platforms. We're targeting .NET Core, .NET 5, backed by Microsoft. We're targeting React and JavaScript, which is so popular. You know, Facebook are helping with React. It's got commercial support. So it's a really good place to be if you want to write web apps. So just to elaborate a little bit more on that quickly, so we're taking two popular and mature platforms, ASP.NET on the server and JavaScript and React on the client, but then we're tying them together like a thin layer on top with F#, which is simple, it's succinct, it's robust. You've heard that already a few times, but that's really what it's doing. So one small architectural diagram, and then we'll probably move on to some code in a minute. So you can think here, we've got F#, and then we have these two compilers. We've got Fable on one side, and we've got the standard F# compiler for .NET on the other side, ASP.NET Core and .NET 5, and JavaScript and React on the other side. I can put these slides online, so if you want me to go back and look at them later on, you can definitely do that. Single code base, I sort of touched on this before, but effectively we have F# code. So your types, your records, your unions, tuples, and your functions, shared validation between client and server. Then on the left hand, we've got .NET compiler, boils down to .NET. On the right-hand side, Fable, which boils down to JavaScript. But your code at the top will be the same across both if you want. And you can choose which bits to share and which bits you don't want to share. So I'm going to jump into another demo now, where we'll actually do a bit more coding for a few minutes. And hopefully you can see the sort of the development experience and what that looks like. So just before I do that, if you're interested in finding more about the SafeStack while I'm doing this, SafeStack GitHub.io, you'll see here the full website. We've got a demo that I just showed you. You can look at the doc site, where we have a huge amount of documentation, how to do features, a load of recipes for doing common tasks, all sorts of great resources there. So definitely recommend having a look at that. The last thing I wanted to show you was this Elmish pattern, which is what I'm about to show you in a second. So where I talked about MVC and MVVM and all those sorts of patterns, the MVU, or this Elmish equivalent, is really, really beautiful. And I'll show you this in practice in just a moment. But we effectively just have three components, or three abstractions, or things to understand. We have a data model, so the sorts of information you're capturing on your page, on your web application. We've got a view, and we have an update function. So we create a model, which is our application state, and we give it to our view function. And all it has to do is say, here's the state, what should the application look like? What should I render on the screen? Should it be a button, or a list, or an input text box? Should it be disabled, and so on and so forth. And then we'll get events from this UI, button clicks, people typing on the keyboard, and that will then update the model with some logic, depending on the type of event that occurred. So keep that in mind when I'm showing you this, and I'll refer back to this in the coding demo. So how do I create a .NET a safe application? So thanks to .NET, we now have these things called .NET new templates. And this is on NuGet, so you can go straight to NuGet and look for the safe template, and you can install it. .NET new install safe template. Once you've got that, I'll jump into VS Code now. Jeff, if this is too small, just ping me in the chat and I'll increase the font size. I'm going to say here .NET new list. And we'll get a list of all of the different templates here, one of which will be the SafeStack web app. So this is what you'll see after you install. Once you've got that, you can type .NET new safe. And this will give you a safe application out of the box. So I'm just going to restart code with that folder. We'll see what we've got here. So it's created a full stack application for me with loads of files that you don't have to really worry about. But it's got all of the dependencies for the client side, NPM packages, all of the NuGet dependencies for the server. It's created me some test client libraries. I want to do unit tests. It's created me a client project for the browser. It's created me a server project for my backend. Both of these are F# projects, you'll notice. So there's no JavaScript here. The only JavaScript you'll really have to do or see is Webpack, which is a technology for those of you that aren't web developers for bundling your JavaScript application together. But everything else will simply be standard F#. So all the things that Scott's told you about, the main modeling, type safety, type inference, you'll get the best of them on both the browser and on the server. We also have another project here, which is worth just spending a minute on, which is called shared. And this will contain any functions that are shared across the client and the server. So that might be types, that could be validation logic, that could be contracts, as I'll show you in a minute. Then we have our server, which has got ASP.NET on it, and our client side, which is doing the JavaScript work. Now, in the interest of saving time, I've already started the application up. I'll just show you what that looks like here. So let's jump on to save template. So when I hit .NET Run, and that is all you have to type, .NET Run, you'll get a full application that's running, which has got some logic, which is basically a to-do application to get you started. And we can type in things that we want to actually add into our to-do list. So learn all about safe. I can hit add here, and it's going to add that into the list. All right. So learn all about safe. There we go. And you'll see that we get, again, sort of validation logic. So that if I delete all the text here, I can't hit the add button because I've not typed anything. This is just using standard React components and JavaScript libraries. There's nothing bespoke in F#. We're just using F# as the programming language here. So now I'm actually going to do some actual coding, and you'll see me making some changes to this app as I go through it. So I've got my application here, and I'm just going to show you it's exactly the same as really what I just defined a moment ago. It's running here in the background. You can see at the bottom here, we've got ASP.NET listening. So this is indeed a normal ASP.NET web application. So what I would like to do, and the challenge here is, I'm going to take you through the app and how it looks, and then I'm going to add in the ability to clear all the items from the list. Nothing too drastic, but enough that you can see and get a feel for the programming model. So let's start from shared. I have a type here, a normal record that is a to-do item. So this maps to the item that we see in the browser here. Each one of these is a to-do record. And we have what we call a contract between the client and the server. So these are the operations that I can do between the browser and the backend. So I've got two operations, get to-dos and add a to-do. So when the app starts up, it's going to call the get to return all the items. And when I hit add here, it will add it to the backend. And what's happening on the backend? So let's start at the bottom and work upwards. Here I've got the implementations. So this is the server side. What happens when I call get to-dos? What happens when I call add a to-do? When I call get to-dos, it's going to look at this module called storage, which is just above, and return me the contents of this in-memory list. We're not using a SQL database or anything like that here. We're just using an in-memory list to start with. And when I add a to-do, it's going to do some validation. If the validation passes, it's going to then add it to that in-memory list. So nothing that if you're a .NET developer, nothing you wouldn't have seen before, really.
Hey,
on the client,
can you just bump up the font size one click?
Absolutely. Let's try that.
Thank you.
Great. Thanks, Jeff. Let's jump into the client and just have a look at that. But this is where things get a bit more interesting. We've got the notion of the model that I touched on before. So I've got a list of the to-dos that I want to display and the input string. So that's the input of this content here. So I've got 4 items in my to-do list and an empty string here. And then I've got some client-side messages, got to-dos. Whenever I set an input, this is a message that's going to pipe to our system, adding a to-do, what happens after we added a to-do, and so on. And then we have to use this pattern matching in F# for what to do when each of these messages get fired. So this is our update function that I touched on before, which says, given some message and an existing model, what should I do with the model? So for example, whenever we want to add a to-do, I'm going to reset the input text to empty and then go and save the to-do back on the back end. And when it comes back, I'll add that item to the list. Or if I want to get the to-dos, once I've received them from the server, I want to add that to the model and update the model. So this is using the same sort of syntax that you saw Scott talking about before with record updates and so on. And lastly, we have our view. And I'll just skim through some of this. The important thing here to see is that this is not anything apart from F# code. This is F# code, which is wrapping around an existing JavaScript library called Bulma, which is for styling. but it gives us nice, strong typing here. So I can type Bulma and I get IntelliSense for all of these HTML elements and React elements. We don't have to use Bulma. I could use whatever styling library I wanted. But this is just one that comes out of the box with SafeStack. I can see things here like a button, for example. I want a button, which is the primary color. It's disabled if the text is invalid. On click, I want to fire off an add to do message. And I can do things here, and I'm going to actually switch to a side-by-side view here. One of the nice things we get because we live on JavaScript is we get hot reload for free. So let's say I'm typing here, and I want to change the add to create. Save that. The browser will automatically update, and I won't lose the state. It doesn't restart the application, just carries on. So I'm going to try and add in a clear button now. Try and clear the items from the application. So I'm going to start with our messages, our core domain. I'm going to add a message called clear. So when we receive this message, we have to clear all the items in the to-do list. Straight away, the compiler is going to now tell me that I've actually got to do something here. We get this warning here. Incomplete pattern matches on this expression. The value clear may indicate a case not covered by the patterns. So the compiler is actually letting me know you've added this new case in, but you're not handling it. Please handle it. So I'm going to add a new handler here with a little refactoring, and now I have to know what to do with that. So in this case, I'm simply going to clear out the list of items in the to-dos. And say to-dos equals empty list, and there's no further sort of processing to happen, so no command. The last thing to do is now hook that up to our UI. That's actually relatively easy, believe it or not. I'm going to copy all this code and paste it to create a second button, and side by side. And what I'll do is change the message to send the clear message when I hit this button, and I'll change the text to be clear. I'll save that, and now we've got two buttons. And let's change the color to warning while we're at it. Now we've got a warning button. Click that, items are cleared. So that's kind of the client-side loop. We've still got a few minutes left, so I'm actually going to try and go one step further and actually hook this up to the back end, because currently if I refresh this, the app's going to go straight to the server and retrieve the items from before. So I only cleared it on the browser here. So let's actually hook up some client-server messaging. And believe it or not, I can actually do this relatively quickly. So I'm going to add in a new message to our shared contract. So this is the interface between the browser and the backend. I'm going to call it clear, which will take in nothing. So we call that unit. And it's going to return nothing as well, asynchronously. Now the server's going to break because it's going to say you haven't provided an implementation for this. You have to provide an implementation for our clear method. So let's go back here. This should break. I can type clear, which is going to be a function that will asynchronously simply clear out this list here. So let's try that. Save that, and hopefully that will compile. So we've got our server implementation now. Now we just have to call it from the client. And there's no need for me to worry about creating what route do I need to hit or anything like that. I get all of this strongly typed. So all I'm going to do is when someone hits clear, I'll make a call to the backend that says fire off the clear method. And when I hit doc here, you'll see we get IntelliSense for clear. It knows now there's a new method. Hit save. Browser's updated. Hopefully now, if I hit clear over here, let's just refresh this. Now I've reset that, and every time I refresh now, it's actually done it on the back end as well. So there was no need to worry about setting up the correct routes or sharing types, making sure the JSON matched or anything. That's all taken care of for me, all out of the box. So it's just a pure F# experience across the browser and the server. Got a couple of minutes left before I want to hand back to Jeff just to see if there's any questions or any comments. So I'll just show you a couple more things. One thing we have in this that's really, really nice out of the box is, you remember I mentioned Azure? So we also support Azure out of the box. So we have the ability to deploy this web app using a technology called Farmer, which uses ARM templates. So if you've used Azure and done any DevOps work with it, you'll be familiar with the notion of ARM templates. We will generate an ARM template for your web app and deploy it into Azure. You would simply have to type .NET run Azure. That will do everything for you. And just to prove that, I did this just before. Just to save time, I'll show you it now. So I'm going to jump over here, and we'll jump into Safe Template. And if you go to .NET Conf Safe AzureWebsites.net, you will see the exact same app that I've just created running in the app service. I've done nothing else apart from write .NET Run Azure. And just so you can see that it's actually really running, we've got things like App Insights hooked up. So whenever anyone hits that URL, I'll see little pop-ups here with little hits of the website. All out of the box, this is standard Azure stuff, but running with F#. We get a normal resource group, all the stuff that you would expect to see in a normal ASP.NET web app, but we've also got here in Azure as well. I think that's pretty much it, what I wanted to go through. I've got a few minutes left. Jeff, we've got any questions or anything you'd like to chat about?
Hey, Isaac.
Hey.
You know what? We do have a couple of really good questions coming in from Twitter. Let me bring that up and we can take a look at some of the questions folks have. There we go. So over here, let me start with this question from Giorgio asking, is CSS easy to integrate in the Safe Stack?
Absolutely, great question. So out of the box here, I'm actually using a CSS framework called Dormer, but you can create your own ones. There's even a special type provider, which is a feature of F#, that will let you reference CSS and get IntelliSense in F# for your CSS styles. So yes, absolutely.
Oh, that's really cool to see. Has anyone managed to use F# and F# autocomplete on a Unix OS? Have you done much work with F# on a Unix-based OS?
I personally haven't, but autocomplete should actually work as far as I know, because Ironide, which is the tool that's running in VS Code to give me IntelliSense, that's actually, as far as I know, using FS autocomplete in the background.
Yeah.
So I believe that should actually work on Unix. I'd be interested if you want to give me a message, though, DM me later. Be happy to chase up with you on that one.
Very cool. Let me grab this question from Vili asking, I understand Webpack is not needed anymore, but it's there in the Safe template. Are they misunderstanding what's going on there?
No, that's absolutely right. So you can use Fable to generate your JavaScript without using Webpack. The reason why we're using Webpack in this demo is for things like the hot module reloading, hosting our application locally in a dev server environment. But you absolutely don't need Webpack if you want to do bundling yourself or not at all. Absolutely fine to do that as well.
Cool. Very cool. Gareth has a question here. How does the Elmish model scale to multiple pages or panes?
So it's actually a relatively simple model, this kind of MVU pattern that scales simply. There's a bit of boilerplate with the default sort of model, but there are certainly extensions that you can use that will make that much more succinct as well. But you don't need to know these extra hooks to write multi-page apps. Out of the box, it works just fine. Once you grow a bit larger, you may want to invest a bit more time in learning some more tricks about how to make that a little bit more succinct.
Okay. I see a couple more questions have come in here, but I want to grab this one from Nico because this got me interested also. What is it you've got there? You had those really nice lanes for the tab indentations there. What's that extension you're using?
Yeah, so that's called Indent Rainbow. Every time I go to talk, someone asks me about that. It's super useful in F# because F# is in the white space sensitive. So if you accidentally do this, it will actually highlight in red. You've got the extra space there. So yeah, definitely worth doing. I know that we're not showing the screen. I've just seen that, Jeff. Don't worry. But absolutely. So Indent Rainbow, and there's another one called Rainbow Brackets, which will highlight the bracket indentations with different colors as well.
I got to imagine folks who use Python would be very interested in that, right? Because they're space sensitive as well.
Absolutely.
Yeah. There was a question here. Dimitro has a question for us. Can you point to an example of a larger application where number of messages in the front end became too much for a single file and the update function was split into a module.
Absolutely. So the example app I showed you, the safe search with the property searching, that's online. I'll send the GitHub repo onto .NET Conf hashtag, and you can have a look through that as well and see how we've done it. But there are plenty of apps on that. The Safe Docs website that I showed earlier will also have a number of applications there that are multi-page, so you can see how to do it there.
Oh, very cool. Let me see here. How hard is it to change safe to deploy to another target other than Azure if you want to use another cloud provider?
Totally fine, because it's just ultimately JavaScript and a .NET application, so any platform. We also have recipes and guides on the web, on the Safe Docs for working in Docker. So once you're in Docker, you can host it anywhere, AWS, a few other places. So yeah, totally fine.
Very cool. And I think that just about does it for the time that we have together to be able to talk through some of what's going on there. Thank you so much, Isaac. I really appreciate you joining us for .NET Conf.
Brilliant. Thanks for having me on. Take care.
All righty. You have a good one. And we'll say goodbye to Isaac there. Thank you so much. Wow. There's a lot happening there around the web space that I really want to drill into. And as a web developer, now I'm interested to see how a little bit of that works. But you know what? I want to bring on my friend here who's going to pick up the hosting duties for a bit. Let me bring on, this is Jamie Singleton. Hey, Jamie. Good to see you.
Hey, Jeff. How's it going?
Oh my gosh. F# is one of these topics that I've always wanted to dip my toes in, try out a little bit, and I'm getting excited with a little bit of what I'm seeing here between Scott and Isaac, a little bit with Don this morning. I'm seeing some stuff that I want to learn more about, and you have a session coming up tomorrow, don't you?
I do, yes. F# is a hot topic this month. We've had tons of content coming out for it. And for those who are also looking to interested to get started with F#, really from the basics, we do have an event tomorrow, 8:30 a.m. Pacific, called Let's Learn .NET F#. And you can register right there. It's a completely free event, and we'll walk you through the brand new Learn modules that were just released and published. So we have tons of new content for you all.
Awesome. Well, I'm going to step away and let you take over hosting duties for the next little bit, and we'll catch you later. Thanks so much, Jamie.
Amazing. Thank you, Jeff. All right. Hello, everybody. I am so honored and excited to be here with you all. Thank you for joining us. Let's get started. So that was amazing, Isaac. Thank you so much. It's really good to see how F# actually does work building modern web applications. It's not just for data. But speaking of data, I am joined here with Kevin Schneider. Let me see if I can bring him up. There we go.
Hi there.
Kevin. How you doing?
I'm fine. How are you?
I'm very well.
Very excited today.
Good. Me as well. So as I mentioned, you're here to talk to us about productive data science in biology with F#. So what's that about?
Well, I'm kind of trying to make like a roundhouse kick and show multiple topics where we are using F# to be productive in science. Not just only data science, but also some HPC stuff. So maybe some people are interested in that. I hope so, at least.
Yeah, I mean, I'm definitely intrigued. So let's get started. Let's go ahead and bring up your screen
Give me a second. So I'll share my screen. Here we go, the second one.
Yes.
All right. Are we live?
All right, perfect. We are live and ready to go. I'll let you take it away.
All right, thanks for having me. So I'm Kevin from Germany, and as already said, excited to share with you some insights on how we are using F# being productive in all kinds of research, basically. So I am a PhD student at the Computational Systems Biology department in the Technical University of Kaiserslautern. And in biology, you have these kind of two facets of researchers, where you have those wet lab scientists that are usually working in laboratories in the lab coats, performing all the complicated experiments that we in the dry lab, working behind the security of our computer screens, can then analyze. So we really appreciate the data there, but we like to stay a little bit more safe there. So what kind of data are we working with here? So we are really fascinated by plant organisms because they are sessile, so they can't move away. So they are exposed to their environment all the time, and they can't change what will happen to them. So especially in the context of climate change, it is really important to understand how plants can cope with change in environmental conditions that can happen on the timescale of days or even hours. So in a more abstract sense, what we are looking at are plants that have to react to environmental conditions and some kind of change their molecular composition to that, because in this time scale of like days, you can't just grow new leaves that will cope better with cold conditions. So the plant has to change that on a molecular level. And how can we measure that? So this is where our friends, the wet lab scientists, come in again. So the usual experiment that we'll perform here is that we are taking plants from their like normal, let's put it like that, conditions, sample a few times from them, and then they apply the condition of interest, for example, increased light intensities, and then we create a time series of data sampled from this here. And as you might imagine, the data or the samples taken here are not as simple as these colored dots here, but depending on the type of molecule that we are measuring here, and these days we are actually trying to measure all molecules in there, you can get terabytes of data just from one of these samples. So you have giant amounts of data in this kind of time series experiment. And what we are doing is we are developing methods to extract knowledge from these kinds of data sets. Why am I here telling you about our research here then? Because we are doing all of this with F#. So you can categorize our research basically in these 5 pillars here. So we are teaching because we are part of a university, we are a research group, so one of our responsibilities is teaching science. And these 4 other pillars here are kind of more interconnected with each other. So as I said, we are developing these methods for analyzing these kinds of data sets. Then for sure, we are performing data analysis with these methods, if they are mature, for example. And more often than not, these data analysis pipelines that we are building here and then up as, for example, as a web service where users have to put in their data and they get out the results that our pipeline produces, or tooling for open science to make this available for everyone, especially in a high-performance computing context. So you can imagine that you need a large amount of computation resources for handling terabytes of data in such a data analysis pipeline. Okay, so let me first focus on teaching because this is a little bit more decoupled from the rest, as I just said. We are basically teaching F# as the first programming language for many of our students for scientific programming. We are also offering advanced data analysis and project work. And what really helps us here is the robust tooling that is there in the F# ecosystem. So what we really love is the FSDocs tool. This is initially thought of as a tool for creating documentation for F# libraries. But you can also create, beside the HTML documents that contain this documentation, you can also create .NET Interactive notebooks with that tool. And this is where it gets really interesting for our teaching purposes. So let me show you what I mean with that. I'll switch to my browser here. So this is an example. It doesn't matter in detail what stands here, but this is an example of the output that FSDocs can provide us with. So you have contextual text, code blocks here. You have also interactive visualizations that you can put in here. And the really awesome thing is here, besides, as I said, this HTML file here, you can also get notebooks. I already downloaded that one here. Kind of looks exactly the same. But you can change the code that you have inside of here. So for example, if you don't like the style of the visualization here, because I would like to have a dark mode here, I can just go inside there. I can't do that on the HTML page, and use a template. This is plotly.net, by the way. I will shortly go into more detail about this library. So I will use the with template function, and I will use the dark mirrored one, which should fit, should fit better inside here. So these notebooks really help to give a more hands-on approach and for teaching programming. And as you can see, you can directly change the output that is produced by these code blocks. So let me show you a more simple example of what you're doing with FSDocs. So in FSDocs, you use these so-called literate F# scripts. So I have an F# script open here, and you can open Markdown blocks with these parentheses and asterisks here. And you can will also get Markdown syntax highlighting inside here. So this is my Markdown block. I just have this header here and some text. And then I can go on and write F# code. And I can also include the output of this F# code here. And if I then run my FSDocs tool here with the evaluate flag, because I actually want to evaluate this F# code here, I will get in a second a local hot reloadable version of that website that is produced here. So as you saw here, this is the output of the Markdown block. This is the F# script, and this is the evaluation here. And I can simply go here and change the value, and then I will have a hot reload here and see what I have changed. So this is basically how you can then scale up, let's put it like that, and build these kinds of more complex teaching modules. All right, let's go back to the presentation here. And I will now focus more on the data science part of our work. So for both of these pillars here, method development and data analysis, what is really the outstanding property of F# is that it is an amazing prototyping language. You can get going really fast with F# and get into something that I would call here iterative scripting cycle, where you have this scripting environment. You can directly execute code inside there and get productive really fast. And what is also helping us here on this side of this visualization here is the FSLab toolbox. And Don in the keynote already spoiled a little bit. I will focus on FSLab a lot right now. So what is FSLab? FSLab is thought of as this center of gravity for data science packages in F#. So if you are coming from a R background, think tidyverse, but in F# with F# projects for F#. And the basic idea is that you can perform all of these data science tasks in the cycle here with F# projects. So you can import data. Usually you then read it with some kind of data frame library, have structured data, do some transformations on this structured data, visualize the results. Maybe now you want to model this data to make some forecasts, for example. Do some ML here, import some new test data, transform it with the model again, visualize the forecast, and so on. You can go forever inside here, right? So my point here is we are already there. You can perform all of these tasks with F# libraries. You can stay inside of F# during this whole cycle. So for data import, we recommend the F# data library, which has accessors for multiple data sources. What I personally using it most for is access of HTTP resources, so data downloading from the internet inside a script. For the data frame part, we have the DDL library, which actually does this transformation, but keeps the original data immutable. So you're actually creating a new data frame with your transformation steps. And I think this is a really unique approach to the data frame concept, and fits perfectly in this environment of F#, where you have this robustness coming from the type system. For visualization purposes, we recommend using plotly.net for all kinds of 2 and 3D visualizations. I'm actually the co-maintainer of that library. People coming from a Python or R background most likely know the Plotly library. It is an amazing initially JavaScript library for visualizing data. And it has many language wrappers around them. Plotly.net is the one that I myself, besides others, are maintaining for the .NET ecosystem. For graph visualization, for network visualization, you can use scikit.net, for example. On the model side, we have some more libraries. Directly recommended in F# from our side is the F# stats library, which is a multi-purpose project for things like statistical testing, signal detection, and also light ML tasks, such as, for example, clustering. For linear programming and optimization purposes of those systems, you can use the Flips library. I think there's a talk later today from Matthew, the mathematical planning talk, I think, or suspect he will use this library there because it's from him. And on this side here, there are also established libraries that are on the .NET platform, written in C# that you can use from F# as well. So for example, ML.NET can't talk about data science in .NET without mentioning ML.NET, right? You can use that from F# very well. As well as the SciSharp stack, which is an effort to port the SciPy stack to .NET, but these are written in C#. We are focusing more on the F# libraries here. You can also head over to fslab.org to get more information about fslab. Let me show you the website real quick. What I think is cool about this here is here's the packages page. And we are also providing you, for example, with scripts to get you started really fast with those libraries. And we are also providing basic tutorials for doing data science with F#, also tutorials for getting started with F#, no matter if you want to perform data science afterwards or not, and also some more advanced blog post style articles here. And this is, you might already think, also built with FSdocs, so you can download these tutorials as interactive notebooks without problem. Okay, so this is FSLab, and we are using it heavily in this iterative scripting cycle environment. Let me show you a quick example of data analysis where I read such a data set that I introduced to you in the beginning, a time series of a plant in changing conditions, molecules measured from that, not terabytes, but some smaller data set, and then perform a quick analysis with it, and then visualize the result. So this again here is my Visual Studio Code window. Usually I start with referencing the libraries that I will be using. I will use F# data to read data, Beadle, the data frame library, to read this data as a frame, F# stats to perform my analysis, and plotly.net for visualization purposes. So I'm binding first my data source here. This is an online data source. This down here is the interactive console where I'm sending code down there, for those of you who have never seen this. The first thing I'm doing now is I will read my data frame from that data source after I have gotten the data source with performing a HTTP request here. And then because I know this data set, I know that this is the indexing column, so I will already index my data frame here. You can print also this data frame to get insights how the data looks like, but at the zoom level, it will look really bad. Let me check if I can. Wait a second. Yeah, that looks better. So this, I think this was the layer I was in before. So here I have my data frame printed, column keys and row keys, and the structured data inside of this data frame. It has, by the way, 18,000 rows. This is corresponding to all of the molecules measured in this experiment over 11 time points. So we are handling time series data here. So what I will do then next is from the F# stats library, I will use a method called surprise analysis. You can also see that down here, which gives me the main components of my system of interest here, so my plant system, and the dynamics of how they evolve over time. And for that, I will initialize a linear algebra service here, because I will use highly optimized linear algebra native libraries for that. And it's just like that, extract the data out of the data frame to a jagged array and transform that jagged array to a matrix here. And then from that, compute my surprise analysis. Should go really fast here. What is then left of this record type? I am accessing this field here. This is where my information is stored in. I again get out of this matrix from F# stats, and then I will map over each of those components. Those will be 11 for each time point 1, and create a chart with plotly.net. Here, just a simple line chart where my XY values will be the values inside here, indexed just by their position in the array, so 0 until 10. And I will name them according to their index, basically, here. And then I combine these 11 charts and render it in the browser here. So what I can tell you from experience here is that this method, it's a little bit like PCA. The first component here is the one that captures most of the noise, so we will ignore that one. And I can also tell you from experience that the first 3 components are the most interesting. So what you can see here is the most prominent behavior of the molecules in our data set over time here. And let me just make the chart a little bit nicer real quick. So I will use a template here as well, as I used before. Here I will use light mirrored because my browser has a light theme, and I will also give this one a title. Oops, with title it is. And I will call that one main components dynamics. Let's put it like that. Here we are, looks quite nice, but I would still like to filter out these components. So I will, at this stage here, skip the first one. Oops, and only take the first 3 of the remaining ones. So, and this is what I mean with iterative scripting cycle here, right? I visualize my result, I go back and forth until I'm happy with what I am showing here, and this looks kind of nice now. So yeah, this is how we perform this iterative scripting with FSLab. So let's step away from this side of the chart here and see what we are doing then if we build these data analysis pipelines. So what we are doing is, first we are creating web services for everyone to use these data analysis pipelines, but these are not very interesting because this is just a text box where people can give the input, then press on run, and there's the output again. For that, we are using the SafeStack and Fable mature ecosystem. You heard lots about of this in the previous talk. It's just awesome. I actually learned web development, I think 3 or 4 years ago in this stack. I have never written JavaScript before, basically. Yeah, but these web services are really simple we are using here. But what we are also doing with Fable and SafeStack is Office add-ins. Let me show you that real quick and why we are doing that. So if wet lab scientists, as I just showed you, perform a experiment in the lab, they have to keep track of as many experimental parameters as possible, because they can have an influence on the result that we get out of the end. So we have to keep track, how much light was this plant exposed to? What was the temperature at any given time of the experiment? What was the length of the day cycle, the night cycle, and so on? And in the past, wet lab scientists usually track these kinds of metadata in handwritten notebooks. And this is part of a large grant where we are part of in Germany currently. What we want to change, we want to enable all scientists to create digital structured metadata. And therefore, we created or one of the tools we created for that is let me switch to Visual Studio Code real quick here again, is a Excel plugin where we are using SafeStack to do this. Let me first sideload the app real quick. So here we go. This is the web service that is created by our SafeStack application, and we are using the Office.js API to handle the Excel side of things. So for example, to get started with annotating my experiment, I will create a annotation table here. And then for my purposes, because I just talked to you about plant growth, I will use the template that is provided here, select that one and insert it here. So, and this creates a huge table that I can now fill with metadata about my sample. And the important thing here is, let me zoom in a little bit maybe here. The important thing here is what we can fill this here is not just free text, but what we are using for here is ontologies, so controlled vocabulary. So every time I am inserting leaf here, for example, it will be the same term, leaf. Doesn't matter, doesn't matter, what's going on here? Here we go. It doesn't matter if I write it with a large L or something like that, it will always be the same term. And what you can see here, we are automatically adding machine-readable information to these columns here. And this is very important because we later want to be able to perform meta-analysis based on these structured metadata. Okay, so this is the kind of web service tooling that we are also doing or creating for the science community. Let me also talk about, I think we have a few minutes left here, about open science tooling in the context of making really complex data analysis pipelines available for everyone. Because, right, you can create command line tools, Docker containers to execute them everywhere, but this might still not be enough for everyone to be able to use them. So an example that I will take here is the case of proteomics, where we want to measure all proteins in a plant, for example. So this is the sampling process I just showed you, but the thing with the sample inside here, even if you take just a single leaf, you have millions of cells in there, and the cells inside there look like this. Many different kinds of, so the insides of the cells look like this. So you have millions of proteins and other kinds of molecules in there, 1 million times for each cell. And each of these molecules creates data in your machine, which you then have to computationally map to a spectrum, which you then have to use, for example, machine learning approaches to infer which kind of protein you're actually measuring. And this has to perform millions of times with a data input of terabytes. So a really, really computationally taxing task. So, and this is only one of the parts of what you have to do in proteomics to actually get these time series data out of that I just showed you. And for all of these tasks, our work group develops the Proteomicon, which is a full proteomics pipeline written in F#, and we are packaging all those as .NET CLI tools, so you can install those with .NET tool install, for example. But this is not where we stopped. As I said, this is a very computational complex pipeline. It has many different tools and parameters. I think it's 20 or 30 tools. And our task is to make this available for everyone. So we need a platform that is able to perform high performance computing across multiple clusters and nodes, and also has a user-friendly graphical user interface to start these kind of workflows. And this is how .NET landed on the Galaxy project, basically. So the Galaxy project is a open web-based platform where you can perform all kinds of data-intensive computational research and also share the results and workflows you are creating there. And what we did to bring .NET there is first create a Conda package that contains the .NET SDK. So you can now, the Conda package manager is a language agnostic package manager, which is used by Galaxy. So you can now package your .NET tools as Conda tools, and therefore we are now having all of these .NET CLI tools on the Galaxy platform. Let me show you real quick how a workflow there looks like. Just a really quick glance at it. So what I'm seeing here is a workflow graph of a single step in the proteomics pipeline, and I can create this workflow now, not with inside my CLI environment, but with a graphical user interface. And I can also go back to my workflow or go right here and just start it. And that's it. I can edit the parameters and so on. Galaxy takes care of the rest, schedules the jobs for all of these nodes, and we're done. So yeah, you can do all of this with your .NET tools. Submit some pull requests if you would like. Okay, so with that, I'm finished. This is my work group. You may already know David and Benedict from the ML.NET stand-up. I think it was about F#, and David is the guy that is mostly concerned with creating all of these complex tools in the proteomics pipeline. Yeah, so if you are interested in doing data science in F#, why not taking a look at fslab.org? Maybe you might like it and never look back, just as us. We actually published, I think, more than 50 peer-reviewed scientific articles just using F#, so you can have a little bit scientific success with that as well. So yeah, with that, thanks for joining. Here's how to find us, find me. Happy to answer questions if there are any.
Amazing. Kevin, thank you so much. That was so informative. I'm very excited. I'm going to go check out fslab.org myself. And it's amazing to know that you used what Isaac spoke about earlier, the safe state for your web applications as well. So
yeah,
amazing how it's all coming
an amazing
full circle.
framework. It's really good.
Amazing. Alrighty. Well, so we ran a little close to time, so we don't have time for questions, but there's some really great questions on Twitter. Kevin, if you don't mind heading on over there and answering those directly.
See if I can answer something. Thanks for having me.
Amazing. Thank you, Kevin. That was excellent. Alrighty, let's keep moving on. We have a lot of content to cover today, and I am excited to bring on our next hosts and experts. We have Philip Carter and Krzysztof Klesiak. Klesiak, how do I say your last name? I mispronounced that.
It's actually Cieślak.
Cieślak. Okay.
Yeah.
I wouldn't have been
no one will be able to do that, so no worries. Thanks for having us.
Yeah.
Yes, of course. Thanks for being on the show. It's great to have you, Philip. It's amazing to see you again.
Indeed.
We will. Y'all are talking to us about a tour of F#, the editing tooling, correct? Yes.
That would be correct.
Amazing.
Yes, that is correct. So I'll begin with sharing a little bit of slides, and then we'll do some brief introductions, and then it'll just be demo time, really, because this is about editor tooling, and editor tooling is best when you show it and when you use it rather than just talking about it. So
couldn't agree more. I'll let you take it away.
Yes. Hello. My name is Philip Carter. I'm joined by my good friend Krzysztof, or Chris as he sometimes goes by. We have both been doing a lot of F# for quite a few years. I used to work at Microsoft actually on F# for a little over 5 years, and now I do developer experience over at Honeycomb. quick plug, if you're interested in observability tooling, you should check out Honeycomb. It really does offer the best way to look into your distributed systems and all that other stuff.
Totally, it looks amazing. So yeah, my name is Chris. It's actually funny because I think it's for both of us. It's like first public talk after the milestone. So you've left Microsoft and I kind of joined Microsoft family. So nowadays I'm a research engineer at GitHub. I was helping to build Copilot. So also quick plug, if you are interested into some AI stuff, check it out. All right, we probably should move on. Like introductions are boring.
Yeah. So really kind of the main takeaway that I want people to have here, if you're not familiar with F# or just have a little bit of passing familiarity with it, is that F# tooling is everywhere. It's absolutely everywhere. Pretty much no matter what kind of developer you are and whichever development environment you prefer, you will have something available to you, right? If you're a .NET developer or just working in a .NET shop that's been using Visual Studio forever, guess what? F# is right in there. If you're using VS Code like millions of people are today, it's right there available to you. If you're on the Mac, you can even use Visual Studio for Mac. You can use JetBrains Rider for all of these operating systems. Ionide is, although it's primarily used within Visual Studio Code, it's actually kind of a suite of tools instead of just purely editor tooling. And so it gives you some good stuff there. And then, I mean, hell, if you don't care about editor tooling, you just want like a little text editor and a command line interface that does what you want, the .NET CLI sort of has your back with all of that. And of course, it can be used in conjunction with everything else. The .NET CLI is packaged with the .NET SDK, which includes F# by default. And so anytime you install .NET, you get F# and everywhere that .NET runs, F# runs as well. And that includes well over a dozen, I think several dozen at this point, Linux distributions, obviously Mac and Windows and that kind of stuff. So yeah, that's the main thing. It's everywhere. And so, we have limited time. We can't possibly show like every cross product of all the different stuff that you can do. So, but critically, and this is what I want Chris to briefly talk a little bit about, is this is not just a whole bunch of little separate efforts everywhere. I mean, like, yeah, there's different tooling, but really it's powered by a central component.
Yeah, so the component is called F# compiler service, and without going too deeply into technical details, it is a version of F# compiler that's distributed as a normal .NET library. You can add it as a NuGet package to any of your .NET projects and get access to the internal APIs of the compiler, some additional APIs that help build editor tooling and any other kind of tooling. So this is the component that enables us all to build this ubiquitous language tooling that is really similar across all those editors and all those places. I mean, the user experience differs a bit between different IDEs and different editors, but at its core, the set of the features that are supported in all of those places is fairly similar. And I think that we will quickly move to demo time. So let me take over, and if we could switch to my screen, that would be lovely.
Yeah, let's see it.
Please let me know when we are live, Philip. All right, yeah, I think that my screen should be live.
Screen should be shared, and okay, there we go.
There we go. Okay, yeah, perfect. So here I have open Visual Studio Code instance. It's empty folder. There is nothing in there here. So we want to start with creating actually some kind of F# project. So there is a command F# project. I can run it, and this will deactivate the extension. Takes a moment. Okay, yeah, that shows me a list of possible projects types I can create. This is powered by the .NET SDK. So as was mentioned before during the Isaac talk and other talks, you can install your own templates for the .NET SDK, and if the template supports F#, it will be displayed here in the list. So let me create console application. There are a couple of parameters that I may provide, but I don't need to. And then this should hopefully, yeah, this created actually simple F# project. So as you can see, it created a couple of files, but what is important, it actually enabled Ionide, which is F# extension for Visual Studio Code. You can see here, there is this additional F# icon at the activity bar on the left in Visual Studio Code, which will be display list of your project. If you would have solution, it would be displaying the list of the projects in this particular solution. It is a feature that tries to simulate the solution explorer that you know from Visual Studio or from JetBrains IDEs like Rider. So you can check list of packages references, check list of project references. Well, there are none in this case. You can right-click on the project, you can do run, you can debug, you can build, all the stuff that you know from normal IDE. You could, if there were more files in the project, you could move them up and down because that's kind of important for the F#. However, let's quickly jump to the file. And so there's a couple of things that we will see in a moment. Okay, here it is. So first of all, as we've seen in the previous talks, I'm not going to deep into like basic functionalities. As we've seen in the previous talks, stuff like go to definition, autocomplete list, tooltips are all working just fine as you would expect in any other IDE, in any other programming language with decent tooling. What is really interesting in case of what we do in Ionide, the first thing that you can see is that we have those code lenses. So code lenses is the feature in Visual Studio Code where you can display some virtual information on top of some symbols. So here we display the type of our symbol, this string, arrow, string thingy, or this thing here. This is type definition of our symbols. So in F#, as was mentioned before, F# has type inference feature, which means that you don't need to specify the types. However, when you code, when you quickly read the code, it is useful to have those types visible all the time. So we provide that. And then there is the references code lens, which is known from C# tooling. When you click on that, it will display the list of all usages of given symbol. If you, let's say, let's do that. This is already updated. This works across the project files. This works across files, across different projects. I'm not going to show that. You need to trust me, but it is pretty great. Another really interesting feature that's kind of connected to that, and it's in the style of providing additional information for user when they code. Let's write some pipeline stuff. So as you may know, in F# we pretty often code in this like pipelining stuff. So whoops. So you get some input, you pass it to the next function using the pipeline operator, and you do so and so and so. So what is really useful, string, I cannot type. What is really interesting?
Sorry to quickly interrupt. Could you just have the code on the upper half of the screen because the little okay, cool.
So what is really interesting is that we display those informations about what's the type of every step in your pipeline. This is super useful when you do bit bigger of those like pipelines. For me, it was always a bit confusing about like what's really going on regarding types. This helps a lot with that feature. Staying in the area of reading code, what I'm really proud of is how good are tooltips in Ionide. I know that tooltips are everywhere, and this is maybe not super exciting feature, but tooltips in Ionide are a bit more advanced than in most other IDEs. So first of all, we have those formatted function signatures. Then we display a whole bunch of additional informations in the tooltip that is usually not displayed in other tooltips. I think most IDEs are using just a summary XML tag for displaying information. We are using also other XML tags. And we are also displaying the generic parameter resolution and things like that. Related to that is a feature called info panel. So I can open that. As name suggests, it's additional panel that you can open in Visual Studio Code. It displays the documentation. Again, what is really interesting is that it is kind of like connected to your text editor. So when you navigate, when you move around code, it automatically updates. When you code, it automatically updates. But at the same time, you can also click on those things, like all those things that are marked as a link are actual links. So you can, for example, click on this function. You will go to the documentation of this function. You can click on some type. It will go to definition of this type. And as you can see, this is like integer type. This is coming from the .NET standard library. So It's not really connected to your code base. It works across all the references that you will have, which is pretty exciting thing. Another thing is a bit more advanced. Let me close the info panel. We don't need that anymore. Another thing that I want to show is a bit more advanced navigation that we have in Ionite. So let's imagine that you have some function from the F# core library, for example, array2d. I can F12 on that, and this will actually take me to the source code of this function. So this feature is provided and powered by the feature .NET functionality called SourceLink. Without going into details, this allows package authors to package also the source code together with the compiled versions of DLL. And if the package is SourceLink enabled, we detect that and we provide this like nice navigation. In case of the packages that don't provide source links, for example, .NET Standard doesn't provide source link. Don't ask me why. When you do F12 on that, we will try to decompile the code. Unfortunately, it's to C# because the most common decompilers in .NET ecosystem decompiles towards C#, so we do that. But yeah, it also works. So all that was kind of like connected to reading the code and navigation, but there is also writing the code and maybe some refactorings. So in Ionite, we have a whole bunch of quick fixes, and Isaac's shown some of them, but also I want to show a couple of them. And I think like we implement total few dozens of those, so I'm not going to show all of them, but let's go quickly through this like really short file and see what we can do. First thing interesting is this add explicit type definition. This pins the type of your parameter in the function. This is super useful a lot of times, especially for public functions, public APIs. You want to pin the types rather than use type inference. You can, for example, if the value is detected as unused, you can replace that with the underscore. If you try to write the record, but the record doesn't exist, Ionite will tell you that maybe you should convert that to an anonymous record. However, at the same time, if something similar would exist, type X. Let me quickly create the record type. Y is something else. Let's go back here, do the normal version. If compiler thinks that this should be an instance of this type, however, it's just missing fields, it will provide with record stub. It also works for discriminated unions. It works for implementing interfaces, for implementation of abstract classes. I'm not going to show all of this right now because we don't have time. Last thing I want to show today is integration with F# Interactive. So you can just open terminal window inside Visual Studio Code. You can click plus button, open F# Interactive. This will create F# Interactive session. Let me bring that here. I don't need this. And I will open additional thing, which is called Watcher, FSI Watcher. And this is still experimental feature. Not a lot of people are using that, but let me quickly show what it does. Let's send this code to the interactive, and let's, for example, send this code to the interactive. So as you can see, this got evaluated in the F# Interactive window. And now suddenly we see in this FSI Watcher tab, we see what are declared values in my interactive session and what are declared functions. This is a super useful feature for interactive working with code. The performance is still not great as it's experimental feature, but yeah, it refreshes. So that would be all for me. Now I will pass the virtual microphone to Philip, and he will show some cool stuff in Visual Studio world. So yeah, take it from here, Philip. You're muted, Philip. You are muted, Philip.
Hello. There we go. Classic maneuver there. All right. I am in Visual Studio right now. So if you're a .NET developer, you know exactly what this is. If you're not a .NET developer, but you work in a .NET shop, like your workplace uses it, there's a pretty good chance that you're using Visual Studio and C# tooling already. And so I'm here to tell you that F# works in Visual Studio just like you would expect it, right? Let's say I want to create a new project, right? Just Control-Shift-N. You can see right here, I've filtered this down to the F# language project types. I got, console app library, ASP.NET Core stuff, ASP.NET Worker Service, some test projects. You can install some custom templates in there as well. There's a lot of options there already. Another thing that's a bit more unique to F# tooling here that you may not be familiar with in the C# world is scripting. So this F# script file. So you've seen some F# script files already in the context of inide and VS Code. I'm going to show you a little bit of that inside of Visual Studio. So here I'm just going to paste in two functions. One is called isodd and one is called square. Isodd will take in a value and it will try to mod it on 2 and check if it's odd, and square will just square a value. A couple things I want to demonstrate before I move forward. I can do control dot. This is actually unused. I defined a function, but I'm not using it. I could just remove it if I want. Or I could move over to the parameter, hit control dot again. And I can add a type annotation, similar to what you saw in inide there. In fact, there is a big overlap of the features that inide and Visual Studio have. And so if you're familiar with editing code in one and you hop over to the other for some reason or another, you can find yourself pretty much at home. Now, of course, Visual Studio Code and Visual Studio are very different in terms of the UI, and there's this big thing called Solution Explorer, and I'll get to that a little bit later. But in core F# editing, you're going to find that there's a lot of similarities, but there's also some differences, and I'll show a little bit of that as well. Let's say I want to use these functions right here. I'll define another function we'll call get odd squares. It'll be values. Well, actually, let me start off here. Let me call square, okay? I'm calling square. You can see I have a tooltip there that sort of shows me what the signature is. I hit space. Oh, I get another tooltip. But in this case, the tooltip, it's a little bit different. It highlights in bold the parameter value here. So I can see what I want to pass over to it, right? So I'm going to send these over to F# Interactive, hitting Alt-Enter. I'm going to send this guy over there, and it'll be val. It is 144. Let me zoom in. You can sort of see right there. It evaluated it. This is the F# Interactive window that's embedded into Visual Studio as well. Okay, so let's say I'm going to write this get odd squares function. I want to get a list of values, and I want to find the odd ones, and I want to square them. Okay, that's pretty easy. We'll go list.filter. I got another tooltip, except I want to call out something a little bit different with this tooltip. So it's saying that, okay, I need to pass in a predicate, a function given a t, produce a bool. But if I hover over tooltip, filter itself, the full tooltip shows that same predicate, but another parameter called list. Well, you might be asking, well, why is list missing? Well, it's not. That's intentional. It's by design. That's because we're already passing it in via this pipe operator. And so we chop off that last one in the context of piping operations, because if we were to show additional parameters, that might sort of mislead you into thinking that you need to pass in something more when you're actually already passing in everything that you need. So anyways, this is just a wonderful helper for when you're writing code. I can type my good old is odd. All right, I'm going to go list map square. I got the mapping, and we're off to the races. I'm going to send that over to F# Interactive. I will call get odd squares, and we'll pass in a list from 1 to 10. We'll evaluate that, and ta-da. All right, so from 1 to 10, the squares are 1, 9, 25, 49, and 81. That should be no surprise to anyone who understands the most basic math, which sometimes I fail at. So moving on. What I have here in Solution Explorer, so this is a script file. Script files in Visual Studio are great for just interactive experimentation, that kind of stuff. You can do more than what I showed you. But I want to show Solution Explorer. I got C# and F# mixed in here together. This is especially relevant if you want to introduce F# into an existing .NET code base. You're probably going to have a lot of C# code in there. And you're probably going to want to be able to use stuff from C# in that F# code. So here's something cool that Visual Studio lets you do. So I actually have a class right here. It defines a string. This is Philip, and it's just my name. And then I'm going to go into the F# code here. This is actually a file called http-handlers.fs. Let me zoom back out a little bit here and move this over a little bit. So this is actually a Giraffe application. You should have seen some. I don't know if there was Giraffe shown yet, but Giraffe is sort of a bit more of a low-level ASP.NET Core style web server implementation. The Saturn stuff that's part of Safe is actually built on top of this. And so you can see it's got a bunch of the wiring up ASP.NET Core stuff in there. It's got some functional routes, got some routes right here called handle get hello with name, get goodbye, blah, blah, blah. I can go to definition of one of those. All right, cool. Here we are. I got handle get hello. Instead of saying hello world from Giraffe, I want to say hello world from Philip. That Philip is defined in C#. So how am I going to do that? Well, that's fine. I don't need to mess around with anything. I don't need to build anything. I'm just going to go open C# library. And then I'm going to create a new instance of that class. Called it class 1. Very nice name there. I have an interpolated string here. And so instead of saying from Giraffe, I'm going to go C.Philip. And so I got IntelliSense from that C# stuff right there. If I want to see what that looks like and go to definition, it'll take me directly to the C# code that I had, which is pretty great. Speaking of go to definition, I can go to definition on stuff just like an Inide and things that are not necessarily in my own code base, like this JSON function. Boom, this takes me to something that's defined inside a Giraffe. I can look at the option type. I can see here, I can get tooltips. I can look into this thing right here. There's a lot of experimentation that you can do just by sort of looking at APIs. And, again, this is kind of what I mentioned before. A lot of overlapping features in the F# tooling, but, some of them are a little bit different from place to place, depending on what sort of makes sense for that kind of editor. I can do find references. I can rename stuff if I like. I can do pretty much anything. And so rather than, just try to exhaustively show you everything that you can do, I'm just going to encourage you, go use Visual Studio, especially if you're a .NET developer today. Create an F# project and just start using it like you would be using C# code. And you'll find that it'll have pretty much all the features that you're looking for. And you can just be productive in it. So to wrap it up, I'm going to switch gears and take us back into VS Code. Except I'm not going to I'm not going to have Inide loaded up here. I'm going to have .NET Interactive. So .NET Interactive, which you should have seen a little bit before, I believe, is a very cool project here. It allows you to do notebook-style programming in .NET, in this case with F#. So here, I have the square function. It produced 144, but it's a little different. So now I'll write get odd squares again. I actually have GitHub Copilot installed, so even though GitHub Copilot is not officially supporting F# right now, it can actually be pretty dang helpful. So it's able to suggest values for me there. I'm going to type in my list filter is odd, and I'm going to do my list.map square. It knew exactly what to autocomplete for me. I'll go get odd squares. Odd squares from 1 to 10. We'll execute that. All right, cool. Got a nice tabular output here from 1, 9, 25, 49, 81. That's pretty cool. A different way to look at stuff. Speaking of looking at stuff, you can do more than just show a tabular output, though. That's if you want to do interactive programming, you got to have charts, visualizations, pretty stuff. So let's do a little bit of that. We'll call this XY, and we'll go for X in from 1 to 100, I'm going to produce a tuple of X and its square, okay? And then I'm going to pull in a charting library. So first I'll just sort of send that there. I'll bring that up. And so then I'm going to pull in some libraries here. I'll use both of them. Okay, I'm pulling in plotly.net.interactive. This is a way to embed .NET Interactive charts directly into, plotly.net charts directly into .NET Interactive and some F# data. Just pull in those packages immediately, and I'm good to go. And so now I'm going to call the chart function chart.line, I believe is what I'm after. And we'll just send that over, and ta-da! I got a nice line chart going from 0 all the way to 100 and showing the squares there. So that's pretty cool. You can do fancier visualizations than this. In fact, I have something really cool here. This is in the Plotly docs for Python itself. Plotly is a super popular library for Python and JavaScript developers today. And so this is a continuous error bands chart. So this is basically showing a measurement and then an upper bound and a lower bound of that measurement based off of some statistical, like standard deviation, that kind of stuff. And so the code for that in Python is it pulls in some wind speed data from the wonderful state of Nebraska into a CSV and does some stuff with it and charts this kind of fancy chart. And so the question is, in 2 minutes, can I reproduce this chart in F#? let's give it a go. So I'm going to pull in the type provider here, get some data, and I'm going to see if I can use GitHub Copilot to make this thing go nice and fast. So we'll go for row in data.rows. It's time series data, so I'm going to want the time that comes directly from the type provider. I want the X, I want the Y. All right, I don't want row.value, but instead I want the 10-minute sampled average. So then I want the upper bound. We'll call it Y upper. GitHub Copilot already suggested most of what I wanted there. It got that one slightly wrong, but that's okay. I just want to add the 10-minute standard deviation. And then I want the lower bound, boom, autocomplete. I'm ready to go. So the name of the chart for this is chart.range. And we'll autocomplete that, send it off. Oh, there we go. This is looking kind of similar here. Yeah, it's okay. The color's a little off. So a few things are not quite the same. Instead of boring you with fiddling around with colors and sizing and all that kind of stuff, I'll just copy paste some code that I already had here because I'm a cheater. And there we go. This looks almost exactly like what we had. I think this actually does look pretty much exactly like the Python one. It's got the measurements. It's got the upper and lower bounds there. I think there's a few more tweaks that I could probably make to touch it up. But the answer is yes. You can do all this stuff that you can do in Python with very mature libraries in F#, in .NET Interactive today. And so that about rounds out, I think, everything that we wanted to show. Went a little fast, but that's okay. I think the main thing that you can take away here is that you can do pretty much any kind of development in any development environment, and the F# tooling is going to have your back. And I think that's really wonderful because it's very mature tooling that continues to improve over time, and it's both deep and broad, which I think is great. And so, main takeaway is you can do everything that you'd like. Please try it out. Please give people feedback. And a lot of the stuff is open source. So if you're feeling like you want to get even more involved, we love contributors to all F# tooling. And yeah, that's about it.
Totally. I just want to also point out that so the language server that powers Ionite FS autocomplete, it's using language server protocol. So if you have NeoVim or Vim with LSP extensions or Emacs with LSP extensions, this, like a lot of the features that we've shown today, will work also in those editors with probably a bit more of manual setting up. But yeah, it should work just fine.
Yeah.
And totally thanks to all of our contributors for like all the projects that we've mentioned. We couldn't do that without
dozens and dozens of contributors over the years that have enabled all of this. It's not just me and Chris who are doing this kind of stuff. We just have the pleasure of being able to show off all this great work. Oh,
You're
James,
muted.
looks like you're muted.
You're muted. Still muted?
Wait.
Yeah.
Nope.
AV. You make AV so hard.
Imagine if we played that joke.
Nope, not yet.
We should do the hosting. So next talk will be. Let me quickly check in the
I think it's Dave.
timetable. Yeah, it's Dave Krullo who will be talking about deploying cloud infrastructure with F#. That will be the amazing talk. Dave works at Microsoft right now, I believe. So I believe this is the stuff that is actually used in Azure in production. So I'm really happy to see what Dave has for us to show.
Hey, thanks there, Chris. What can I tell you? This is live, and sometimes microphones and things all go out of whack. Yes, absolutely. Thank you so much, Philip and Chris. Really appreciate you joining us. Yeah, let's get Dave ready to come in here, and we'll excuse Christoph. There goes Philip. Thanks so much. Now, Dave Curlio is going to join us here in a second, deploying cloud infrastructure with F#. Let me see if I can get David. Hey, Dave.
Hello. Hi, everyone.
There we go. Good to see you. Thanks so much for joining us as part of .NET Conf.
Absolutely. I'm excited to be here.
So deploying cloud infrastructure, I'm used to just pushing the button to download a profile from the Azure portal, or I'm in a GitHub action and I say, yeah, go ahead and send it to Azure. I can do this with F#.
Yes, absolutely. You can do all that with F#. So, deploying to the cloud sometimes can be a little bit tricky. The portal helps out a lot. It makes a lot of good choices for you. But if you look at some of the more complex resources, there's certainly a lot of options to them. And so F#, representing some of those things in F# enables us to kind of define a lot of those complex deployments in a more manageable way. And then we can kind of push the code straight from F# up to Azure.
Oh, that's cool. Well, gosh, I'm sure you've got some slides and stuff to share with us. So I'll get your screen up on the video here for us.
All right.
There you go. And the stage is yours.
All right. Thank you, everyone. Again, my name is Dave Curlow. I'm going to go over deploying some cloud infrastructure with F#. Just about me real quick. So I'm part of Microsoft Atlanta. I reside in Atlanta, Georgia. I'm an engineer on the Azure dedicated team. We do lots of F#, use F# and some of our stack. I have expertise, is kind of what I've done is infrastructure and distributed systems work. I'm also a member of the F# Software Foundation Board of Trustees. Been on it for a couple of years. I've been with the foundation for quite a while. I encourage people, if they haven't joined, to join. It's free, and you can connect with a lot of other F# engineers there. You can find me on Twitter and GitHub as well. So infrastructure development. So infrastructure development is a little bit different than you might say database development or front end development. So it's software to deploy and manage, physical and virtual hardware. And you're doing that usually so others can build on like a solid platform. And one thing about it, infrastructure developers are always saying where it's like idempotent and infrastructure as a service, and we'll talk about goal states. And one thing I want to say, when you're an infrastructure developer, your resources are constrained by, they're constrained by money because you've got to buy physical equipment a lot of times, and time. Like this stuff, infrastructure testing is slow. Some of the stuff takes, 15 minutes. It's not like a unit test or an integration test. When you're testing infrastructure, it can take hours to get through some of the tests. You're limited by physical space. I mean, you've got data centers with racks of servers, and you can only put so many racks in, so you can imagine large development teams do get constrained by physical space and hardware limits. But probably one of the biggest things, and this is where F# comes into play, is that system failure is kind of an expectation. So it's one of those things that happens when, especially you're dealing with hardware, you're dealing with networks, you're dealing with DNS and authentication. All these things kind of come into play. So we have to be cognizant of the different failure modes. So when you're running applications on the cloud, you've got cloud native applications. They're built with dependencies on cloud infrastructure. It's usually, you might be dependent on Key Vault or storage accounts, or, and this is whether it's, Azure, AWS, and whoever you're using, you're building a cloud native application. You're depending on it. Might be depending on it for hosting your service, for hosting your DNS, for hosting some of your storage. But you get the benefits of scale. So like a tiny company is able to use the same resources and processes like a huge enterprise, which is one of the things I really like about it, because it enables anybody to run their code. It's not like you've always heard that a cloud is just a VM under somebody else, or a machine under somebody else's desk. And it's a little bit more than that, because you're getting all these people who specialize in running that hardware, and there's people that have gone through all these compliance processes, and there's all these security policies. And as a tiny company, you can use the same thing as a big company. So I think that's kind of cool. Of course, it gets baked into the price, but like that's one of the things that you take advantage of. You can scale up really well. And so instead of a local library like you would in a traditional application, you probably use functionality from a remote system, and this leads to a lot of different sorts of failure modes. So when you write code for an application, you usually write it pretty optimistically. You'll fail fast, log errors, recover, move on. If you're writing against a database, transaction fails, you may just log it and not worry about it, or you may restart. In infrastructure, it's a little different. Failure modes can actually cascade. Like a failure in authentication or DNS or whatever can cause a call to one component to fail or another subsystem to fail, leading to another failure, you know, with really big failures. And they're distributed systems. And unlike a database, like the rollback and retry are pretty questionable. You can't always roll back across all the different systems. You can't always retry. So one of the big important things is to be able to represent failure in the type system. This is what we kind of heavily try and use. So if we can represent failure, and this is one of the features of F# that it really like, is that you have the result type that you can manage, or you can represent the fact that optimistically it might succeed, result okay, but pessimistically it could fail, and then you're representing it to the compiler, and then the compiler will force you to deal with the fact that it might fail. And so you can imagine that kind of cascades through your code. So the cascading failures that you might have had in your software, you can now have represented to your compiler. And it's not going to be pointed out in code reviews by subjective engineers, but like the compiler, which is a pretty objective thing, will say, hey, you didn't handle this error, what's up? And you can do this with exceptions, of course, but errors are different from exceptions. So, you know, a result.error is represented in the signature of a call, whereas an exception is not really in the signature. I mean, you can look at a function and not know that it throws an exception. The compiler, on the other hand, will check that you handle errors. Like it will say, you have to handle this structure. Whereas exceptions, you might have a person who knows the internals of that call and knows that you have to check the error, check for those exceptions, and handle them. But so with errors, developers are forced to basically proactively consider failure modes, whereas exceptions, they might be found during testing or deployment. You've probably all been through this, where you get a null reference exception or something that you just dig it up in the middle of your it's basically unexpected unplanned time to kind of deal with an exception. So if you can proactively think about failure when you're doing your development, you're doing it on a Tuesday at 3 p.m. or something like that. You find an exception, it will be in a lab environment or a customer system, and it could be in the middle of the night on a Saturday. And I'd much rather be able to get them up front. And then F#, the compiler's pretty strict about these things, and you end up having to deal with a lot of errors, but you get to deal with them on your own time instead of other times. So, all right, so about Azure. So we have orchestration and failure mode. So with Azure, when you want to deploy a cloud-native application, you have to orchestrate multiple service and calls to reach what we call a goal state. So the goal being these resources are deployed. Any of these service calls may fail for unexpected reasons. And inside Azure, we like to represent errors as a terminal state versus a transient failure. So like a terminal error is one that you can't retry it. It's just the system's busted. You're gonna have to roll back. You're gonna have to do something else. Or transient one where retry it and it'll work. And so if you have an orchestrator that's aware of that fact, then it can kind of handle some of that for you. So ARM deployments are one that orchestrate a series of goal states. So we've got all these resources. We want to get them into this state. If they give you some transient errors like, oh, this DNS lookup failed, or this web service was briefly down, ARM will go, oh, that's a transient one. I'll just retry it, and then it'll just work kind of blindly to you. You don't have to worry about it. Another thing about ARM deployments is that they execute in the cloud. So they're not executing locally on your system. Like if you run an Azure CLI or something like that, it's executing locally on the system. The ARM deployments run in the cloud. So when they're pulling credentials down, it's all internal to Azure. It's also integrated with Azure authentication, auditing. There's telemetry, there's correlations kind of automatically baked in. So if you have a problem with something, you can actually say, here's my correlation ID for my deployment, and they can look at all the different services that you're talking to. So it's pretty neat. It's orchestration that you don't have to write or execute. So you don't have to think about all those different failure modes, which is nice. Challenges of them. So the syntax is very verbose. There's either in JSON or bicep, and this is the same on AWS. So there's ARM deployments, there's CloudFormation. Either case, they're very verbose. You have to define all of your dependencies, and being in these big files, your composition is pretty limited. And as F# developer, you probably like to compose lots of things together, but it's kind of hard to do that when they're on a bunch of loose files. all these things, the ARM template just represents the goal states and the dependencies between them. Any logic you might want kind of has to be done externally, and you don't really have an ecosystem. So this generally leads to a lot of templates and a lot of parameters to manage, and it's an external file in JSON. There's not really any type checking. So all those things that you have in F# developer, you lose. So Farmer is kind of cool. It helps you out with this in a way. It generates standard ARM templates. And this is a tool that we use some in Azure. I've used it for quite a while. I've contributed to it as well. And we use it. And if you watch the SafeStack talk a little earlier, that one, part of the safe template uses Farmer for the Azure deployments. But your templates are authored as F# code. So it gives you full type checking around your orchestration definition and your resources. There are all these builders for each type of resource, and you can compose those together. So you could define the way you want a VM to look like, and it's just a little expression in an F# file. You can use it in other ones, or you can parameterize them with regular F# code and generate lots of different types of resources. A builder can add one or more resources to the template. So like a VM has network cards and storage accounts, sometimes has the VM disks. So it has all these pieces that go with it. And you'll just define a VM and then some options, and then you'll get all those pieces. The dependencies are automatically kind of chained together. You get a regular ARM template out of Farmer, but you don't have to actually go in and hard code all the JSON for it. Cool thing is F# is cross-platform. You can use it anywhere. I think with .NET Core, they've even started to support it on Windows. So F# is not just a Linux and Mac OS tool anymore. It's nice. So I'm going to go into a quick code sample, and I'm going to kind of demonstrate it. This is what some of the Farmer DSL basically looks like. So here we've got a container group. If you're familiar with Azure, Azure's got these container groups that are kind of a lightweight way to deploy a container. So you've got some software, you just want to package it in a container and deploy it onto Azure, and you can do that pretty quickly. And here, hopefully this is relatively clear. So we've got a name of our container group. We've Farmer containers. We get them in a DNS entry for public DNS. Call it, and it's running on port 80. We added an instance of a container. You can add many containers to a container group. Here we're adding one for the Xplot service. I'm gonna Philip was just showing this. I'm gonna use this in my demo as well. But and then we're gonna kind of run a little service that shows Xplot. And here we're referencing registry credentials. So you can reference, ACRs, Azure Container Registry. And it kind of plumbs all this together and ends up generating a template that just works. And as you need to go, the big thing is like your orchestration only becomes more complex over time. And as it does, you need to refactor things. And this would allow you to be able to refactor. And F# compiler goes, hey, you're missing this thing. Oh, you need to change this thing. And that way you're able to see where your changes over time would be applied. One other thing I want to talk about with it is that, so I get to work with Eugene Tomashev. He's another developer on our team, and he made a really good quote. Contributing is what the F# community does best. So F# is built on community engagement. It's been a long time open source model, and a lot of influence comes from JavaScript, Haskell, Scala, Python, people who've worked in other ecosystems, and so they've seen great solutions and been able to bring that together. And also, it's very you compose things. It's how you generally as an F# developer, you look to compose things. You don't try to say here's a framework that tells you all the things to do. You'll usually have pluggable compositions where you can bring in lots of different great things. So between the composition engagement, you get like a thriving community. And this is one of the things with Farmer. So Farmer was started by Isaac Abraham. He spoke earlier on SafeStack, and he built this. He initially started Farmer, but there's lots of Azure engineers that we use and we contribute to Farmer. And it's a high quality project. It's well tested and documented. They keep a low bar to contribution. And it's one of the scenarios where we can use it, but we can also contribute greatly to it. There's a lot of resources. We have access to lots of infrastructure, so we can kind of heavily use it. And so anyway, it's been a great experience to be able to participate in the OSS community with that. Are there any particular questions so far? So I'm going to hop into a demo of this. Oops. All right, so the demo. So I want to use F# for infrastructure. Now, as we know, F# is primarily for math and science. I'm going to do something mathy, like a chart made from some math stuff. But I'm going to make it into a service, and I'm going to define a Docker file for this service. So this is kind of the infrastructure sort of development. I'm also going to build a container registry, send the Docker file to the registry to build it, and deploy the image and container group. And this is typical orchestration, and this is one of the things that you can do in Farmer, and it'll help us manage the scale and complexity by taking F# to define this orchestration. As it changes and it gets bigger, and we have to have some logic into what pieces of the infrastructure we deploy, what libraries go with our application, what services go with our application, then it'll help us keep that complexity under control. And so let me switch over. All right. All right. So I'm going to take a quick look at it like a Farmer. So if I take a Farmer script here, and this is just a regular FSX file, nothing special. Thanks to the folks in the F# team that built the scripting implementation. But you can just create an ARM template use NuGet Farmer, open Farmer and farm.builders, and then you start to define your template. And I'll show you what we get here. So .NET FSI quick start.fsx. It's going to take just a second to run. It's got to download the package and all that stuff. And then we should get our little quick start. So that gives you like nothing big, an empty template. But say we wanted to add some resources to it. So add resources, and we might want to add a storage account, and we'll call it name Dave's file storage 1.3. Yeah, kind of got to make it unique. And now let's do that again. So run it again, and we get our nice little, it gives us a template that will have, has all the kind of pieces built in. So as West US, storage v2, local redundant storage, and you have options for configuring all these things. You can choose your SKU, and that'll be SKU, storage.sku.premium. You can choose your SKU and kind of do that sort of stuff, but it takes some sane defaults, so you get up and going really quickly, and then you can just deploy this sort of thing to Azure. So let me switch over. I'll get go custom template. You can deploy right from the command line. I'm just going to kind of show you as well how you can do it in the portal. You can just take that thing that was generated by Farmer, and it's it recognizes it all. It's valid syntax and all that stuff. We'll call it Dave's Farmer demo. We'll call it that. What are we in West US? I'm stimming this. Do that real quick. All right, so we'll create it. I'm gonna let it churn. It doesn't take too long to deploy a storage account, but it's really good at building a pretty simple deployment. So I'm gonna go over building a little bit more of a complex application. So while that one's churning in Azure, it's not done yet. So I did a little thing is to say our .NET. It's just taken straight from the Plotly website. Or the XPlot website, where we can just generate a little chart, and I'm gonna draw a surface chart, and it looks like FSI xplot-server.fsx. This will build and run a little server that would run locally, and I'm gonna put it on Azure. So there we go. So our listener's going. That thing's still deploying. All right, so let me localhost. So here's our, there's not much to it, but it, generates a nice little chart. Looks like math. Okay, and then we'll go back to our script. So if I want to take that and deploy it to Azure, so we got a few things. So I have that little XPlot server, and I'm just gonna read all the source into it. In real life, you'll have like a, you'll have a whole system with that can run CI. You'll have source control and all that stuff. But here I don't have that. I'm just going to read it into my script. I'm going to put that into a Docker file, all kind of from F#. So I'll take the source. I'll embed the source into a Docker file. Since I've got the whole .NET ecosystem, it's just regular .NET code, I can convert it to base 64, and then I can embed it in my Docker file and not worry about escaping. This is kind of an infrastructure developer trick. You can do things like that. Base 64 is your friend. And I'm going to build a Docker file. I'm going to create a container registry, and that's this little bit of code. And then I'll create a deployment identity. It's got to run a user identity that can then build my image. So it's going to connect to that container registry, and it'll send it that Docker file up to the container registry to build it. We'll let that churn, and then once it's done, we'll deploy it to container group. And one of the neat things about this is, so I build the image, and I get a step called build image deployment script. So I could create this container group like I was showing before, but it depends on the build image deployment script being complete. So ARM will orchestrate it for me and get these all done in the right order. So let me shut down my local one. Let's see, .NET FSI xplot -Azure. And let's see if we get done with our storage account. Our storage account. Yeah, Dave's farmer demo. So that all worked nicely. Let's go. We're going to create another resource here. Again, a custom template and create. Now let's see what we got here. So it generated this much bigger template. So it's, and I could walk through the complexity on here, but all these things have their dependencies built in. So this thing depends on what resource is this? The deployment script depends on the container registry being created, and user identity needs to be created. And then my container group also depends on the deployment script finishing. So you have all this orchestration that's all kind of just in here, but I'm not having to think about it, which is kind of nice. And so when I change and I forget to think about it, then F# kind of thinking about it for me. So I've got all these resources I want to deploy. Let me save it. Let me create a new xplot -Azure. We're going to deploy that service. Again, we'll go on West, US, and then it'll hopefully be valid. Yeah, great. So we'll let it create it. So this takes just a couple more minutes. So I do want to take a little bit of time to see if anybody's got any questions or anything while this one's going, because it's going to actually build the container. It's going to deploy all of the container registry. It's going to actually build the Docker image, push it to the registry, and then deploy that to container. We can kind of see the steps going here. But any questions from anyone so far?
Hey, Dave, can you hear me okay?
Yes. Hey, Jim.
Okay, great. Technical details resolved for the time being. No questions at the time, but if you are following along, please feel free to ask your questions on Twitter, with the hashtag .NETConf, and we'll get those answered right away. But you're doing great, and I'm sure the questions will come in, and we'll save a few minutes at the end to get to those, okay?
All right, great. Thank you. Cool. Yes, so there's a bunch of things that are going on here. You see this, it's like doing operations on the container registry. So it deploys the container registry, and then it also has to retrieve credentials from the container registry to actually use them in the deployment. So I mean, I can kind of walk through what all of this looks like, but it's almost like inhuman. It's if you were just manually creating these in JSON or even in Bicep, you probably wouldn't easily be able to do stuff like encode all of your encode some file that I want to put into my script. Embedding a resource. It's this long string of base64, and then I write it out to Docker file. It's like I'm shipping code inside an ARM template. So it allows you to be able to use the .NET framework. Full framework is available when you're building these templates. You've got the whole open source ecosystem, and you got any NuGet package that you want, you can pull in. And so I mean, one of the ones that I pulled in here was to actually build the Docker file. So I pulled in f#.text.docker, which kind of builds the Docker file and lots of little F# into elements. I don't think it's as pretty as Farmer, but it does the trick, and it lets me know if I've kind of messed something up. So I always get a valid Docker file. and then we are able to encode that Docker file as base64, stick it into a script. And when we're building our, when we're generating our deployment script, we're able to use things like interpolated strings from F#. So I'm able to take my encoded Docker file and stick it in here, and then it'll be inserted. So it's fairly clear code here. It's not so clear when you look at it from the ARM template side, but this ultimately becomes more maintainable. And you can see your dependencies. I mean, if I messed up my Docker file and it wasn't building, then I wouldn't be able to get an encoded Docker file. I wouldn't be able to put it into my ARM template, and I wouldn't be able to generate the template. So it enforces putting together healthy code and healthy deployments. Let's see where we are on that one. Still going. So this usually takes a few minutes, but hopefully we'll get it done in time. Okay, good. So it built the image, and then we're getting to the xPlot Azure side, which is usually the quickest. So let me go to that. What did I call? Let's just go here. So xPlot Azure.
Hey, Dave, it looks like we do have a couple questions.
Okay.
So if you want to get to them, I'm happy to ask them.
Yes, definitely.
Okay, great. So Ben from Twitter asks, is Farmer officially supported the same way that Terraform and ARM templates or Bicep are?
So there is support. So Farmer is a open source community project. So it's not like Microsoft supports it. So I'm not, I'm not endorsing that I would support all the everything for it, but there is support available from Compositional IT. They sell support packages for it. So it's kind of the open source, and you can buy support for it, which is often a requirement if you want to use it in a corporate or government environment or anything like that. You can, often these companies will say, hey, do you have a support package for all the open source that you use? And you can get one, and they're active about doing fixes as well. So.
Okay, great. Good to know. And then we do have one other question. What is your background, and how do you get up to speed with Farmer, your developer background?
Gotcha. Yeah, my developer background. So I've kind of been in infrastructure for a long time. So I did a lot of VMware type of work, and I still do Azure VMware Solutions is the group that I'm in. And I've worked in, if you do infrastructure development, you'll probably do a lot of things in Python. You'll probably do some things in lots of different languages, as Go. So I end up having to work in a few different languages. But that's just kind of what comes with the course. But yeah, I primarily I got started into infrastructure development because I came from more of a bit of a support background where I was doing kind of development support work, and then that kind of grew into infrastructure development. And then that's kind of when we came to Azure, we were doing the Azure VMware Solutions, and yeah, so that's my background. What was the other question about the?
Oh, and then the other question is, how do they get up to speed with Farmer?
How you get up to speed? So Farmer does have pretty rich documentation. If you go to Compositional IT, compositionalit.farmer. If you go to on the Farmer repository, and that's one of the things about it is there's a ton of docs, and there's a ton of samples of the different kind of scenarios. Let's actually look at the scripts. And all sorts of different resources from Azure, Cosmos, deployment scripts, functions, event hubs, Databricks, all these sorts of things. And a lot of these are just, they're created by the community. And there's also some ways that you can make stuff. If it's not in Farmer yet, there are ways around that you can you can add those resources just ad hoc as you need them. It's got a rich website, lots of quick starts to kind of get you going. I recommend walking through some of these, and it's just gotten simpler since .NET 5 came out because you've got the F# scripts. So does that work?
Amazing. Well, we're right at time here. Were we able to get that built?
Yes, and the build did finish with my container instance. So yeah, it took maybe 5 minutes, but instead of our localhost one, let's go to the one on Azure Container Instances Farmer chart. So it's up and running there. Throw a little container group here, and all the different resources that we deployed. So the container registry, when they went the script to build the image and push it to the container registry, and finally container instance to actually deploy it to something. And all that took, I don't know what it take, almost 4 minutes. And that was all, I didn't have to run anything locally. It was all done within ARM. Credentials are pulled out of the credential registry and used to deploy the containers, but I never touch them. It's all kind of inside ARM. So it helps with security and things like that as well. So, all right.
Amazing. Well, thank you for that excellent demo, Dave. That was really awesome. We appreciate the insight. And yeah, we're going to go ahead and move on. Those were all the questions. If you have questions, please feel free to reach out to Dave on Twitter.
All right. Thanks, everybody.
Thanks so much. Mm-hmm.
Bye.
Okay, so next we have my good friend Luis, who let me bring on to the stream. Hi, Luis. How are you?
Hey, doing all right. How you doing?
I'm doing very well now that my audio is working again. And so you've been doing a lot of F# content this week. This has been a busy month for you with F#.
Yeah, I think folks are tired of seeing my face already. So I promise you, this will almost be the last time that you see it.
Almost. We do have one more opportunity tomorrow at our Let's Learn .NET F# event streamed on Learn TV. Luis and I will be your host, and we'll walk through the complete fundamentals of getting started with F#. Yes, thank you. There's the link right there, aka.ms/letslearn.net. And we will see you there. But until then, Luis is here to talk to us about getting started with data analytics and machine learning in F#.
Yeah, super
So
excited.
I will bring up there we go. All right, and I'll let you take it away.
Awesome. Thanks, Jamie. All right, so I am going to talk to you about data analytics and machine learning in F#. It's almost like all the presentations before this. Basically, we're just queuing up my presentation here because I will be talking about actually a lot of the things that you've seen in previous sessions, which they've all been really wonderful. But if you don't know who I am, my name is Luis Quintanilla, and I am a content developer here at Microsoft. I work on ML.NET, .NET for Apache Spark, as well as Azure Machine Learning. So, whenever I get a chance to talk about both of the things that I really love, which is F# and data analytics and machine learning with a lot of these tools in the .NET ecosystem, that's sort of my happy place. But anyway, I'm going to try to get through these slides as quickly as possible because I know that you're not really here to see slides and you just want to see the code. But just to give you a brief introduction into what I'll be covering, basically, I'll first start off talking about the machine learning workflow and sort of, how do you build these types of applications. I'll then get into what the landscape looks like in terms of what are the tools that folks are using to build these machine learning workflows. Then I'll talk a little bit about sort of, what's F#'s role, which I think you've seen, some of the benefits that F# can give you and what the role of .NET is when building these AI applications. And then finally, I'll show you what that landscape looks like for building machine learning applications in .NET, as well as walk you through some demos, a full end-to-end example of how you can build a machine learning application. Okay, so when we talk about the data analytics and machine learning workflow, typically at a high level, it kind of looks like this, right? You start out with a problem, things like, I want to forecast the sales for the next quarter, or I want to make some personalized recommendations to my customers, right? So you start with the problem, then you go out and you get some data that might be sitting in your data warehouse, or maybe you go to some other public sources or actually start collecting the data. At that point, you go ahead and prepare the data, and that means cleaning it from the sense of, you want to basically get your data and remove duplicates. You're going to join data because it's probably going to be coming from different sources. And you're going to get it ready for training or for modeling, which typically you use different algorithms depending on the task that you're performing, right? If you're predicting numbers or if you're categorizing items, the task may differ. So according to your task, you're going to select an algorithm for your data set. Once you find an algorithm that kind of works, you want to go ahead and evaluate that your model that gets put out. A model is essentially just, you can think of it like a function that contains state based on the historical data that you've given it to train on. It's going to remember patterns, and it's going to remember patterns. And then based on those patterns, it's going to try to make predictions on new data that you give it. So you want to first and foremost, you want to evaluate to make sure that the model performs the way they would expect it to. There's certain metrics that measure basically what are the differences between, say, a ground truth and what your predictions that you're making. And this is typically an iterative process, right? It's very experimental because sometimes you might go back and you might change the algorithm that you're using because maybe it's not right for your particular data set. You might either add more data, you might change the inputs that you're using for your model. So you might go back and forth until you find and settle on a model that you really like. At which point, once you have a model, you go ahead and deploy that model. Typically, this is done as a web service, right? But there's many different ways to deploy models. And then finally, once your model is deployed, you go ahead and make predictions. And again, this process of deploying and making predictions, it's also an iterative process where you don't stop. Once you deploy something, you don't stop there because the world changes, right? So you want to make sure that your model represents the state of the world that it's sort of making predictions under, right? So to give you a perfect example, right? Let's say that you were running some sort of a tourism company back in 2019, and you were making forecasts for what your peak season was going to look like in 2020. And then all of a sudden there's a global pandemic. So your models are no longer valid, right? Like they no longer work because the state of the world has completely changed. So you need to go back and retrain these models based on what the state of the world is now and redeploy them, reevaluate them, and make predictions with this sort of new model. Right? So that's at a high level how you go about building these applications. What does the landscape look like, and what are folks using to build these types of applications? So the three that I'm going to focus on, or the three steps within that workflow, are going to be the data preparation, modeling, and deployment components. Typically, when you're preparing data, you might see folks using something like Apache Spark, especially when you have large data sets and you're doing it at scale. Pandas and Dask are very similar in the sense that they allow you to represent data in this tabular format and perform operations on that data. And then typically this data processing and visualizations and all sorts of things are done inside of this environment known as Jupyter Notebooks, which I think you've seen something similar before this, .NET Notebooks, right, which I'll be showing off later. And to get this interactive experience, right, then once your data is prepared, you use something like scikit-learn for training classical machine learning models. So think logistic and linear regression. You might use TensorFlow or PyTorch for training deep learning models. And again, this modeling might also take place inside of a Jupyter Notebook. And then for deployment, as I mentioned, typically this is going to be done inside of some sort of it's going to be done in some sort of web service, typically. So you might use something like Flask. Maybe you might containerize that web service containing your model using Docker, deploy to Kubernetes. So just like any other sort of web application, you have this sort of microservice for hosting your machine learning model. Or you might use other tools like Triton, right, for simpler for making predictions simpler inside of a GPU environment, right? So with GPUs, you might also use something like Torch Serve, right, for deploying PyTorch models, or you might use something like TensorFlow Serving for deploying TensorFlow models. So they all have their own sort of ways of deploying models. And you might also even consider Onyx, right? So Onyx, although it itself is not necessarily a way to deploy models, it is a way of providing uniformity and providing sort of interoperability across frameworks. So let's say that maybe you trained with TensorFlow or you trained with Scikit, and maybe you want to use it inside of some other PyTorch environment. So you might leverage something like Onyx. That way you have this sort of a uniform way of representing your machine learning models for deployment. With Onyx, the Onyx runtime, you can also deploy models very efficiently to devices on the edge, right, or IoT devices. So that's essentially a set of tools that folks might use in the industry. There's a few more. Again, this is not exhaustive, but some of the more popular ones. And one of the things that they all tend to have in common, there's sort of a common theme here. And part of that theme is that that these tools either have strong Python support or there's Python exclusive, meaning, so for example, like Dask and Pandas and Scikit-learn, they are Python exclusive, meaning you can only use it with Python. And that makes sense, right? So some of the folks over at Anaconda, which is this sort of company and ecosystem for that builds tools for building machine learning models and for building these data science workflows, they did a survey recently, and they found that 63% of the respondents said that they always or frequently use Python. And because, again, this is a state of data science survey, I'm going to assume that, to finish off that sentence there, that they use Python to work in data science environments, right, or to build data science applications. And this is further corroborated by some of the folks over at JetBrains. They actually did a survey as well not too long ago, and they basically asked Python developers, what do you use Python for the most? And you can see that in the top 3, you have machine learning and data analysis, right? So again, this further reinforces the fact that folks are using Python for these types of applications. Now, when they were asked, what sort of features do you like in Python? Some of the answers, these are the top 5, sort of from most popular, I guess, to least. And you see that some of the things that folks really like are the simple syntax, the fact that it's easy to read, it's easy to write, it's easy to learn. You have generators and list comprehension for working with data. You have libraries, kind of like I showed you. There's tons of libraries for these types of machine learning applications, as well as other types of workflows, right? Web, whatever type of application you're building. And the fact that it's dynamically typed or duck typed, right? Which I would imagine contributes to that sort of simple syntax and making it easy to read and learn. However, folks were also asked, what are some things that you would like in Python? What are some of the desired features? And again, this is from most to sort of least important, and these are the top 5. And you can see that there's things like static typing, better performance, concurrency and parallelism, pattern matching, and a compiler. Okay. So if we are to take the fact that folks that are building data science and machine learning applications are using Python, and if we are to take at face value the things that folks like about Python, as well as the things that they wish they had in Python, what exactly is F# and .NET's role? Now, I'm not really going to go ahead and go through all this because you've seen tons of sort of demos how wonderful F# is and different features and things like that. But I'll just call them out, right? One of them, straight up, at the very beginning here, is the fact that you have libraries for any problem. In this case, I'm using F# data to get HTML and download HTML from some website, right? I'm using in this case, there's static typing. Again, there's a compiler that's sort of checking my code. And there's also type inference, which is probably the next best thing or the closest that you can get to sort of dynamic typing inside of a statically typed language from the standpoint of I'm not explicitly defining the types here, but the compiler is able to guess or infer the types that I'm working with based on the code that I have inside of my application, right? You have things like pattern matching, list comprehension, generators, and concurrency and parallelism sort of built in. So in terms of, I'm not here to tell you that F# is the answer, right, to everything. But again, if you are to take those things that folks like and the things that folks wish they had, right, you can see that with F#, you don't have to make a lot of trade-offs, and you get the best of both worlds. Now, in terms of .NET and what .NET's role is, number one, .NET is performant, right? So it performs really well. The runtime is extremely performant. And also the deployment targets. So you can deploy basically anywhere. So you can deploy and build applications for desktop, web. You can build for mobile, IoT devices as well. And of course, you can build AI and machine learning applications, which is actually what we're going to be talking about a little bit more here. So what exactly does the data analytics and machine learning landscape look like in .NET? Well, again, if we go back to that sort of prepare, data modeling and deployment steps within that workflow, you can see that we can use tools like .NET for Apache Spark, which is a set of .NET bindings, a library with .NET bindings for working with Apache Spark. So again, if you're already working with Apache Spark with PySparks, so that's your Python environment, or you might be using Scala, right? Some of the native Scala libraries. Now you're also able to use .NET for Apache Spark to perform your ETL jobs and your data preparation processes at scale, right, across various clusters. And because again, Spark runs in a lot of different environments, this can be, basically in any cloud or any cloud, it can run inside of any cloud provider that has Spark capabilities, right? It's just a matter of getting sort of the .NET, the .NET libraries and the bindings, and then submitting jobs using the .NET sort of driver, right? You can also use the FS Lab set of tools, right? So Plotly and Deedle, which you kind of saw Kevin talk about earlier today. All right, you can use the FS Lab set of tools for preparing your data. You can use ML.NET to a certain extent, right? ML.NET has some transformations that you can filter data, you can impute or replace missing values. So you can do some data preparation inside of ML.NET. And of course, I couldn't find a better logo for this, but essentially the .NET logo here basically stands for .NET Notebooks, which is some of the notebooks that you saw in previous talks. For modeling, again, you also have ML.NET, and one of the things that I didn't really talk about in terms of data preparation, but I will focus a little bit more on here is ML.NET. Which is an open source and cross-platform machine learning framework for .NET. And basically what ML.NET allows you to do is it allows you to not only train custom machine learning models, especially for classical and deep learning scenarios such as image classification, but it also allows you to use pre-trained models. So for example, if you have an Onyx model, right, or a TensorFlow model, you're able to also make predictions with those inside of ML.NET. So it's really powerful in terms of, like, it's not just ML.NET models that you can use, but you can also interoperate. Say, for example, if you're working with folks that are using other frameworks like PyTorch or TensorFlow or something else, you can interoperate with them inside of .NET applications using ML.NET. For modeling, again, you could also use the FSLab stack, so you can use F# stats, as well as you can use flips, right, which Matthew's going to be talking about a little bit later. You can use the SciSharp stack, which is actually, part of it is actually used inside of ML.NET. Some of the TensorFlow bindings for .NET, TensorFlow.NET, is inside of the SciSharp stack, as well as a Keras library, right? Which I believe it's TensorFlow Keras, that allows you to build custom neural networks like you would with, say, TensorFlow or Keras, right? So that's how you would basically go about modeling using these libraries for modeling. And again, you might do this inside of, say, tooling like .NET notebooks. And then last but not least, talking about deployments, again, you can use ML.NET to deploy not only ML.NET models, but also models that are in Onyx or TensorFlow format. You can, of course, leverage the power of ASP.NET Core and the performance of ASP.NET Core to deploy these services as web services. You could also, leverage things like Xamarin to deploy, and I believe Maui is sort of the next iteration of that, right? So you could deploy these models to mobile devices as well, right? So there's a lot of flexibility. You're not only constrained to web services, you can really deploy anywhere that .NET runs. So there's a lot of benefits there. Now, let me actually get into showing you some code. And I'm going to show you how you can go about building an end-to-end machine learning workflow with F#. And basically, the tools that I'm going to focus on mainly are some of the FSLab tools, ML.NET, and .NET for Apache Spark. So let's get started. All right, so what I have here is I have a .NET notebook. And the problem here is essentially I'm trying to predict the scores of a restaurant inspection in New York City. So the data set that I got was from the New York City Department of Health. And basically in New York City, what takes place is their Department of Health typically goes out, sometimes maybe randomly or sometimes maybe on an annual basis. They go out and they perform inspections on restaurants, basically to make sure that the restaurant is sanitary and it's held up to standards, right? Now, throughout these inspections, they log if there were any violations, how severe those violations were, and based on that, they provide a score for that particular inspection that they then use to give a final grade to the establishment that will determine whether the establishment is safe to sort of dine in, or maybe at some point they might end up shutting down the establishment, right? So that what we're trying to predict is that score that's based on an inspection. What is the score of that inspection based on the violations and other inputs that we're going to have for this particular establishment? So we're going to start off with data preparation, and to do that, we're going to use the .NET for Apache Spark package here. And in this case, to install and reference that package, we use #R and provide the name of the package here, which is Microsoft Spark. That's going to go ahead and install it. Now, I'm not going to run this, so you're not going to see the code running live, mainly because this is actually a lot of data, and I'm running it locally, and with cameras and all, you can imagine that this won't be the most performant. So I'm just going to walk you through the code here. So again, I'm doing this inside of a .NET notebook. I install the package. I go ahead and open my package. I start a Spark session, which basically binds to basically the Spark engine that is running in the background. And again, I'm doing this. I did this locally, but of course, you could do this, like I said, at scale, right? Like you run this on a cluster somewhere in the cloud, right? But in this case, I did it locally. I initialize the Spark session, which sets up a connection with the Spark engine. I go ahead and load my data, which is in a CSV file, and I give some sort of options here telling it that it has a header, and I wanted to guess what the schema is. When we print out the schema, you're going to see that we have information. This CAMIS is basically the ID of the establishment. We have things like the borough, right? So in New York City, there's 5 boroughs, right? Manhattan, Brooklyn, and a few others. You have contact information about the place. You have description about the cuisine, when the inspection took place, right? So that's going to be important for us. If there were any violations, what those violations were they critical? And what we're going to be trying to predict is this score here, right? And we're going to provide different inputs from this set of columns. Okay. So the first thing that we want to do is we want to just kind of like, we want to explore our data. So we go ahead and we check out the boroughs here, right? So again, there's 5 boroughs, but here you notice that there's this other 0, which maybe that's like a null value or invalid data. There's only 171 of them, so I'd be okay just throwing that information out, right? It's not significant compared to the rest. I think I have enough data here that it'd be more trouble to try to figure out, what each of these individual rows and inspection rows belong to. So I go ahead and I clean that up a little bit, remove that 0, and then I have this sort of cleaner data frame, right? And data frame in Spark is basically the way that you represent data in this sort of tabular format. Now, viewing my data in this sort of tabular format or this sort of, textual way, I don't really like that. I want to visualize. I want to see plots. I'm more of a visual person. So to do that, I'll use some of the FSLab packages, right? This one here is plotly.net, and I'll go ahead and install that one as well, and then bring it into my application here, into my notebook. I'll prepare the data a little bit, right? Because I need to have sort of XY, I need to have values for my XY coordinates because I'm going to be creating a column chart here. And then when I go ahead and plot that, you see that I get this super interactive, really nice visualization here showing, in this case, it's how many inspections have been done across the boroughs. So you can see Manhattan has the most inspections, and then sort of it goes in descending order down to Staten Island here. Awesome. What if I wanted to visualize or plot where these establishments were? So again, I can sort of look at the latitude and longitude columns here, take those, this is kind of what the data looks like. There's some bad data in there, like some have 0 coordinates, which again, I'm okay throwing those out. And then I go ahead and plot this, right? And again, using Plotly, I get this super rich map and interactive experience for visualizing where these establishments are located. Okay, so now I'm going to sort of fast forward. Let's say I've done all my data exploration, and now I just want to do a query, get to the columns that I need, maybe perform some transformations. So there's this super long query that basically what it's doing is just taking a subset of the columns, performing a few transformations on them to make it easier to read and to feed into my algorithm once I start training with ML.NET. And I run this query. And once I'm happy with that query, I'm going to save it in this directory called process data. If you look at this process data directory here, scroll down, you can see there's a whole bunch of files. And the reason for that is the way that Spark works is it partitions the data and it sort of processes it in batches. So basically each data file here, each CSV is one of those batches that was processed by Spark. So you're going to see here, there's that information. Here's the boroughs, types of inspection, different sort of the violation codes and all types of information. So this is basically the data format that I'm going to be using to train a machine learning model to try and predict the score of an establishment. Okay. So now that we have this data, we ran it, we have our data process, let's go ahead and train our model. So to do that, we're going to be using ML.NET, and we're going to be using AutoML, so the automated ML functionality inside of ML.NET. And basically what automated ML does is, like I told you, you might go back and forth trying to, choose an algorithm, evaluate your model, and that process is very iterative and very experimental. What AutoML does is it allows you to sort of bootstrap and automate that process where it will automatically search different algorithms and different hyperparameters to try to find the best model for you without you having to specify what the best model might be, right? So it's just going to automate that process, and it's really good for beginners, right? So if you're a beginner, you don't really know where to get started, it automates that process for you and sort of provides guidance on how to get started. But if you're an experienced professional as well, right, it also saves you time in terms of automating that process of training a model. So we're going to import those packages. We're going to define the schema. This is basically what the inputs are going to look like for our model and what the output is going to be once the prediction gets generated. We're going to initialize an ML context, which is the entry point for all ML.NET applications. We're going to go ahead and load our data. It's usually a good idea to split our data into training and test sets so that we can perform that evaluation that I mentioned earlier. And then all we're going to do is we're going to say, create a regression experiment. We're going to tell it, train for 5 minutes. This is 300 seconds, right? I want you to train on my training set. And here's the column, right? The inspection score. That's the one that we're trying to predict. Now, go find me a model. Okay, after 5 minutes, it's going to come back and it's going to give me some model, right? And it's sort of stored in this best run model property here. Then what I'm going to do is I'm going to use that model to make some predictions. And then I'm going to compare the inspection score, which is the ground truth, against the predicted value, which is the score, right, on those predictions. And when we print out the metrics, you can see that these are the common metrics for regression type problems. It has an R squared of a very common metric here. This R squared is 0.74, 74%. So It's not great, but good enough for demo purposes. We're going to try making a prediction. Again, we create an instance of that, that sort of, we create a data point here, right, with model input. We create a prediction engine, which is a convenience method for creating predictions. And then we go ahead and predict, and you're going to see that this is the ground truth, 11, and this was our prediction, 11.56. So pretty good, right? Okay, so now we've prepared our data, we've built a model, and we've trained a model, and now we're ready to deploy and get this model out into the world. So how do we do that? Well, here I have a web API that was built with Saturn. So you heard about Saturn, the safe stack in previous talks. So this is essentially a Saturn web API, which, if you're familiar with ASP.NET, ASP.NET Core, this is going to look very familiar. You have a configuration. In this case, I set up a configuration module here, which all it does is I'm registering a service called Prediction Engine Pool, which essentially just creates an engine. It creates an object pool of prediction engine objects. And what this does is it makes the prediction engine convenience API for making single predictions. It makes it scalable, right? So you can handle multiple requests at the same time. And we're going to use that inspection model .zip file. So something I skipped over was when we saved the model, we saved it to this file called inspection model.zip. It's basically just a serialized version of the model that contains information like what your inputs are, what your outputs are, and what transformations are going to need to take place to make predictions and things like that. So we're going to be using this inspection model zip file, and we're going to be, again, registering the service that we're going to use inside of our handler for making predictions, right? So we're going to use dependency injection to basically get that prediction engine pool. We're going to call predict on that, on the model input that's coming in as a JSON request, and then we're going to write out the response to the client, whoever is making the request, right? We're just going to define our routes here. It's going to take a post request to the predict endpoint, and it's going to use that prediction handler, and then just configure this and run it, right? So now we have a web API. Cool. If we were to run this locally, it would run just like an ASP.NET application, listen on port 5000. Great. But wait, there's more. In the previous talk, you saw how you could use Farmer for automating deployments and sort of orchestrating deployments to the cloud. So the next step is, okay, this model's not doing so much for me locally. Let's deploy it to the cloud. So to do that, I have a Farmer script here, which essentially goes over through those building blocks that the previous speaker sort of talked about here. And basically, I set up a web application. I define my ARM template, the location that I want to deploy it to. And then I tell it, hey, deploy my application. So once my application, after a few minutes, it's going to go scaffold my project, deploy my application, and I'm going to get a URL that I can make a request to. So if we use that same input, right, that we used in that notebook to make predictions, we can make a post request to that endpoint, right, to that predict endpoint at this URL. We can go ahead and hit send. Now, this might take a while because it probably fell asleep between the last time that I tried this, like the web service fell asleep, right? This is a service I had already deployed. But you're going to see that after a few minutes, because it's cold starting, right? It's going to take a few seconds actually. So after those few seconds, what's going to happen is I should get a response. You probably can't see it here because it's super transparent. But essentially, I should get that response at some point, and then any subsequent requests that I make, it's going to take significantly less time to sort of process. So yeah, so there it is, right? So there's that response. That's my ground truth, and this is the prediction. And again, as I showed you, right? If I were to do that again, it basically comes back instantaneously. So that does bring me to the end of my talk here. Let me go back to this here. If there's any questions, you can check out the resources here, and I'll take any questions if there are any.
Thank you so much, Luis. That was amazing. Unfortunately, we don't have any time for questions, but there are a few on Twitter. If you want to go head over there and search the hashtag .NETConf, there are a couple questions you can answer.
Cool. Yep. All right. I'll check those out. Thank you.
Thank you so much, Luis. This was amazing. And for those who are getting started with .NET F# or know of anybody who is, please don't miss me and Luis tomorrow, 8:30 a.m. Pacific on Learn TV. Yep. Thank you so much for the Let's Learn .NET F# event. Thank you so much.
Thanks so much. See you folks tomorrow.
Bye. Well, that about wraps it up for my hosting for today. Thank you so much, everybody, for joining me. We have a lot more to cover. And in fact, next up, we have Don Syme teaching Guido F#, which is very exciting. I can't wait for that.
Yes.
Yes.
It is. There is so much cool stuff to hear from them. My gosh, Jamie, thank you so much for hosting.
Thank you. Thank you so much, Jeff. Bye, friends.
All right, we'll say goodbye to Jamie. Wow. Okay. So and I know we're starting just a little bit late. Here's what's going on. Our friend Guido's on holiday. So just a few days ago, I was able to coordinate and get together Don Syme, right? Lead language designer, inventor of F#, and Guido van Rossum. And Don spent some time teaching Guido a little bit about F#. Let me play the video, and let's catch up and see how it goes. Hey friends, my name's Jeff Fritz, and I'm here with a couple of my colleagues so we can learn a little bit more about F#. Let me bring them in here. I've got Don Syme and Guido van Rossum here, and we're going to learn a little bit more about F# from gosh, Don, who's lead language designer for F#, and we've got Guido, who's the language designer for Python. Welcome in, guys. How's it going?
Hello, Jeff. Thank you for having us on the show. It is a real privilege to be here today.
Hi, Jeff. Yeah, looking forward to it.
So I understand a lot of folks, they want to go through that beginner process. They want to learn about F#, and what better way to go through and learn that those first steps to get started with F# for other folks who know other languages than, gosh, to see two language designers go through this together. I think this is a really great idea.
Jeff, I am so honored that Guido agreed to do this, but in fact came up with the idea and the format. I think he is setting a wonderful precedent for language designers worldwide and for into the future to say, hey, something new, something different. Let's take a look at it.
I need to give credit for the idea to Steve Holden, who once, many years ago at a Python conference, held a session that was Teach Me Django, and he actually let the audience teach him Django. It was very entertaining.
This is how we learn. Step outside of our comfort zone, try something different, and hopefully have a good time with it. So, gosh, I'll let the two of you go to it, and I'll just be here in the background if you need me.
All right, that's great. Guido, all set for a session of learning. Don teaches Guido some F#. So all set?
Yeah, I'm all set. I have tried not to read anything about F# in the last 2 months.
Okay, coming at it
so
clean, coming at it fresh. That's great. Now, today, the material we're going to be going through, I will share my screen, is at github.com/dsyme, and it is Guido Learns F# is a repository. Now, we have done a little bit of setup for this just in the 5 minutes before we started, and Guido has cloned this repository and pulled the latest changes to it. And there is also a guide in the repository, a guide.pdf, and Guido has also done the installation of the prerequisites, which is the .NET Core SDK, Node, VS Code, and the F# extension for VS Code. Running through those steps quickly to orient those following along, please do, if you're following this, please feel free to kind of pause the video as you go along, do the tasks, and then compare as we go along. And so there's the repo that we've got. There's one of the setup steps to the .NET SDK. Guido has promised the .NET team some feedback on their installation page for whether he found some things that need to be fixed. So that's all the way along when you're doing this kind of dojo. Those are the kind of things you fix and you notice, and as you work together, you kind of make these experiences much smoother and much more intuitive. You also will want to install node.js and npm, and some of you might be thinking, I'm installing Node, why am I doing that? F# is a .NET language, but F# is also a JavaScript language, and we will be using it as both a JavaScript and .NET language in the sample today. You are installing VS Code. Some people in the past have accidentally installed VS Code by snap. Don't do that. Install it just the way it comes. And you will also be installing the F# support for VS Code. You'll probably get an automatic prompt for this if you don't do it yourself, the ini.f# package. And we are now going to dive straight in. I'm going to close my screen, and Guido is, I'll click the stop sharing, and Guido will share his screen. Okay, so we got VS Code open, and the pre-steps that were necessary were to do .NET, to go to the repository directory and then do .NET tool restore, and then .NET run. And that restores the projects, gets the dependency chains, and then runs the application that we're going to be building. And Guido, I think you have a browser window there with just sized quite nicely to fit down the right-hand side. Okay, we are now running so the way this is going to work, just to give the format, is it's a dojo. And Guido learns F# are a dojo. And in fact, it is a set, so we'll do a set of tasks, and then we will land Guido in the middle of an application, which has been sort of left in a half-finished state by someone who was trying to help him out, but didn't really work out that way. And Guido's got to fix a lot of things with this application. And they're grouped in 5 clusters, 4 main clusters, and then one is a bit different at the end. And but the application does compile, and it does run. So and it's actually a client-server application, a web app with a server backend. And Guido, if you do the magic URL for accessing the locally running one, and not that one, and localhost. Here we have the application running, and I have heard, one reason we're pre-recording this, so Guido is having the amazing good fortune in 2021 to actually travel. And in fact, I've heard you're taking a trip back home to Europe. Is that right, Guido?
That is correct.
Well,
we'll see about the good fortune.
I understand.
I've been bombarded
times.
with emails reminding me of all the COVID precautions.
I see. Yes. Well, this. So someone was helping out Guido with his app for his trip to Europe. It doesn't cover any COVID dimensions. There will be only one small mention of COVID in this whole exercise, and so someone has been trying to help out Guido. Let's see how this app rocks to start with. So you can give the app a try. It's actually asking for a postcode. And it's asking, I know you are originally from the Netherlands, one of my favorite countries in the world. And you can type in any Dutch postcode you wish and see what you get. Okay, and you can hit fetch. That's it. So you actually you're not the return. You can just click on fetch. Yep. And
I have no idea of the distribution of Dutch postcode, so I'm just going to enter something random.
Did you click on fetch there, Guido?
For the first one, I did.
No, okay, we've got a problem of some kind. No, I think you didn't click on. Okay, great.
Maybe I didn't click. Haarlem.
Heart attack moment
Haarlem,
when it wasn't. I thought it wasn't working, but it is. All right, that's grand. And feel free to put in a second stop here.
From Haarlem to Amsterdam. How appropriate.
That's absolutely great. Okay, so the app is in a kind of half working state. And now where helpfully the person who left this app kind of half finished did leave some notes about where things needed to be done in the code. So we're going to be using the search all code, the magnifying glass on the top left, or feel free to use all your favorite keystrokes. I know you're a VS Code user regularly in your Python programming, if I understand. So all the usual key searching and should work just fine. And you can search for the word task. Yeah, no, not capital, and make it a capital T on the task, and may as well put on a whole word and whole and capitalization just to get us down. And you can scroll down there, and we can see a list of tasks that will need to be done. And fine, okay, great. And we can, in fact, start with task 1.1. Now that's the one in the README. So if you actually scroll down to the one in the code, I'm not sure why it's saying yes. That's just saying you'll do that. And we can start with task 1.1. Okay, so they've left a note saying the text is wrong. What is this tooth stop business in the app? Now, it's not a major bug in trip planning, but it is big enough that we want to kind of fix that.
You want me to try something? Well, can I just start typing because this looks easy enough?
You can just start typing. Now, I do know that Guido has some experience with Haskell and is fully conversant with the idea of pattern matching, like all programming language designers these days are.
Well,
And,
we're introducing them in Python too, actually.
That is absolutely wonderful to hear. We are infecting the world. I love that. So if you can save that file now, that would be great.
Isn't it? Okay, for me it's usually set on autosave, but that seems project specific or something.
Okay, so
Something
first task
saved.
is fixed. We have second over on the right.
Oh.
So we have a hot reload
Okay.
experience in this development experience, which is looking good. So you feel free to pop in a few more. We'll probably do no more than 4 stops today to test things out. That's absolutely fine. Third stop.
Okay, it does actually. Where is 7,000? Oh, I guess enter doesn't work yet. Try another postcode. Okay.
That means you got a validation error on the server side.
Try another postcode. Okay.
Feel free to use the browser to look one up if you wish. You can use 1011 if you like.
Ah. Third stop, Tessel.
Okay, Tessel.
Excellent.
That's looking good. Okay, and we've still got the fourth. The fourth is looking okay. In fact, after we don't need to fill in the fourth.
Yeah, no, I'm just gonna fix the layout there.
Yeah, lovely, excellent. Even learning how to format F# code. That is excellent. Okay, task 1.1 is done. That's great. Let's move on to task.
Oh, that is, huh?
2. Yeah, but these start nice and simple, and you can take a look there. Just two things above. That's it. Task 1.2. That's great. Yeah, that's very helpful.
Okay.
Okay. Now I think make the probably make the search box on the left a little bit narrower so we can see a bit more of the code. I think you can narrow that down until we see that.
Yeah.
That's it. And if it's possible, I don't know if it's easy to hide that bar down the right, that changes bar.
I have no idea.
Okay.
I once knew, but we can make an excursion to configuration.
Yeah, that's fine. Okay. Then maybe make the code one thing smaller so you can see your application and the
like that.
Yes, and now over on the right, make that we can see the application at the same time as developing the code. Since we'll be doing a lot of hot reloading, yeah, that's looking perfect. Yeah.
Okay. It looks like I can make that quite a bit narrower.
Yeah, you can. That's right. Okay, so task 1.2. Now, I'd like to take a moment to orient yourself on where you are and seem to understand what part of the application you're actually developing here. So if you just scroll up until you see the let on line 252, it says let location display, and taking a location response as an argument, and we use equals. And then it equals, let's say, a table, a t-body, a tr, a th, a td, a tr, a th, all the way down. And you can see this is actually an HTML DSL in the web application. So this is sort of generating generating HTML
Oh my.
programmatically. And you can see let's check out the correspondence. So if you see the line th region, so this is the string region. In fact, you can edit that to something else if you like, just some random text, and save. Then over on the right, you'll see the exclamation mark. So you can see where we are in the visuals in terms of that's the header of the table column. And now we want to fill in this to-do here. And we need to find the region. And it does give you a hint. You might fill in the region found in the location response. And replace the string to do with, for example, you can see the location response that we have. LR location response is the argument.
Okay, let's lead. You've been talking a lot, and I'm trying to read what we're going to do here. I should have warned you that I'm not a web developer, so
it's fine. You are today.
I'm like, oh dear, do I still know how tables work in HTML? Because that was a while ago.
Yeah.
So what we have LR, which is a location response, and there is LR.location. Okay, if I just put LR.location, like the comment says, location. Okay, if I type that in lowercase, it'll whatever autofill will still do that correct. Then hit dot for the region. Oh, yeah, I had hit tab, not return. Okay.
Yeah, that's the one.
And let's see what happens when we save North Holland. Yeah, it's all North Holland.
Everybody's just in North Holland. That's right. We don't know the postcode for Maastricht or one of the places in the south. Excellent. You've successfully become a web developer today, Guido, filling in content in an HTML DSL. So
I guess we go on to task 1.3a.
That's correct. We can go on to 1.3a. Okay, we have our only mention of COVID for the day, which is that we have distance to Heathrow. Now, as you know, COVID is running rampant here at the moment, and you do not want to fly to Heathrow. I can be sure maybe you're passing through. I don't know, but I think you'll be flying to Schiphol, which is...
In fact, I did manage to find a direct flight. Lucky us.
All right, indeed. Lucky.
But that changing the text doesn't suddenly make it change. So where do we find?
Correct. So save the text. That's right. And
still save that. Okay.
Yeah, just keep saving. Save off.
Yeah, but now it's much more obviously wrong.
Exactly. Nowhere. Nowhere.
What I remember of Dutch geography.
Probably nowhere in Holland is that far from Schiphol. Maybe it's right at the top right. I'm not sure.
No, maybe Maastricht.
Okay, so this thing distance to airport is wrong in some way, and we can actually search for. You can actually either. It's up to you. You can actually search for distance to airport if you like, or you can search. So you can see. Helpful. Yeah, so you can see the text. The number is coming from LR.distance to airport, and you can do a search for distance to airport. That's fine. Or you can actually do a right-click, go to definition, and on the search, could you put case sensitivity on, just so we get the actual.
I always forget which one. Okay, there's that.
And you can put on whole word as well. We won't want to do function searches. That's right. Okay, so let's take a look in shared.fs. In the search list down the left, you'll see there are 3 results in the search for distance to airport. One of them is in index.fs, or 2 of them are in index.fs. One is in api.fs, and one is in shared.fs. Let's take a look at shared. This one here. This is the definition of the type, which is the location response coming back.
Okay.
Okay, and now
looks like a dictionary to me.
Yep, that's right. It's just a dictionary record type, and that's right. Now we're looking at api.fs. If we take a glance there, we will see the distance to airport being calculated. In fact, you can see it being calculated here.
So there's a reference to London.
That's right. Now to change, yeah, that's here. For this one, I'd like you to do a right-click rename symbol on London, just so we start using.
Oh, we're going to actually use the refactoring.
Oh yes, you're going to be refactoring. That's it.
I hate that, but sure.
That's okay. Schiphol, it's good. And,
it's probably loading the code for refactoring because I've never used that in my life.
Yeah, good.
But there it is.
And you can now save that save as often as you want. I'm a bit of a saveaholic. It's kind of always saving my code.
Sure, but we didn't change the lat long. So
exactly, task 1.3c, exactly.
Let's just Google that.
That's right.
And let's hope that Google just used decimal fractions. Okay, go back to this thing. Save.
That's right. Now,
okay, that didn't actually.
Yes. Now, but you will have to make a new request over on the right. You'll have to, for instance, reload the page and enter some data. This is because you just changed the server part of the application, and you have to reload over on the client side and re-enter the postcodes.
I see. I see.
That's it. And you can hit.
Oh, and I never hit fetch for anything. So
yeah, we have independent fetch buttons. Yeah, that's right. All right, so I think the distance to Schiphol is looking pretty good there.
Yeah, I don't know what happened to Haarlem, but try that. Yeah. Okay. Here we go.
Okay, 12 kilometers. I love it. Okay, that is great. And now we fixed the distance to airport. We've got all the references to Heathrow and London, and that is great.
All the impressive stuff here is done by databases that apparently know zip codes. All right.
Yes, we are using a web service that knows a zip code, absolutely, and I can dig into that in just a moment. Let's finish off on task 1.4 and then have a chat about the architecture that's being used and the mode of programming and some of the language features we've been seeing along the way.
Okay, some error.
Okay, we will dig into this in a bit, but try an incorrect postcode of some kind over on the right and put in half completed. All right, now it is saying invalid postcode there, and it is saying it in green, and that is obviously not the color we want to use here. We'll just fix a color here, but the actual what we're going to be coming back to is actually
your audience is not going to be able to read that, but
it says invalid postcode. That's right, and so if we just change this to the danger color is danger, and save. But
I see.
Yeah. Danger.
You actually have a sort of a little enum of various colors, or I don't know what it is. Is it an enum? Is it a structure? Oh,
it's a generated API.
Okay.
Yeah, so it
did automatically refresh when I saved there.
Yeah, that is great. So that is our initial set of tasks, and that is absolutely wonderful that we've been going through those. Now I will. We'll talk about some of the things that we've seen along the way. And I just want to walk through some of the things we've seen along the way. And the first is that so much of F# programming is let. You saw the let function definitions we were doing. You saw the let Schiphol for defining let London equals finding
in fact, it's so ubiquitous that I don't remember even seeing it.
Yeah, that's right. It is just absolutely everywhere, and there's a let.
There's one. Yeah.
And or a little bit. The first function you defined was this adjective thing. And so that's defining a function. You use let to define data. Now, in Python, of course, you don't have let at all, but you're just doing a very similar kind of thing. You've got your defs for some kind of things, and the values don't actually use let. But actually, and we'll be looking at an example later on of if you just take F# code and strip out the lets, you often get very close to Python code. It's a very similar mentality between the languages, I think, which is it's about defining some values, about defining some data, and then working with them. And that has been the fundamental mode of programming for. This might be a little bit more oriented around defining functions to work with things, but still, it's just let all the way through. The next thing, language construct you saw is match, and that was the very first thing we saw. And as you're familiar with pattern matching, you just take an expression and then you match it against various patterns. It's it's an absolutely core construct in F#. It is just forms so much of how you do decomposition of data and then taking various cases through. There is an if then else. You use it for Boolean values, but besides that, match is kind of the way you take different parts in your code very often.
That's going to be an interesting direction we're taking in Python. We just in 3.10 we're introducing that, and it's going to be interesting to see how much of the Python community will actually switch to using match, and to what extent people will just keep picking things apart using if then else.
Yep, I understand.
Like they've been doing for 30 years.
Yep. And C# is in a very similar position. It's put in actually a very rich form of pattern matching. There are even a couple of things that they've done, which we will include back into F#. And there's some things we definitely won't include back into F#. That would be a longer conversation. I'd be happy to have that conversation with you about Python as well from my experience. But it is absolutely fascinating to see these languages bringing in these features and how that kind of changes the kind of development side of things. There was another use of match further down in task 1.4, which is showing in your search bar on the left. If you just want to double click on that, it's just further down in that file. And this was this, you can see a different pattern match saying, when we're displaying the help text, check if there's a validation error. And if you hover over validation error, you'll see its type. And it says it's a string, an option of string. Okay, so options you match with none or some, just like in Haskell and many other languages. And and if there is no validation error, then we don't generate anything. And if there was a validation error, then we show the text, prop.text on line 348, and we set the color to danger. Okay, so this is even when we're generating HTML, and we'll get back to this in a little bit more after task 2, when we're kind of generating these structures, DOMs, we use pattern matching to work out what we're generating.
I'm actually confused about what's happening in the sum error case. I understand what the sum error part does just fine, because that's like matching a pattern sum with a that has an attribute error, but I don't understand what the color dot is danger and prop.text error do. Is that things with side effects, or is that still part of your mini HTML? DSL?
We will be talking more about this in. It's a general construct called computed lists. So if you look at on line 338, the help that you've got there, the kind of help and then the square bracket. It is generating a list, either empty list or a list with 2 elements. And so...
This is like a very fancy generator. Yes.
It is like comprehensions or generators on steroids, and it is a really powerful construct in F#. And if you actually look through this file, and we'll be talking more about this in a moment, or we can talk about it now.
I suppose
your language design eye spots this immediately. It is one of the most powerful constructs in F#, and it is incredibly good for generating data lists of all sorts of crazy shapes and sizes. And
so is it? Yeah, I see. Is this help? Is that just an attribute on property?
Help. I think if you just hover over help, I'm actually not. This thing is generating a help React element. So one of the standard React elements for CSS and everything else is help. And so we're just generating some help, and then the CSS will look after how that gets displayed.
Something in Spanish showed up there. Full name, Feliz Bulma Bulma help.
We have some great members of the Spanish community. That's actually a really good place to segue into section 2, where Spain does appear. But before you do that, we just run through the lessons from on the slides over on the right, just to cover all of those. One of the other things you saw was dot notation. And so F#. You saw lr.location.response. You just saw it supports
feels very
program.
Similar.
It feels similar. It's funny. It feels similar to C# in that it is static. Those property resolutions are static. They're not dynamic property bags. Like in Python, it is static resolution of the dot notation. Because F# is a statically typed language, and in fact, that difference between dynamic property bags and static.
What is this bag word you're using? That sounds like pejorative. That's probably just sort of functional language lingo, but I don't know what a bag is.
When I say property bag, it is just a technical term, meaning a dictionary.
Okay, yeah, I guess F# people are more familiar with the term property bag.
Yeah,
but I have not heard that one before. Okay.
In fact, they're probably using the term incorrectly, actually. So let's just call it a dictionary with either static keys or dynamic keys. If a dictionary has static keys in F#, it's called a record.
Okay.
If it has dynamic keys, it's called a dictionary.
Mm-hmm.
But we won't be using dynamically keyed dictionaries here today. We'll just be using records all the way through.
Is that similar to how it's done in JavaScript?
It's
where object sort of you have two notations, but they map to the same underlying data structure.
I'd need to check on that. I think it's similar to how it's done in C#.
But I don't know C#, so that's not helping me. Right. Sorry. I know Python. I know just enough JavaScript to be dangerous. I've read them.
Yeah. So when you move across to these statically typed languages, then you have to split the world, and it is one of the reasons why working in a statically typed language is a little bit harder in some ways than working in Python. You get benefits from it, but you have to split the world into what we statically know and what may kind of dynamically change. And in these, when you have a static type, like the one we saw for location response, it will be called a record, and it will have a static set of keys that don't change at runtime. And if it's dynamic, it'll be a different type called a dictionary, and they can change at runtime. Now, TypeScript is the leading language which kind of merges these two worlds together. F# keeps these worlds separate. You either choose in your coding to work in a static record, or you choose to work in a dictionary. But TypeScript is an interesting blending of this world.
That feels familiar from C++, which I do remember a few things about.
Mm-hmm. Got it. Yeah, and any attempt to statically type Python code is going to absolutely have to land in that kind of middle space, like TypeScript. Yeah.
Yeah, we do it very similarly as TypeScript.
Yeah. Right. You also saw some strings. We won't particularly go there with nothing particularly interesting, and we've discussed this now. F# is a strongly typed language. You can hover over things. The IDE knows your types and checks them on the fly. Excuse me, it's quite
You'd be surprised how good the IDE is for dynamic languages like TypeScript and Python.
I absolutely am aware how good that material is getting. F# is like on the spectrum of kind of how much typing it asks you to get right before it runs your code. It's definitely on it really checks your code and quite kind of deliberately designed to be tight, I guess, and to whereas TypeScript, for example, well, it has various modes. You can call it strict mode and things like that. So.
Oh yeah. So if I sort of change this property name, it immediately complains.
Exactly. It wants to know.
Yeah. So I was wondering if we could sort of, I don't know what the term is, lift this match out. If we could put the match at the outer level and say, if there is no validation error, then don't generate a property, or otherwise, if there is a validation error, generate help with blah and blah.
Absolutely. Why don't you give that a go? I'll also, you should be able to flip.
Yeah, I'm not going to try to use the refactoring.
No. We don't even. In fact, one of the nice things about F# is that you can do a lot of refactoring simply by indenting and undenting. So.
Yeah, I probably have to. Oops! I've done that a little bit.
Yep.
I didn't want that line there. And that looks like it goes there. Now, I don't see any squigglies. Let's see what happens if I save that. Where was my thing?
Yep.
It says invalid postcode. And now it's not invalid.
Yep.
Okay, well that's actually pretty nice.
Thank you. I think that does. Excellent. I like it very much. The code is better. F# knows how symbols resolve. You just saw a rename, and so you can support these kind of refactorings. Which I'm with you, Guido. I don't use those refactorings that much. I do use rename refactoring.
And it's not really the language that knows how symbols resolve. For the refactoring, it's the fact that the editor knows, right? Or is that the editor and the language are still separate pieces of the world?
So when I'm saying F# knows, I mean F# is designed to know. The F#, so F# is symbol strong, you might call it, in the sense that it knows whenever you have a symbol in your code, it will know how that resolves, and it will resolve to something static.
Funny, interestingly, in Python, scopes of variables are about the only thing that is statically known.
Mm-hmm.
Like the Python compiler, if there is such a thing, doesn't know the types of things. It doesn't know the difference between a function, a class, or an integer variable.
Mm-hmm.
But it knows which variables are locals, which variables are globals, which variables are sort of part of closures, and all that stuff.
Mm-hmm. Yep. Understood. And it's interesting. Yes, it's we use these terms like statically typed or dynamically typed and so on, and actually prefer to kind of analyze different properties, just like you were saying. Like, how much does the language know about symbols? Okay, and it because it just doesn't cut the world into two kind of things. You can actually look at every different language and make that same kind of judgment about what it's doing. Okay, so we can now. We'll just look through a few more slides. Run through them quickly. So the aim is to achieve three kind of things. We do want a kind of succinctness. You'll notice F# code is pretty succinct. You don't type annotate everything. It's got if you strip off the lets, you can sometimes believe it's almost like Python sometimes. But we do get the performance of C# and Java because everything is ultimately statically resolved. And we do aim for, we sort of touched on that with this question, what do we mean by static typing and how much do we check? And those lines are being blurred all over the place today with languages like TypeScript and Python being typed and so on. But we want a kind of robustness and a kind of, with a tradition, I guess, that's coming from the strongly typed functional programming languages. We don't think of...
So let's clear up a misunderstanding. I somehow always thought that F# was in the family of functional languages, but you're not even mentioning that here. And
I mentioned strongly typed functional programming, but F#, all these languages support functional programming now. It kind of comes from a tradition of the functional programming languages, but that's not what matters to me. What matters to me is the properties we deliver and the experiences we deliver with it.
Right. Yeah.
And I actually
that makes sense.
I've actually broken a lot of the rules of functional programming, and along the way, there's a couple of talks I can point you to maybe, or we could talk separately about that. There's a history paper on the early history of F#, and sometimes, we deliberately did things differently because in some ways we're trying to take, we'll credit the Pythonic kind of spirit and to bring it into the functional programming world. We're also taking elements of the object spirit and bringing it into the blending that with functional programming point of view. We do keep this emphasis on immutable data, or what we call functional first programming, where the place you start is with kind of immutable data, functions, and working with those. Okay, but then you bring in aspects of mutation. You can do mutation. You can do side effects in F#. You can put a print statement in the middle of this. I don't know where it will print to in a web browser, but you could do logging and everything. It's a lot of things. Yeah, and we bring in object. So I mentioned object programming. So some functional languages like Haskell haven't really had their full reckoning with object programming. They haven't really kind of worked out how to combine the two. F#, we've done that.
It's sort of, yeah, there are corner cases of the type system that are deeply affected by that, right?
Absolutely, and the major, probably the biggest part of F# is delivering a type system that kind of blends these characteristics while keeping this, well, to deliver these three key things. I just scroll down just to orient people. This stuff will be familiar to you on the slide. So this is our structure here. Some of the code in index.fs is the web client. It's actually being compiled to JavaScript. And so you're writing JavaScript in your, you can see on the top of the bar of the editor, you'll see index.fs is your current file. And this is getting compiled to JavaScript. And if anything in API.fs is getting compiled to .NET. And shared.fs is actually shared code between the two for validation code and things like that. So F# is absolutely a JavaScript language as well. The JavaScript tooling is provided by the F# community. And you could say, Mark's in terms of delivery, we all contribute to everything. The .NET existence of F# is delivered and curated by Microsoft at full enterprise quality. Okay, the architecture we're using in the web client is called Model View Update. It's MVU. It's a bit like React. There is underlying is a model. It's got a view function that generates the DOM, and then that DOM gets applied to the actual DOM. Like the diff gets applied. And then you get a dispatch function which sends a message. It goes around the update loop, and it goes round and round and round. The important thing here is the view function is which you've been editing the bits and pieces of the ultimately packaged up into the view function. It's just a function that takes a model and computes a view, and it's just functional programming. In a sense, you calculate the view you want. So in lines 3 through 8, where we did that pattern match. And then you did your modification. You are calculating the DOM components you want, given a particular state of the UI. That whole thing is just a functional calculation. When I say calculation, I mean kind of, you know what I mean. It's just a pure function.
Yeah,
it's just
It's sort of starting here, like that destination entry section. That just describes a piece of HTML.
Exactly.
Right?
In fact, if you go to the bottom of the file, you will see the complete view function. That's it here. And it should add up. If you open up the app that we have in the browser window. This one here. And the structure should sort of matter. It should match. We have a model coming in. We have a dispatch function, which is a function which allows us to dispatch, and that's at the top of the view function. The arguments to the view function on line 436, and so on line 436. So you see we've got a model.
Takes a model.
And the dispatch is a capability to do dispatch. It's a function which you can dispatch new messages with.
Okay, that part of the syntax is not super clear to me yet.
Okay, so the view is a function you're being defined, and it takes two arguments. Okay, it takes a model and a dispatch, and
so I'm confused why the model is in parentheses and the dispatch is not.
The model is in parentheses because it's got a type annotation.
Oh, that's so different.
Yeah. So it's because
in Python you would just put parentheses around the whole argument list.
That's right. So a lot of
I see. Okay, I'm getting the syntax now.
Cool. Great.
Yeah.
In fact, why don't we take this as Well, I was just going to mention is if you look at these lines, if you I guess line 445, line 448, line 452, you can see us laying out the destination entries. And
yeah,
then,
here's a for loop that I guess the destination entry is the sort of the input box where I type the zip code.
it's the whole of one of those boxes. Yes, that's right.
Yeah.
So and we always, on line 448, we always add an empty one at the end. Okay.
Okay, that's where you add more.
Okay.
I see.
And then on line 4.
Okay, so I see what you mean by that. The sort of it's comprehensions on steroids, because you have a comprehension part here. That's those two lines.
Yep.
And then you have just one extra entry.
Just an extra one. That's right.
And in Python you'd have to use a star and some extra parentheses to do this, to sort of combine that.
That's right. And and so some of these languages have these generators which are very good at doing this sort of thing, yield, or whatever other syntax they use. And I know Python has things like this too. So this kind of combines comprehensions and generators into one.
I'm confused actually why there's a yield here and not in the other places.
This one has a yield bang. This is because it may produce, the way destination info section is written, it may produce multiple entries. If you want to yield, so destination entry section just yields one element. But if you want to invoke something to yield multiple elements, you've got to make the yield bang explicit. Okay, if you look at the type,
so are you saying that we don't really need the yield here? Could I just get rid of it, or will it not work?
It won't work, because you will be told, hey, this thing, the syntax is telling me this is yielding one element, but this is actually yielding multiple elements. So you can take it out if you like and see the error that comes up. I probably regret how bad the error. Yeah, okay, the error is not that great. Could you put that back in? that error message is not the best in the world.
Okay. And so we don't need that in the previous, the first section, because what exactly?
If you hover over destination entry section and take a look at its type, you'll see that it's
React element.
It's producing a React element. Now do the same thing for destination info section. You'll see it's producing a list of React elements. Okay.
Okay. So the yield, in a sense, is sort of flattening that list.
Exactly. Yeah.
Okay.
Yeah. So you kind of got to. Yeah. Cool. That is great. We've covered a lot of topics that we're actually going to do.
I think we're not going to get to task 5, right?
We will get to task 5 because we will skip task 4. So let's do task 2, and I'll take a glance through the lessons along the way.
Okay.
And
1. Problem: we would like to add maps for each stop.
Yeah.
Whoa. There's also a weird thing here that I think that is just because the line is longer than.
Yes, it
okay,
shouldn't.
Yeah.
That shouldn't be there. You can delete that. Those 2 characters out. Yeah.
I thought it was funny extra syntax, but then I realized it was green and there was no line number. Okay, so what do? We add the map widget. Well, I'll just type map, and
it does tell you what function you will need to use to create the map widget. If you look at those instructions, it gave you a bit more information.
Yeah. Map display.
Yeah.
Okay, so this is like, do we just add it like that, or do we wrap it in, like, I mean, up here I see things added in columns, and again my HTML is rusty.
This is not HTML. This is a DSL, F# DSL page.
Yeah, I know, but it maps to HTML, and so, yeah. but that for most people that is helpful, but for me, you still have to explain what the structure of the syntax of the DSL is, and so I'm just going to type map display and.
Yeah, so 415 gives a pretty good guide, which is where line 415 is a pretty good guide to the sort of thing we're going to want. So that's laying down a React element for the location display.
give it, we can use location again. I don't know if a location is a location response though.
You can, if you're interested in knowing, you can hover over on line 415 and check out what the type of location is.
I have some kind of Git thing.
I don't know why,
that is...
but at the bottom it does say location response. Yes, there is the val location.
Okay,
is the
okay.
location
Well,
response.
then I'll just type that. And now I'm curious, is that all we need?
That is all we need for task 2.1.
Okay, and now we have to refresh or not? Oh, wow. And it shows a map for Madrid. So,
okay.
Wow, fascinating. Do they all show maps for Madrid or? Oh yeah, the map widget needs to be told what to.
And you've predicted what task 2.2 is.
Yes, that's what task 2.2 was, but our friends Don and Guido, they had so much fun teaching each other that they just kept right on going. And literally, we've got about another 45 minutes, another 50 minutes of them teaching each other. It is really great stuff. We're going to make that session available to you along with all the recorded sessions throughout the day today here on .NET Conf over on the YouTube channel, youtube.com/.net. We're going to have a playlist going up there in the next few days with all the sessions from today. Let me see. I believe my friend Don is here. There he is. Hey, Don, let's bring you on. There's Don.
Hey, good to have you. Yes, it was a lot of fun recording that session with Guido. It was a pre-recorded session for everybody online, so I'm glad you got to see the first half of it. And yes, as Jeff says, the second half will be coming out any time now. Yep. And there's a lot of good and interesting content in the second half as well. I was watching some of that. I was very happy. One thing I really noticed along the way was how much we were using the types to orient. How much Guido ended up using the types to orient, even though he's not used to using like that. I think he uses Python in a well-tooled environment that does give some hints coming back. But in F# you get a lot of type information. He's able to hover over those different things, and he's learning about the language. You know, he saw, oh, this yields one element, this yields multiple elements. He just saw that in the types and bang, he knows what it means straight away. The types help to understand the language, and there's this interesting kind of thing going on with that.
And there's a segment where I don't remember if it appeared there or if it's in the full recording. There's where he looks at that location. I think it's it's literally in the next 5-10 minutes. He learns to hover over the location property and he's able to see what the latitude and longitude properties are for the location object, and he's learning the type system.
That's right. I think that's the point where he hovers over a type annotation and it shows the definition of the type at that point. And it seemed entirely natural, I think, in the way that experience came across. He was just entirely comfortable with using rich type information to guide his experience, and I liked it. I loved the bit where he just, we're talking about how strong naming was, how strong symbol resolution is in F#, and he goes and just changes help to something else and gets a red squiggly, and he says, and immediately he's got that. He knows what the language knows and doesn't know, what it's checking and not checking. I loved it. And another thing we saw, I think, in Scott Wollashen's talk a lot, I think it comes across later in some of what we did with Guido, is the very nicely done inline where it shows the results of type inference in those nice gray sections of the code. And I think Scott Wollashen did some editing and just showed, look, if you change this to an equals, it changes it to bool or something, like shows the type inference going on. And Guido really saw that as well. And I think it's really coming across to me how easy it is to learn F# in these in Visual Studio Code. Because type inference is just done so gently for you, so automatically, so nicely all the way through. So.
There's definitely something to be said about IntelliSense helping folks learn how to use a programming language, how to use a framework, and I think we're seeing the evolution of that here over over the last few weeks with updates to IntelliCode, with updates coming with GitHub Copilot, and it's as those tools evolve, it's going to make working with these languages and jumping between languages even easier.
Yeah, I think that's right. I mean, full credit to, we had Philip and Christoph's session on F# editor tooling, which was just on about 2 hours ago. And if you just joining for this session, please go and watch that as well. Just showing, because those, Christoph and the F# community have built on top of what the F# compiler service, a core component, kind of delivers, and built these wonderful tools in Ironide, in which is what Guido is using there in Visual Studio Code, and it's just beautifully done F# support. A part of that is this point where Guido asks, is this the compiler or the IDE that knows this stuff? Okay.
Yeah.
In F#, one of the things Christoph likes to point out is that the F# implementation is really sweet and tight with this, in that the compiler, the thing that actually runs your code, is used for the command line compiler. It's used for F# Interactive, but it's also exactly the same code that ends up in Visual Studio and ends up in Visual Studio Code and Ironide and in other places, code spaces. It's one implementation of F# in a sense. And when we add a feature to F#, like we added, say, string interpolation, it just flows out into all these tooling environments automatically.
Oh, very cool.
Now, do we have a few questions from the web? Or?
We do. I was going to bring that up here. Let me see if I can add them in here quick. There we go.
Here we go. A bunch of questions. Great.
Let me go to this question first from our friend Beth. So how was it teaching F# to Guido? Were you nervous, excited, maybe a little bit of both? And did he give you some ideas to take back to improve F#?
I really enjoyed it. The thought of doing the session did concentrate my mind on a few things with regard to F#. We are thinking of changing the index notation, and it was definitely partly the thought of teaching the language to Guido that made me think, maybe there's something I should take a good look at.
Yeah.
I'm pretty happy with the core features of F# though, and how Guido interacted with them, with the pattern matching, with the let, and the we later on we do talk about type definitions and a little bit of object programming and a few things like this. I mean, there's this thing, I think you always, whenever you're teaching a language, especially to someone like Guido, this simplicity thing is going through your mind all the time. And F# has, I was really happy. I think F# has a very, I mean, obviously the session was largely about code comprehension and a little bit about the language constructs. We weren't like writing loads of code, but I'm pretty happy with the simplicity thing we have going on. In the second half, I should mention, we get on to pipelining, we get on to some, looking at some gnarly reflection code actually, and I was really, yeah, it's really comprehensible. And Guido immediately didn't know the .NET libraries for that particularly, didn't know the F# libraries, but he immediately kind of saw what's going on between the different, I'm kind of happy with where things are at. Yeah.
And there was a point there where you said, oh, I don't like that error message. And that's
well,
something we can do a little bit more
with.
with.
Something, exactly. I'm sure a lot of the people noticed that the error message wasn't particularly good in that case, where you mixed up a yield and yield bang. And there's no particular reason why we can't improve it, and we will probably as a community then go back and look at that again and say, well, why do we highlight such a large region? How can we give a better experience in that?
Speaking of better experience, and check out chat room, check out this segue, watch this. Our next speaker, Gina, highlights, really fun to see how Guido uses the types in his tooltips like flashlights in the dark. I don't know HTML, but able to quickly create semantically correct React HTML components. That's pretty cool.
Yeah,
that is.
That is. I love programming in those HTML DSLs in F#. I'm not, to be clear, we're not saying don't use HTML, but what we're saying, if you're programmatically generating HTML and if you have dynamic HTML, then it starts to be pretty compelling, because you can see that the control logic kind of with those match statements and things just drops out so nicely, all this lovely data flow all the way through. And that's when it starts to be really nice. And there are other options in F#. You can But and you can also do HTML design with templating engines. But you can actually see that F# doesn't need the templating thing anywhere near as much as other languages need that, especially if the design element, because HTML has changed. It used to be a design language. Now it's a logic language of content. And then all the design is done in CSS. And that's still the split we have. So although you saw a few is danger colors, the actual color chosen for is danger is in CSS, or default CSS or custom
But we're
CSS.
just expressing our intent.
Exactly. You express the content and let the CSS designers go away and just map that to how that actually looks and feels. And that's exactly the handover point that you want between designer and programmer these days. So I think it's becoming very realistic to do. And we've actually seen enterprises. In my keynote, we saw Marktmit using SafeStack. We've seen compositional IT using SafeStack. We've used other people, Imperfect Foods and others. So lots of great work. That's actually Imperfect is mainly on the server side of it.
Very cool stuff. Well, thank you so much, Don. We appreciate you taking some more time here for us. I'm going to let you go so we can bring in Myra and introduce Gina to give our next talk.
That's great. I know there are more questions on Twitter. I'll go answer them there. And remember, look out for the second video of that and the second session, which will be coming out as soon as we get it out.
Yeah, probably in the next few days.
Great.
So,
Thank you, Jeff.
take care, Don.
Bye.
All righty. And thank you so much to Don for joining us again. I'm going to bring on Myra to join us. Hey there, Myra. Good to see you.
Hello. Nice to see you.
My goodness, this is a full day of .NET Conf. I've Guido and Don talking to each other, teaching about F#. What I feel just thrilled to see that, and I can't wait to see the rest of it.
That was so fun to watch. But we have to continue the show, right?
We do. So I will hand it off to you, and so you can bring on Gina, and I'll catch you later. Thanks so much.
All right. All right, so let's bring our next guest, Gina Marie Maney, and I hope I'm saying her last name correctly. And she's gonna talk to us about how to stop FUD and stay safe. And so it's a cool play on words and acronyms there. So welcome, Gina.
Hi, thank you for having me. Can you hear me okay?
Yes.
Great.
Did I say your last name correctly?
Very close. It's like Maini rhymes with linguini. Yep.
Yeah, okay. Yeah, it's like my first name is Maida, so Maini. So like
there you
go.
Latin.
Yeah. All right. So I hear you're gonna be talking about web development with F# for us?
Yes, I will be. And I'm gonna share my screen, I guess, and get my PowerPoint up. Okay. All right. Awesome. Thank you so much for introducing me and having me today.
Yeah. So take it away.
Okay. Thank you. Hi, everybody. I'm so happy to be talking to you today. Very excited. I'm so sorry I had to take over from Don and Guido. Very tough act to follow. Really enjoyed watching that presentation. And like I said on Twitter, it was really, really incredible to see someone so fundamental to Python using the type system in his tooltips to be a flashlight in the dark. I found that really personally very reaffirming as an F# programmer that what we're doing here is really special. So yeah, thank you also to Philip Carter for inviting me to speak to this and telling me about this great event. So excited to be here. So the title of my talk is How I Learned to Stop FUD and Stay Safe. Little play on acronyms, but I'm coming from the government, so of course I'm going to hit you with some acronyms. But I know as anyone who's done web development, fear, uncertainty, and doubt probably plague you quite a bit when it comes to which stack do you choose. Do you stay up to date with front-end technology, which moves very quickly? You want to, right? You want to use the latest and greatest, but also it's really hard to manage this tool ecosystem. It's very complicated. Like I said, a lot of fear, uncertainty, and doubt. So today it's just going to be a talk briefly from developer to developer about some technologies that I'm really excited about and really why I like to use them for prototypes in basically any circumstance. So a little bit about me. I I'm self-taught. I really think of myself as a site reliability engineer and functional programmer second, I would say. And, you know, showing my cards on the table, I did have a short stint on the F# Software Foundation board, really, really amazing community. And that was a really fun thing to be a part of. But basically, I've used F# in production to build real world scenarios, both for backend data pipelining and also, you know, bread and butter web development. And I've been in NYC startups for years, doing node stacks and all different types of stacks. And in my free time, I hack on a project called Open Transplant, which I'm really passionate about, which is doing organ transplantation and doing matching algorithms for that. My day job, I work at United States Digital Service, which is an amazing agency inside of the Office of Management and Budget. So really happy to be here with you and talk about something I'm so passionate about, which is F#.
Gina, before you continue, can you just go full screen with your slides?
Yeah. Okay, let me try to share again.
Okay, thank you.
Yep, no problem. It's live. It's live. Let me just do entire screen. We're gonna go big here. Now, does this work okay? You can see fine? Assuming silence is good. All right, so going back a little bit, stuff about me, already covered it. And now let's talk about the cool stuff, like what's my experience and what stacks have I worked in? I've done everything from making a component library in Java servlet pages. I know some of you are probably laughing at that one. To jQuery UI. I remember using CoffeeScript when that was really big. I don't know if anyone remembers CoffeeScript. I've done Angular and Node stacks. I've used Ruby on Rails. Some of my favorite ones were using an OCaml functional reactive programming library with XML. That was really interesting way to do web development. But my favorite has to be using something called Giraffe, which I'll show you some code later, some web code for Giraffe, and ASP.NET Core. I found that stack really, really fun. And it was a really great springboard for me to get into using Safe and SafeStack. So some common issues I found doing web development have to be, you know, any tool you pick, there's trade-offs. If you go with something that is server-side rendering and it's completely outside of the JavaScript ecosystem, you're really missing out on the JavaScript ecosystem. If you go with something like TypeScript, where you have gradual typing, you sort of have to maintain that map or the annotation files, which, you know, if the annotation files are well supported, pretty straightforward and easy. But if they're not, then, you know, it's kind of hard and difficult to manage that. Some of the other problems I had would be that, you know, the developer experience was a little tricky. So you might be working with like 3 or 4 different pieces of technology that all kind of have to go together with the build system. And so your build system ends up being kind of a Frankenstein. And it's unclear, you know, kind of reflecting on web development for a moment, a lot of times the developer is not really thought of very clearly. And I would say that, you know, the web stacks that we use today largely reflect roles and not domains. You know, we think about domain-driven design and how we like to build and craft web experiences. They don't really consider a full stack developer, which is becoming probably the most common web role out there. It's interesting how we just expect that these roles like front-end developer, even UX might be coding and shipping code, is so dissimilar from the back end. But in reality, those roles are starting to merge. I mean, you see that with the popularity of Node.js. And so I think there needs to be another thought to developer experience in web, and also why I'm so excited to talk to you about Safe. So let's do a quick aside on F#. So you've been hearing a lot about F# today. Maybe you've played around with F#, maybe you haven't. And I just want to say this is a great place to get to know about F#, ask questions on Twitter, and meet some of the great people in the community. One thing that I really love to think about with F# is the robust performance of F#. So F# was my first .NET language. I know that's like probably surprising to some people, but I found that actually the functional paradigm of immutable data was actually really performant. And another thing that, you know, I think has a lot of real benefits in terms of performance is the fact that generational garbage collections in .NET, right? When we think about how F# code is generally structured, the immutable data in let bindings that can be easily collected in Gen 0, Gen 1 cycles, that's going to give you great performance. But these long object hierarchies with a lot of references in between them, that is actually going to slow the GC down significantly. And I found that F# was a great paradigm for really performant code. The other thing that I really liked about working in .NET and F# was the amazing decompilers and performance profilers. So, you know, the great thing about F# if you're coming from another .NET language is all of those great tools come right along for the ride. So I used them with F# first and had really good experiences optimizing my code. The other thing I really love about F# is how high level it is and how concise it is. I think, you know, as you become more and more senior in your career, you'll start to realize that every line of code is basically a liability. It has to be maintained. It has to be well documented. I think what's great about F# is it's expressive, but it's also, I write less code. It's very readable. You know, we had Guido talking about Python with Don today. You know, it's also white space sensitive. You know, so when you're reading that code, you're really seeing just the bare minimum of what you need to see. I also think what's worth mentioning is this thing called builders in F# or computation expressions. I'm just going to call them builders for right now because I think that's an easier way to talk about them. But basically, it's a way that you can define a real quick class with a couple select methods, and you can create these wonderful syntax that I'm going to show you in a bit, where you've seen this curly bracket syntax. And it's basically like a workload, a generic way to define certain types of workloads. Some standard workloads that are going to come with F# are async, task, and sec. So it's really great. And I'll show you in a bit some Saturn builders that are really cool. And yeah, just fundamentally, you know, make your compiler work for you. You know, it was really great to see in the earlier talk, really seeing Guido use the type system like a flashlight in the dark. You know, if you remove, let's say I've got a type here, this is a very silly type, but type presentation, it could be engaging or it could be trash, right? Well, if I wrote a function that would, you know, match on that type, and I only considered that my presentation could be engaging, the compiler would warn me and say, hey, Gina, you need to remember that your presentation could be trash. That just makes refactoring code so much simpler. I don't have to worry about if I didn't consider a case in my code. I'm getting that for free. And lastly, I just want to say, you know, maybe a benefit we don't often think about is the really nice people in this ecosystem. F# has a much smaller community than a lot of other languages. And what I love about this community is how laser focused they are on developer experience. We heard from Isaac earlier today about SafeStack, and he showed the safe template, which I'm going to show later. And I just loved how focused everyone from compositional IT was and is focused on really making the full stack developer experience great. And I think that's what's so wonderful is how willing everyone is to help you on the F# Foundation Slack, you know, how willing your friends are on Twitter to respond, hey, I've got this weird bug, I don't understand this error message. And they're so willing to jump in and help. So it's a smaller community, but much focused on high quality. So here's a great example of a continuation pattern in F#, something that I might have written in my giraffe F# web code back in the day. An HTTP handler. Now, if you're coming from like Node.js, or maybe you've worked in like XHR objects, or any kind of continuation. This should look kind of familiar to you, or at least parsable. We've got a function that takes two things. It takes a context, HTTP context, that your function's running in, and it takes the next function that you're going to transition to. And here we can see a task builder where I define everything, including all the work that this function is going to do inside of that task. So really simple syntax here. Just a function, just taking two arguments, returning an HTTP handler. Pretty simple stuff. So now let's segue into SafeStack, what we're all here to talk about. So SafeStack is Saturn, Azure, Fable, and Elmish. Now, that being said, there's some different variations of how much of that stack you want to use. And I would encourage you to check out their documentation, which is amazing and very extensive. And, if you don't read documentation, because let's be honest, we're all developers here. We just like to code quickly and figure it out later. There's so much example code. And what's great is you still have the type system and the great editor tooling, right? So you can tooltip and figure out, like maybe I don't remember all of the things that React does, but okay, I've got FOMA, so I can figure out, what stuff is available to me. So here's some great code from the Saturn docs that I really liked. And Saturn is a MVC, server-side design pattern. So if you've used like Ruby on Rails or Django in Python, this should be pretty familiar, model view controller. And it's heavily inspired by Elixir's Phoenix, which is pretty cool. Another really cool project. And here I've got some sample code from the docs where I'm using two different builders. We've got a pipeline, which is for combining and working with HTTP handlers, just like the functions I showed you earlier. And we've also got a router builder as well, which is going to create our router for our API. So here we're creating our API pipeline. Okay, it takes JSON and we're setting a header. So a really great question that came up earlier when Isaac was talking, at least on Twitter, was how do I do authentication or an OAuth workflow? A great way to do that would be doing a pipeline would be a great way to do that, where you're decorating your header with cookies, maybe you're signing cookies at an HTTP handler, and easily reincorporating that and making that composable. You could even incorporate that and open it up into your shared code in your organization. That might be a great way to handle standardization around, authentication. And here we set up our API router where we pipe it through our pipeline. We add a not found handler, which I love the way it almost looks like a little DSL. You've got this little arrow combination. And remember, don't get too afraid by these little combinators or these little functions. Because remember, in your editor, you can always hover over this stuff and see exactly what its input is and exactly what its output is. So here I'm setting a status code, 404. And what are we going to do? We're going to return some text, API 404. Pretty simple. And eventually we forward it to /some API and we pass in a controller or a scope. Really simple code. What I love about this is how much we do in just a few lines. So Azure, I'm not going to talk a lot about this. You're at a .NET conference. You know what Azure is. But yeah, you can use Azure and Safe very easily. And this is pulled straight from the Safe documentation, but here's kind of a high level, how the app would look. And we'll get into the front end in a moment, but just to show you, this is what it would look like with your Azure backend. So you could integrate perfectly well with the rest of the Azure databases or service buses. Very simple stuff to do there. But also it's worth pointing out, this works everywhere because anywhere with Docker technology, there's tons of really good examples on the compositional IT repository and organization for you to look through. We saw the Safe Search app from Isaac earlier this morning. And, there's tons of different little applications and deployment configurations that they have on there. So let's talk about Fable. Really, really cool project. So Fable is how you take your F# code and turn it into JavaScript. So, you know, working with a large JavaScript code base is a nightmare. I don't think that's a controversial statement, but, you know, it really is very difficult. And in 2021, I'm here to tell you, you can stop writing your code base in JavaScript. It's okay. It's really hard to do this context switching from JavaScript to your backend code. You know, I don't care who you are, it's mental overload. And especially, like I said, for a full stack development experience, I'm not sure why you need to write your code base in JavaScript. Actually, I find a lot of benefit in a strongly typed workspace because I can figure out and wrap the JavaScript code base in a way that's meaningful to me. But at the same time, I'm avoiding the issues that I had in other frameworks. You know, there's a lot of them that come to mind. JS of OCaml, I have this issue in. You know, BuckleScript is a project worth mentioning where you transpile to, you know, OCaml modules to JavaScript modules, but it kind of bears the question, like, who even needs that? Which part of, do you modify the JavaScript modules? Who on the dev team does that benefit? You know, it doesn't seem to be that coherent. But what I like about Fable is you're still producing NPM. It's still like calling Node. So you're still benefiting from, I'll show you in a bit, but the front end debugging tooling, which for me is the real make or break why I'm going to use something. Is it's generating and well thought out and mapped really thoughtfully. So you get date time and math and all the important JavaScript utilities and mappings that you need. And most of F# core is mapped. The stuff that isn't mapped is thoughtfully done. So I think that's a real importance that they consider the differentiation in runtime. So there's less shooting yourself in the foot than if you just kind of use something else. So Elmish, really cool project. It's Elm-like, and we'll get into that in a bit. But the idea of sending commands is basically the major paradigm. And you also build kind of a little state machine. There's really no other way to put it. And it's outputting as a Vue, React, or React Native. You know, I don't have to sell you that React.js is one of the most important front-end libraries in JavaScript web development today. It just is. The ecosystem is massive, and it's really not going anywhere. So I think, you know, the fact that Elmish is right there for you, and it's all F# is huge. I also want to call out the Thoth project. So as, you know, I work in government. So when I go to make prototypes, a lot of times it's just forms. You know, the government basically runs on forms and paper forms. So when you're digitizing forms, you know, your Elmish code might start to be kind of big. And I noticed that this Elmish project, Thoth, had some really cool stuff in there. And I just wanted to give them a shout out because, again, it comes back to the amazing F# community providing really great tools. Okay, so now I'm going to run a demo of basically installing everything for you. So here we go. We're going to pull open my terminal. All right, so we're just going to start from the beginning, right? There's no magic here. There's no, no like hidden stuff. I'm going to show you exactly how it works start to finish. So when you're installing templates, right, there's a couple different things you can do. First, you should see what templates you have on your system. And if you're new to the .NET CLI for whatever reason, they've done a lot of really great work in here, and I love using this. I'm also using my Windows subsystem for Linux, which I love working in. And I love we were talking earlier on Twitter about our favorite VS Code extensions. I should probably throw in WSL as a favorite. But here I see I already have Safe installed on my system. Now, if I didn't have that installed, all I would have to do is, do this and put the -i flag to install it for the first time. But since it's already there, we'll just run it. And if I didn't know, like let's say I didn't know if it was safe or if the language was like somehow different in the keyword, I would just put a flag in for searching, and then it would show me, it found it, .NET Safe. But since I've already got it installed, let's go ahead and just make a new, wow, that was fast. Okay, so let's kind of like move up a little bit here. So we've got all of this stuff in here. You know, I'm coming to this, maybe I don't know anything about SafeStack, so I'm looking around, okay, I don't really know what to do, so let's just go ahead and open it in code. Okay, pulling it open here. Oh, and I guess I've got my README open. Okay, that looks pretty good. Let's see, what do I need to get going here? Well, I need, let's see, I need Node, okay. Okay, I've got Node. Let me check. Do I have NPM? I've got NPM. Okay, it sounds like I might be ready. Okay, let's try to do this. Now, what's next? I do .NET tool restore. Okay. Let me just run it. Oh, what did it do? Okay, so it restored something called packet. Okay, glad I don't have to work with packet directly, maybe, or maybe I don't know what these tools are, but okay, I did something that looked important. Okay, cool. So let me just try running .NET Run. Huh, okay, so it's doing something with NPM. Okay, so it looks like it's running NPM, and it's generating my, my NPM dependencies here. Okay, pretty exciting. I don't really like working with NPM, so I'm glad I don't have to do anything with NPM. I'm glad that's programmatic. Oh, look, and I've got tests here. We'll look at those in a moment. Okay, wait, it's parsing an FS proj. Okay, interesting. So just like I would expect in my, C# solutions, or I'm still using an example solution. So it's still using solution files. It's still basically doing all of the same .NET stuff I would expect. And let's see, we've got a couple different projects here. We've got client, server, and shared. Okay, interesting. Okay, it's calling Webpack. Oh man, I don't know if anybody's worked with JavaScript web tooling, but my goodness, I'm glad I don't have to call Webpack or handle Webpack. Well, it says it compiled successfully. I don't know. Let's try to see. Okay, control click. Huh, wow. Okay, so I've got my save template. Goodness, that was 2 minutes, 3 minutes. And we've got a website. I mean, this is sort of what you saw this morning, but what I want to show you as well is, oh my goodness, we've got our JavaScript debugging tooling. So let me go ahead and push that to the side of the page here. And I've got 2 events here in my inspector, init and got to dos. Huh, okay, let me look at the raw events here. Interesting, let's play around a little bit. Test. Oh, wait, a bunch of stuff happened. Let's see if I can't make this a little bigger. Ooh, look at that. That's a little bit better. That looks good. I bet that's a lot easier to see. So here we've got a couple different events, set input. Huh, and that's happening. Look at this. I can use my JavaScript tooling to actually roll back and see, oh, look at that. I even have my charts here to tell me the state. Right, so this is when I say, when you want to use the JavaScript ecosystem, but you don't want to directly interact with it, this is the benefit. I'm still doing my debugging in React extension, right? It's still React at the end of the day. So I can still use these great tools, but I don't really have to interact with them. Okay, added to do. Wow, really easy stuff. So what I like about this is immediately out of the box, I get a workflow that basically I can tweak to do anything I want. I mean, it's an MVC app. And here it's just F# project files. So if I look in shared, I2Dos API. This looks like an interface. Easy, really, really nice. And of course here, this is actually just, font ligatures, which I shared on Twitter, are these great Fira code extensions for Visual Studio, where you just change the text editor language. But, really cool stuff. I think makes it look really pretty. Let me check out the only important files it seems like I might need. So let's go to the files on disk. We'll jump over to client, head to index.fs. Okay, this sounds like the index page I'm on, maybe. Okay, cool. We've got an init function. Okay, well, let me see, like, let me try to change something really quick. So if I change this and I say, I don't know, maybe let's start with like hello from init. Oh, wow. So it recomputes. Huh. Wow, that was simple. So my F# code immediately hot reloaded. That's great. And now I can see all of this really cool, easy content. Like I've got all of this really cool React stuff in here. I've got a little state machine here where I've got my entire state represented. And I don't need to know anything other than what the state machine will tell me in here. So this state machine here is immediately shown in my React tooling. So I'm really, again, getting the best of both worlds. And I'm basically at time for this presentation, so I'm going to stop now. But
I was about to come. I was waiting, didn't want to interrupt. But we are at time. Thank you so much. So much information to unpack on this session. And we are gonna have to move on. So we have one question on Twitter that you can go and answer offline. But thank you so much. And with that, we're gonna bring our next guest, Matthew Cruz. He's gonna give us an intro planning with F#. So I wanna learn more about that and what that means. And you're muted, so.
Thank you so much for letting me know.
Awesome. We can hear you well now.
Excellent. Thank you so much.
All right. So what are you going to cover for us today?
Well, are you ready for me to go ahead and jump in?
Yeah. Share your slides. Let's see. You can give an intro to your talk.
I should be sharing my screen right now. Can you see it?
Yeah, it looks great. So take it away.
Excellent. Thank you so much. As you know, my name is Matthew Cruz, and I am incredibly excited to talk to you today about mathematical planning and F#. Now, as I've worked with different companies and in different industries, I have found that there are 3 questions that really drive organizations and businesses. The first question is, what happened? We look to the past to try to understand how did we get to where we are. The tools for this are things like, dashboards, pivot tables, statistics, all these different means of analyzing our data to understand what happened in the past. The next question is, what will happen? We need to make a prediction about what we think is going to occur in the future. And one of the fantastic things that you've been seeing today is that F# is an amazing language for machine learning, which is a powerful set of tools for being able to take data and create predictive models which help us make inference about what is going to happen in the future. But there's a third question. And that third question is, what should we do? And it's this question that I really want to focus on today. Now, as I've worked with different people and worked on answering this question, what should we do? There's always 3 key ingredients. The first is there's a quantifiable objective. There's something we're trying to achieve, and we have a way of measuring it. It could be maximizing profit, minimizing cost, maximizing efficiency, or minimizing waste. Whatever it may be, there is a way that we quantify success. The second is constraints. These are the limitations on what is possible. They could be financial. We only have so much money to invest. It could be people. We only have so many developers to assign to projects. It could be legal. There's only certain things we're allowed to do. But there's always some type of limit on what is possible. Lastly, there are decisions. These are the choices that we need to make within this framework. It's what we need to decide in order to create a plan going forward. Now, wouldn't it be fantastic if there was a set of tools for answering the question, what should we do? We have tools for inspecting the past. We have tools for predicting the future. But wouldn't it be amazing if there was a tool for answering what should we do? Well, fortunately, we do. It's called mathematical planning, and it's actually been around for decades. Now, this begs the natural question, okay, Matthew, what is mathematical planning? I don't know what it is. Well, I could give you a very clinical response. It's a discipline of finding values for a set of decisions that achieve the best possible outcome, given some quantifiable objective and constraints to be adhered to. Clinical, true, or the definition I prefer is, it's the mathematics of caring for people. When I was teaching this at university, students would come in, and on the first day I would say, all growing up, we always ask, like, why do we have to do this math? Why do we have to do this math? And when it came to this class, I said, this is why. Mathematical planning, I think, is one of the crown jewels of mathematics. And it allows us to do the most possible good with what we have available. Now, a new question may arise. Okay, Matthew, you've piqued my interest, but how do we actually do mathematical planning? Great question. Well, the workflow is, first we build a model. A model is a kind of mathematical representation of our problem. It includes that objective and the constraints and the decisions that we need to make. We then send that model to a solver. And a solver is a piece of code that knows how to understand that model and search for the possible solutions. And because of the way we structure the problem, it's guaranteed to find the best possible answer. And finally, we get the result back, and it tells us what values we should use for the decisions. This is how much money you should invest. This is how many people you should put on the project. Now, what are the ingredients that make up a model? Well, first of all, there are the sets. Sets are the dimensions of your data, how it's organized. It could be the cities you're planning on sending material to. It could be the products that you're planning on manufacturing or selling, or the time periods that you need to plan over. There are parameters, which is the data that goes into the model. And these are things like, what are the capacities of my different facilities, or what are the demands I'm seeing in the market, or what are the production rates of the different facilities. Then there are decisions. Again, these are the choices that we need to make. And we can think of this as like a knob or a dial that the solver can adjust to try to find the best possible plan. Next, there are constraints, the limits. And these are mathematical representations on the limits of what are possible. So it could be like, we only have so much money, we only have so many people, so you have to stay within those bounds. Lastly, there's the objective. It's how we measure success. And so we give it the expression that we want the solver to use to measure how well is it doing. Let's talk about some examples. The first one comes from the power industry, where we need to make a plan for producing and distributing power. The sets in this case would be power plants, where we can produce power, and cities, where we're sending power to. The parameters would be the cost of generating power, the cost of transmission, what the city's demand for power is, and what the capacity is of the power plants. Decisions would be, how much do we produce at a power plant, and how much do we send along the different transmission lines? Constraints are, you can only produce so much power, and we do need to actually power the cities. And our objective in this case is to minimize the overall cost. We could also look at the logistics industry, where we're shipping packages. In this case, our sets are the packages we need to deliver and the means we have for delivering them. The parameters would be the dimensions of the package. How big is it? How heavy is it? And the capacity of our shipping methods. The decisions would be, okay, I'm going to put this package on this shipping method. Constraints in this case would be, we can't overload any of our shipping methods, and we have a budget. And so we can't exceed that when it comes to choosing methods for shipping packages. And our objective would be to maximize our on-time delivery to create a great customer experience. Some other examples real quickly is the sports industry. Scheduling seasons. I actually know that the National Football League, so American football, schedules its season using mathematical planning. There's also the finance industry, where I've actually worked some. At the beginning of this conference, Don Syme showed a slide and on there was Rocket Mortgage, and I actually worked there for a while. And we had a really interesting problem, and I apologize for having to be a little coy and a little vague, but we had some financial decisions that were being made by people using some manual methods. And it took 4 hours for them to do it. So we were able to come in and we developed a model. And what that model did is it took that 4-hour process and turned it into 10 minutes. And not only was it faster, it was much more profitable. So that's part of the power of mathematical planning. And these types of problems are all over the place in finance. There's also a unique application. This is one of my favorites. I was talking with a company and they actually would use mathematical planning to create meal plans for families. A family was able to put in, these are my allergies and this is what I have for cooking and this is what my budget is. And then the model would decide, hey, this is what I think you should buy and this is what I think you should make in order to maximize the nutrition and the well-being of that family. So again, mathematical planning isn't just about making money, it's about caring for people. Now, what I've been trying to get across to you is that anytime you have a quantifiable objective, constraints to be obeyed, and decisions to be made, you may very well have a mathematical planning problem. Now, let's actually work a problem and let's see some code. This has all been very nice, Matthew, but show me the code. Well, let's do it. And we're going to work a problem that's very pertinent these days, and it's vaccine distribution. We have a set of trucks that are able to distribute the vaccine, and we have a set of cities that need the vaccine. Each city has a different amount of vaccine demand. Each truck has a different capacity, and the cost for sending a particular truck to a given city is variable. So that cost is going to change depending on which way you're having it go. And we want a plan that's going to minimize the cost so that as time goes by and we have to continue to do this distribution, we're saving money. Now let's look at our data. First of all, we have trucks. And right now I'm just modeling this as a list of strings. We have our cities, again, a list of string, and this is where we need to send the vaccine to, and we have demand. And right now I'm putting this in a dictionary where the key is the city, and then the value is the float. The value is the demand for the vaccine. We also have capacity. So for each truck, there's how much of the vaccine it can carry, and the cost. And again, the cost is keyed by a tuple of city and truck, and the cost associated with using that method. Now, let's start building our model. We have to make assignments. So what we're going to do is we're going to assign trucks to cities. So for each truck and for each city, we are going to create a Boolean decision. So a 1 would indicate, I am not sending this truck to that city. And a 1 would indicate, yes, I am sending this truck to that city. Now I need to create some constraints. So each truck can only be used once. It's not possible for a truck to physically go to multiple cities simultaneously. So these are my single assignment constraints. For each truck, I want to sum the total number of times that truck has been assigned, and I'm going to use a list comprehension, and I'm going to sum it. So for each city, I am going to take whether I was assigning the truck to that city, and I'm summing those all up. That sum, the total number of times it's assigned, has to be less than or equal to 1. So this will tell the solver, you can assign a truck once or not at all, but that's it. Now we need to make sure that our cities are actually getting their demands met. So I'm going to create some city demand constraints. For each city, I'm going to sum the supply that is being given to that city. And to do that, I'm going to sum a list comprehension. So for each truck, I'm going to multiply the capacity of that truck by whether I actually assign the truck to that city or not. That sum has to be greater than or equal to the demand of that city. Now, we create our objective function. So this is the expression that tells the solver, this is how I measure success. In this case, I'm going to, again, sum a list comprehension for each city, and for each truck, I'm going to multiply the cost of using that connection by whether I actually am using it or not. The objective then takes that expression and says, hey, I want to minimize this function. Now we can build up our model. Our model is simply create the model, given that initial objective, add the trucks assigned once constraint, add the city's demand met constraints, and then we're going to call solve. And so this would send the model to the solver, and the solver would search through that and find the best possible plan, which minimizes the cost, only assigns the trucks once, but still meets the demands for the city. Yay, that's fantastic. What's powerful is as our data changes, we can rerun this and reuse this model. Now, you might be asking a different question. Okay, Matthew, mathematical planning sounds cool, but this is an F# conference, but why F#? What about F# makes it, cool for this type of thing? Well, to answer that question, I need to point out there's actually 2 bugs in that code, 2 visible bugs. Now, there's always someone who's very astute and may have noticed them, which is great. But what's really important to know is that the compiler can't see them. It cannot help you. Now, what I'm going to do, though, is I'm going to add a couple more features to this model. And these are things that are very idiomatic for F#. So normally I would have done them right off the bat, but I wanted to show a compare and contrast. So now let's do this, but in a more F# way. The first thing I'm going to do is I'm going to add some domain modeling. F# has a very clean, concise syntax for defining types, and we're going to use that to accurately model our domain. And we're going to use units of measure. Units of measure allow us to annotate our numbers with the units they're meant to represent so that the compiler can check our algebra to make sure it's correct. So I'm going to define 2 new types, truck and city, and they are simply just wrapping strings. And so now we don't have just a string hanging out there. We could tell we've given additional context to what this string is meant to represent. I'm also defining some units of measure that I'm going to use to annotate my numbers to make sure that the algebra is actually correct. So now trucks, instead of being a list of string, is a list of truck. And cities is now a list of city. My demand is now a dictionary where the key is the city and the value is a float, but that float is in units of dose. Capacity is, again, a dictionary keyed by truck, but now the value is a float in units of crate per load. Costs, where I have for a given city, for a given truck, here's the cost, but now it's in terms of US dollars per load. And I'm going to annotate my decisions. My decisions are now in units of load. When I do this, I'm going to see some errors appear because I've told the compiler so much more about what this code is meant to represent. So now F# is working for me and helping me to figure out, hey, Matthew, what you're doing doesn't make sense. The first problem is going to be as I index into assignment. If I hover over the C, it's going to say, hey, Matthew, I was expecting truck here, but you gave me a city. Before, assignment was a dictionary keyed by a string tuple. So there was no context for the compiler to say, I don't know, it seems to work, they're all strings. But now that I've embraced F#'s concise syntax for defining types and then accurately modeled the domain using those types, the compiler is now helping me ensure that my model makes sense and how I'm indexing data makes sense. So what I'm going to do now is I'm going to switch the order of those arguments, and now the compiler is going to be happy. This may not seem like a big deal, but when you're doing mathematical planning and you're building models, you're often indexing into multidimensional data. So 2, 3, 4, maybe even 5 dimensions to your data. And keeping track of that in your head is difficult. And then finding the bugs that are caused by indexing by the wrong thing can be very time consuming. So F# is helping me write correct code faster. Now the next bug is actually even scarier. And it's here. Now the compiler is saying, no, Matthew, this comparison, it doesn't make sense. And I'm like, what do you mean it doesn't make sense? And I hover over it. It says, I don't have an overload for this operator. And what's really important to note is on the left side, it's in units of crate. And on the right side, it's in units of dose. It's saying your units don't make sense, Matthew. Now, if NASA can crash a rover into Mars because of errors with units of measure, we could certainly do it. F# allows me to annotate my numbers to make sure the algebra is correct. And what's even better, there's no performance penalty for this. It's only a compile time check. By the time it gets compiled and goes down to IL, it's disappeared. So I know there's other languages where you can do this type of thing, but it's typically you're adding new types. In F Sharp, you don't need to. It's just as fast. So now I'm going to add a conversion, which is my dose per crate. I'm going to add that multiplication to the constraint, and now the compiler is happy, saying, yep, your comparisons make sense, your algebra makes sense. So why F Sharp? F Sharp allows us to write clear, clean, concise code. It allows us to write that code quickly because it's so succinct in order to define new types in F Sharp. Not only that, it's fast code because it's all running on top of .NET, which is an incredibly fast runtime. And that code is correct because we've accurately modeled our domain, we've used units of measure, and so that code is going to be robust going forward because it's going to be checking, are you using the correct conversions between your units? Are you actually indexing correctly? So that code is going to be more resilient over time. So we spend more time delivering value to people and less time hunting down really painful bugs. Now, to convince you this isn't all smoke and mirrors, I actually have this example fully worked out, and I'm going to send a tweet out here as soon as I'm done with links to both the code of this example and to the presentation I just gave. If you'd like to learn more about F Sharp and mathematical planning, please check out the Flips library. It has many more examples across different industries, and it has more details. I can just go in more depth than I can here. Thank you so much for having me. Please feel free to reach out to me anytime. I have a blog, matthewcruz.com, where I'm able to go into more deep detail and work more examples, but I love answering people's questions. Thank you to the organizers for inviting me. It was a real pleasure to come and speak to you today. Thank you very much.
Hi, thank you, Matthew. It was such a great presentation. And we're getting tons of comments from the community on how great your presentation was and your style of presentation and your voice. You're getting like best prize for voice at .NET Conf so far.
Thank you. That's very kind. Thank you.
So let me share my screen and show some of the comments we're getting.
Okay.
So from Kurt, Matthew's talks on mathematical planning with F Sharp and the Flips library is truly mind-blowing. You should look up his talks on YouTube. So I guess you have more talks that people can find on YouTube?
Yeah, I actually have a 3-hour workshop that I gave where I'm able to kind of go from the very beginning and just slowly build up concepts. So yeah, I do have several talks out there and have been planning to do more. I just got back from a month of vacation. My first time I took more than a week off in a few years. And so I just really checked out and just spent time with my family. But you're going to be seeing a lot more coming from me now that I'm back.
Awesome. Yeah, awesome to hear. But we all need a break from time to time
Yes.
as well. So
Yes.
very well deserved. And here's one of the comments about your voice. A bit envious of the tutorial voice and people saying you should do like professional voiceover.
Oh my goodness. Oh my goodness.
Yeah, and then Revan also talking about F Sharp and what a nice topic you just covered. So are there any other resources or things that you think like the community would be interested in learning more about?
So I actually put together a blog post to answer this question. So if you just go to matthewcruz.com, that first post that's there right now is actually just additional resources for learning this, because there's a lot of different places you can go. The Flips library has a lot of just worked out examples showing you how to do different things. And again, it kind of slowly builds concepts. So between the combination of those things, that's probably the best intro I could give people. Also, please reach out to me with questions. What I'd really love doing is getting a question from somebody. And then with their permission, of course, I like to turn those into blog posts so that I make sure I'm answering questions that people really care about. I'm a deep nerd in this subject. And so I recognize I no longer have beginner eyes, so I don't know what's hard anymore. So that's why I love questions from people so that I can answer your questions and your problems.
Yeah, and Jeremy also saying that he just hopped back into the conference. And the more I see, the more F Sharp is really making sense. And I'm learning tons as well. I'm more of a C# developer myself, but it's been really nice to hear all these presentations today and how you can use F# in such meaningful ways and create really like robust and succinct code that runs really fast and performant. So really, really great stuff happening today. And I don't know if we have our next talk, like next presenters ready. So let's see.
Was I too fast? I was trying to make up a little bit of time for us.
I think we can bring Houston on our next presenter. Yeah, but thank you so much, Matthew. Yeah, you were on time, but we had like a few minutes to kill. And let's see, we got a few new posts, so let's show them. So I'm back, baby.
Nice.
And thanks a ton to Matthew as well for his awesome talk. So yeah, we really appreciate having you here. And with that, we'll bring Houston to talk about some F# tapas.
Awesome. I'm excited. And like I said, I'm on Twitter. I'm on the F# Slack. Hit me with questions anytime. I will get back to you. So thank you so much.
Thank you.
Hi there.
Hi, Houston.
How are you doing? Matthew is great. It's a tough act to follow.
Indeed. And so, and I cannot do that tutorial voice in any shape or form. So, but F# tapas, I love some good tapas. So what are you going to be covering from the description? It seems like you're going to cover some really interesting IoT and F# and Spark. So what are you going to cover on the talk today?
So because Louis Quintanilla did such a great job with his Spark presentation, I'm kind of going to whistle past it a little bit, mainly in the interest of time, because the IoT example is a really rich example of really concise, what I would think of as elegant code. Even though it's a small proof of concept, it accomplishes a lot with just a few lines of code. And I'm going to show a little bit about how I got into the F# ecosystem and how a lot of folks that come to F# will come from C# because they're already in the .NET ecosystem. And I have lots of C# experience, but I really came more from the R world and that, the R and Python kind of ecosystems. And I want to show the direct line that kind of gave me my first real hook into F# that was like, aha, this really is something familiar, but really compelling and different.
Oh, nice. And I really like how Gina put it, that we have such a great community for F#. It's like a small community, but people are so invested in each other's success and making people successful. So it's really great to hear that as well.
Absolutely. I'm going to be spending some time talking about some bugs that I encountered and some, I would call it self-inflicted wounds while I was learning, and the help that I got from both the Meadow community and the Meadow developers that have their own Slack server, as well as the F# community, really helped me get past some of those roadblocks and got past that initial kind of point of friction that you have in the learning process and really open things up. And I literally couldn't have done it without them. So I'm definitely going to be showering them with some praise, because it's not just the platform that Microsoft has built. It's also the ecosystem and the community that really has brought a lot to the plate.
Awesome. So we are at time. So I think we can get started with your presentation about small bites from the cloud to the edge.
Outstanding. Thank you so much. So this is, as I was saying, a bit of a lead into my learning of how I got drawn into the F# world. I'd had a few blushes and brushes with it earlier in my career, but it didn't really connect until I saw the interop story. So I'm going to show two interop stories that really connected for me. One is out of the R ecosystem, and the other is with the IoT and working with the C# libraries that Wilderness Labs had built for their Meadow platform. So I'm going to go ahead and jump in and talk a little bit about kind of where I come from. the reason why I was asked to do this talk was because a blog post that I wrote called What the F# is Next. And of course, during COVID-19 downtime, and I was on the bench from consulting, I spent a lot of time researching and thinking through this disconnect between the analytic world and the operational world in terms of the code bases. And I really wanted to unify that in terms of the way that I was approaching things. So I went all the way back to looking at some of my early days and some of the IoT stuff that I had done. And my career started, and as you can see in this image here, working for Bob Moog, who's the inventor of the Moog synthesizer. And the big picture in the middle there is the memory Moog keyboard that I worked on that had a Zilog processor that was a microcontroller that was doing a lot of stuff under the hood. And we were doing a lot of modifications of that and also building, firmware and software and experiences for users that were in that realm. And I moved on to working in enterprise and larger scaled systems, but still had a foot in IoT and things like automotive telematics and occasionally healthcare and entertainment and the things that you do as you move through the consulting world. So that was essentially my background, and I talked about this in this blog post, and I'm going to give the 2-minute version here, which is I started in the Java ecosystem, and through that had exposure to Groovy and some Scala, and the Scala carried forward into my consulting when I was working as a Microsoft Gold Partner consultant. And that was the experience where I really started transmuting into using R as its own workload, as a user-defined function inside of Spark, where the Scala workloads were beginning to bog down over really long periods and becoming rather fragile, and breaking out the Spark workload into a user-defined function made it a day-long process into something that could run in just a few hours. And at that point, I was exposed to ML.NET and what was going on with the Spark interop that was being built by Microsoft, and it had those same characteristics that even though it had an API that was very idiomatic to Scala, it produced a workload that was actually a worker that was going off and working in the CLR directly within the worker nodes themselves. And that to me was very familiar to what I was doing in R. So that wasn't quite F# yet, but it was the beginning of me seeing kind of a different way of looking at how to build parallelism into doing these large data workloads. So as I went, made more forays into doing more things in the full stack realm and working with Android and with some IoT projects, there were some Arduino projects involved as well. It was that realization that I think a lot of us have, which is it's a polyglot world. We're dealing with a lot of technologies and a lot of ecosystems, and you have this kind of element of perishable skills that you have in your head of all these different languages that you have to know enough of to be able to accomplish a certain thing. And then once you step away from that domain, it feels like the perishable portion of that knowledge is lost, and you always have to go back and revisit. And so what I was looking for was a language and an ecosystem that really could carry the water in a lot of different domains. And the phrase that I was using was from the cloud to the edge and back. So that was really where I started with F#, and I started with learning going on to online courses and taking the kinesthetic approach of actually learning by doing. And as soon as I got through some of those online courses, I immediately started trying to solve my own problem because I figured that would be the way that it would make that it would stop folks that are conversant with the F# interactive. This is our studio. I'm kicking off a process, and you can see inside the console here that it's running the code and giving some error messages back, and then it's doing the render of the visual off to the side. And this is for really rapid prototyping and developing things, and eventually this gets converted into a web page. But what's happening is the HighCharter library, which is a JavaScript library, is actually being controlled by R. And you can actually see down lower here, there's actually some HTML that's being brought to bear, but it's actually informing how the tooltip is being built. So there's this interop that's already there in the R ecosystem where R is talking to HighCharter, and HighCharter is doing things with JavaScript and with HTML to actually render this. So I wanted to do the same thing within F# to kind of bring it home. So I have this exercise where I went through to try to find other places where HighCharts were being used, and HighCharts makes a .NET library. And HighCharts is like Plotly and other visualization libraries that it has a large user base, and it's used for a lot of different things. They use it for stock and analysis. I used it for medical analysis for a healthcare client. So it's one of those things that it's a kind of a chameleon and kind of runs anywhere. So I found that WebSharper had an implementation for it. And this is actually an experiment that someone had built in F# called Fizzplot that is designed specifically for working interactively. And so you can see here, and I'm going to go ahead and just run this in front of you. It's building this plot and rendering it right in front of you. So you exactly within the RStudio experience where the code was being run, and you could see it happen in the console, and you could see some feedback. If there were errors, you would actually see them in the console, so you can remediate and rerun. And this inner loop is very familiar to me, and this was the first real aha moment that I had with F#, that you have this very concise syntax. You have a very immediate and gratifying inner loop in the editing environment. And so you can do things here that's very familiar to what I was able to do within the R environment, and then I was off to the races. So the first thing I wanted to do is I was looking at the way that this was applying themes, and the way it was applying themes in the RStudio is exactly the same way that you can apply it here. The syntax is different, but it's the same thing where the code environment is basically projecting into the JavaScript runtime, and JavaScript is basically updating what's happening in the web page. So this was the beginning of, oh, I want to find this thing that's familiar to what I had used before and bring it over. So I'm going to go and find, this is the HighCharter library where it has all the different versions of different themes that can be applied. And this is JavaScript that's embedded inside of R. So what I did is I extracted that JavaScript out and brought it to, instead of just the 3 that it offered, which was listed here, gray, dark gray, and then default, which is what falls through, and it falls all the way through the logic. And I added the other JavaScript objects that came out of the HighCharter library so that I could take and apply them here. So all I had to do was add this to this JavaScript library, recompile my own version of the DLL, and I was off to the races. All I had to do is then use those name labels, and it could remap what was actually showing in the display, and then eventually, of course, you can work it out to put it in its own visualization. But this was that inner loop of being able to do some experiment and do discovery and do it in a way that's really concise and really friendly. And of course, I was looking at the F# code behind the scenes that was built for this particular library, and I couldn't believe that it was as small as it was. And that was that next step of drawing my eye forward in the F# ecosystem. So I'm going to switch back and talk a little bit about the second project. The second thing that I wanted to do was, where else can F# run? And of course, the ultimate to me is being able to move out into mobile and out to the edge in IoT. And at the time that I was asking myself that question, Wilderness Labs was actually doing some of their own work for supporting templating for F# and for VB on the Meadow IoT platform, which I'll talk about in just a minute. But at the same time, there were discussions going on about aerosol transmission of COVID. And so I had a friend that had a commercial CO2 sensor and had gone into a gym to see if he could go there. And the CO2 readings were like 1,500 parts per million. And you can see here that the research actually shows that 750 really is kind of the threshold at which they're recommending that you start bringing fresh air into a space. So we ended up having a conversation about somebody should be doing something about that. Someone should build something. So I decided to actually use the Wilderness Labs Meadow to do that. So I'm going to show the Wilderness Labs Meadow in a summary view, but you're also going to see it in a live demo here in just a minute. One of the really nice things about the Meadow is that it's not just one processor. It's actually a full solution board. So you have this, and I'm going to go and find this. You actually have this ARM processor. It's the STM32F7 that is a fully capable microprocessor. And there are other co-processors along with it on the board that allow it to do many other things. There's battery charging, there's Wi-Fi, there's Bluetooth support, and it has, as you can see, a high degree of I/O that allows you to connect a lot of different things and for it to do a lot of different functions. So it's a general project platform, but it's not just hanging out there. It has a lot of support for other peripherals and devices, and they basically are piggybacking on that ecosystem around the Raspberry Pi and the Arduino form factors. And so they support the SparkFun and the Adafruit peripherals and so forth. So they made it work well and play well with others, not just hooking it up in hardware, but they actually built drivers for them. So you can get these off-the-shelf components, do a NuGet pull for the C# library that supports that driver, and you can just go. And that to me is really this amazing kind of propelling kind of effort that comes, it's open source, but it's also a commercial effort. And so all these components that you can find anywhere online, you can take and add to this project board and write idiomatic .NET code. And I'm going to be showing the F# version of the CO2 sensor operating here in just a moment in my own test rig. So this is a CO2 sensor. You can see here in these two little slots here, there's a little tiny sensor on a board that's about the size of a quarter. I'm also running a relay that's relaying in a dual fan operation that actually is pulling in fresh air and sucking out air inside of a test enclosure, which I'll show in a moment. So this is an overhead view of the entire rig, and I put an enclosure over the top of the project board with a display that's going to show the parts per million that's being read in the CO2 sensor, and this relay that's off to the side that's turning on these two fans. So that's the high level, literally, of the rig, and whenever I switch to the next camera position, you'll be able to see a bit more. So if you look at the lower part of the screen here, you'll see that I've got some project views here, both of the side view and an overhead view. You can see how everything is wired in. I'm looking at the time, making sure that I don't run over, so I'm doing okay. But the enclosure actually sits over the top of it so that the air stays enclosed, and I have a little CO2 injector that's a bicycle tire inflator that actually allows me to put a controlled burst of CO2 into the space. You can watch it kind of level up and see the events trigger in the console, and then the fans will turn on with the relay and will eventually clear the air, as it were. So before that, I want to show a little bit about the actual boot up process here, because this is what's really interesting to me. Is this is very close to running like running a debug for an Android or iOS device, where you have a USB connection to the board itself so that you can actually get some debug information back into the editor. So you can see that this relies heavily on Mono, and they've done some amazing work. The folks at Wilderness Labs are the same folks that helped create Xamarin. So they definitely know how to make interop work with the outside world. And so this goes through a series of checks to see all these DLLs. It's actually putting DLLs directly on the microprocessor. So you're actually running .NET natively. This isn't something where I'm running, in an emulator on the machine and pushing to the display. It's actually pushing the code and running it on that STM32F7. So I'm going to switch back to this, and I'm going to lower the hood on, and there we go. So I'm going to plug this in, get the power to the board, close the lid. You're not going to see the fan quite yet because of, I want the CO2 to kind of build up and for the loop to trigger for turning on the fans, and then I'll show how that works and how it dissipates. So this is the boot up cycle, which is relatively quick. And now we're getting basically a debug stream from the console write lines and printfns out of the code that you see above. And it takes a moment for the sensor to initialize and start talking to the microprocessor and for it to start displaying. So here we go. And we'll give that a couple of cycles for it to start registering new values. I'm going to inject some CO2 into the enclosure. You can see the CO2 value going up, and this is registering in parts per million. And if it goes over 750, it starts to remediate, and then once it gets below 650, it then shuts off again. So pretty straightforward. I'll do another injection and keep pushing it a little bit so it actually has a few more seconds to run. And this is running on a 2-second cycle. But of course, in a production environment, it would run every minute or run every 2 minutes. So again, the ventilator goes back off and it's going back into the blue zone. So you can look at the fan and see that it actually triggers, and you'll see the relay will So I'm going to let that run and let it idle in the background. The valve will continue to emit some CO2 because that's the way those bicycle tire inflators are. Once you pierce the head of the cylinder, it just continues to leak CO2 until it's empty. But I'm going to go through the code and actually show how this works. And we'll start with the bottom and work our way up to the top. So you can see here I'm sampling the value every 2 seconds. And that value is being emitted into this observer and going through the process of actually extracting data out of this. Now, this particular sensor, the CCS 811, actually gives you 2 values. One is the CO2 value, which is the first value, and the second is a VOC value, which is kind of a more general term for like the amount of particulate that's in the air. I'm only interested in the CO2, so you can see here I'm actually doing a match that's only pulling the first value out of that tuple. And I'm going to talk about the signature for that and how the Wilderness Labs ecosystem did a really good job of building a very deep and useful model, including the units definition that was first a stumbling block, but then became really enabling. And I'll talk about that in a minute. And that's part of the support that I received from the community to really kind of get through that process and understand how that works. But this is the idiomatic part that you'll see in a lot of F# code, where you have a match expression where you want to go through a match of value to return something out. And this is to return the value back to that display. And here, of course, the base value, whenever everything is fine, I'm giving back a sky blue. Here I'm using burley wood, which is kind of like a Los Angeles smog kind of color. Orange is kind of between that smog color, and there's Los Angeles for you in the background. And of course, once you get above 2000, I just made that red. These values are arbitrary. The 750 really is the value that I care about, and the one that's kind of based on that research. But here I'm just setting some thresholds so I can actually see that the loop is actually working and is actually getting new values and changing what's displayed. So I'm going to pause for a moment, go back up to the top, and look at what this loop is doing whenever the ventilator is turned on. You've seen that happen whenever the console actually emits the value that the ventilator is on. This happens whenever this value goes above a certain amount, and it basically spawns a separate thread and runs that thread in parallel while it continues to emit the new data values out of the observer. So this to me was what was really compelling about the Meadow, is that you can run a multi-threaded application in it, and it's very kind of like garden variety idiomatic code to get it to run. So basically sending an async start and then wrapping the function in an async, and it just works. And there was a little snag that I hit in that process that I want to get to before timeout, but where I stubbed my toe a few times and got helped out by both the Meadow community and the F# community. So there's a couple of state management things that I'm doing here with these mutable values, these Booleans, and that's the thing that basically says, while I'm in the loop and it's above the 750 value, if the fan is already running, then don't trigger the event again. And that's what this is. And the basic idea here is, once you get used to the domain, this is very readable. Like if the new value is greater than the threshold value and ventilation is not on, then toggle the event. So that ventilation is on Boolean is what prevents it from continuously sending events while the fan is running well above threshold. So it creates a very clean exit for the logic. And even inside the loop itself, there's another evaluation that goes on that basically is looking for whether it actually sets ventilation is on to true so that the observer doesn't send any more events. And this relay 1 is on is actually something that was provided by the Wilderness Labs Meadow in their model that basically says, oh, hey, this is a relay. we have a model type for this relay, and therefore we're going to provide this thing that says is on, that provides a Boolean, so that you can evaluate whether something is on. And so this is that thing of, instead of having to have it toggle on and off on a hard cycle, you can simply continue to evaluate for the state and continue to loop through. So it creates a very smooth experience, and then you toggle off whenever you exit out after it goes below the threshold. So I've been talking about these thresholds, and I set them up here as these immutable values. And the threshold to turn the fan on is 750 parts per million. And you'll notice that I actually set this very verbose explanation for this, and there's a couple of reasons for that, and I'm going to get to that in a minute. The second value is what the clear threshold is once it gets below that value. And a lot of HVAC systems actually work like this, where if you set your thermostat to 75 degrees, it actually doesn't cut off until it goes to 74, those kinds of things. So this is similar to that, where I wanted to bring it all the way down into the blue zone before I switched the fan back out again, and then allowed it to creep back up to 750 before it would trigger back on and push it back down. So the latest CO2 value is just a nominal value because the sensor itself starts at 400. And the previous CO2 value I set at 0 for a specific reason, and this is where I got caught up in one a specific hang within the evaluation here, where basically if I was looking at this old value and it was null, it was actually causing the process to hang. And so I could actually just do, because of the type system, it has this function called hasValue and gives a Boolean back. So if it had a value, then I would do the assignment into the previous CO2 value. Otherwise, I would leave it at that 0 that I had originally set. So it would always evaluate because there's a 0 there, it's not a null. And that way, when I'm running this function where I'm only emitting the new value to the display whenever the previous value is different than the latest value. So if they're the same value, then I don't bother telling the display to do anything. Right now, while I have power on the USB port, it's kind of an infinite power supply. But when you're running on battery, and eventually there's going to be times where you want to have a quiet time and not make the processor do this repetitive work. Right now, I'm using a very short time scale on purpose for the demo, but when you get into time scales of minutes and hours and you want the battery to last weeks or months, you have to start being concerned about whether or not you're telling the processor to do certain functions and wasting cycles. So this is a really simple proof of concept, but I wanted to start at least including a little bit of that to show that there's ways that you can actually make it sensitive to that. And the thing that I really like about this is that all of this is expressed with less than 75 lines of code. That's probably the biggest lie you're going to hear here today. And that's because there is a ton of code that's behind the scenes that was produced by Wilderness Labs that gives a tremendous amount of functionality that I can just access very easily within F#. So it's all written in C#, and they're all libraries that I bring in. But if you look at the way this is built, I'm actually just declaring Meadow Foundation sensors.atmospheric, but then I import .ccs811. And that's a special thing about Wilderness Labs Meadow, is that they don't overburden you with like a huge library. You only import the libraries that you need for the specific sensors that you're using. So when you go and you do the open or the using, you'll see it's generic, but you're just going to be accessing that specific sensor that you've imported. So it's a very thoughtful model. It's very robust. It has a lot of support both from the F# community. I've got a tremendous amount of help from them, even folks that had no idea of how the Meadow actually works. They were just seeing what I was trying to accomplish and actually helped me get past some of the roadblocks. And of course, the Wilderness Labs folks are just really tremendous in terms of not only building a model that works really well for these off-the-shelf components, but also creates an ecosystem that allows you to bring your own device and bring an I2C device or an SPI device that you can actually build your own model, because they've done a really good job of leaving breadcrumbs that you can follow and actually build something behind them. This is one of the projects I have planned. So that's basically the sum total from me, that I knew that I could take this very concise code all the way out to the edge and be able to make it actually run for days. I mean, I haven't run it for weeks yet because I've only been working on it for a while, and I keep tweaking it, so I keep rebooting. But this is one of those things that initially I was stubbing my toe on an async function, and an F# person who has no idea what I was doing within Meadow gave me the answer back in a way that kind of blew my mind and really opened things up. So those are the three things that I'm taking from what I consider to be the start of my journey with F#, which is take the kinesthetic approach and learn while doing. Like just watching videos or just reading a book is not enough. You definitely need to do that as well. But getting inside of that inner loop and working with the tooling, it's very inviting and very rewarding. And that's definitely something I would recommend everyone do. The second thing is find a problem that you've solved before and find a way that F# has solved something similar to it in its own ecosystem. And that way you can make your own connection to the way things operate in that world. And then the last and most important thing is, and if you've been watching any of these presentations, those resources are everywhere and they're really phenomenal. You can, I've been able to talk to the folks that wrote the books that I've read. I can talk to Don Simon. I can, send messages on the F# Slack forum and get answers back from folks that I've just finished looking at their library online and they help me pierce the veil. So I would very strongly recommend just to get involved and to start experimenting with it because it's a very rewarding environment to work in. So thank you so much for listening and for watching me go through all my toys and everything, and enjoy the rest of the conference.
Thank you, Houston, for the great talk. It was great to see your setup there. And let's see some of the comments we got. So our friend Beth was saying what a really nice setup, and it was really cool to see like the cameras and everything that you had there for us to really see the demo really well. So thank you. And there was a shout out from chat for showing that mutability in F# can be used for good at .NET Conf today. Immutable.
That's really, yeah. You know what? That's I should have mentioned that in particular. Sorry, the head of Wilderness Labs, he basically said that immutability is actually kind of a hindrance for these limited resource processor things where, and this is, you're talking to the outside world where you're talking to the display or you're talking to the sensor or you're sending something out somewhere else. You have to have a mutable structure. It's kind of based that way. And that's one of the things that I ran into trouble with where I was doing a sleep inside of an asynchronous thread that it was basically after a couple of cycles, it was replicating an overrunning memory and causing the thread to jank. As soon as I started using the async thread and async sleep, then everything really smoothed out. But that was the beginning of understanding that in that ecosystem, mutability, particularly as you're talking to the ports and adapters level, is really an advantage.
Yeah, and we got a question from the Twitch chat. If there is a framework to do stuff like this in an Elmish way without the mutable var. So do you know about that?
So I don't know, but I'm looking at like using Akka.net. I know that Akka.net it's an actor system that people have used with mobile devices, and I'm very interested in that kind of encapsulated function where it, using the threading, and there's a coprocessor as well. I didn't mention that, but there's an ESP32 coprocessor that can do its own work on the Meadow board aside from the STM32F7. So there's a lot of opportunity there where it's entirely possible. If you can do it in .NET, I would imagine that you could at least try it with the Meadow because it's very amenable to that. It's designed to be a kind of a garden variety kind of .NET experience, with resources notwithstanding.
Really cool. I really appreciate your talk. It was excellent. And you mentioned that it's a polyglot world, right? And so up next, we have Paige Bailey and Maria Nagaga to talk about polyglot notebooks in the wild. So let's welcome them. And thank you, Houston.
Thank you so much.
Hello, ladies.
Greetings. How are both of you?
I'm doing great and so excited to see you both.
Excellent. We're excited to be here, and I have loved learning a little bit more about F#. I am not, I don't come from a C#, F# .NET background at all, but seeing the great tooling that's being created is really inspiring, and learning about folks' use cases, especially in data science. I'm really excited to share some of the things that we've observed. And then Maria is also going to do awesome deep dives on the .NET Interactive piece. So it's very cool.
Hey, Maria, I want to check that your mic is on. So can you say something? Yeah, I don't think we can hear you yet.
Yep, there might be a mute button in the browser. I know that these the conference software is all like, it feels like it's different for every single one.
Yeah.
Yep, but
any better now?
yes, absolutely.
Okay. All right.
All
I think my fancy mic is no longer working. Anyway, it's done its time. It's done its time. I think I've had it for like 6 years. You know.
Oh no. All right,
tried.
Time to ask for a new one then. So take it away, ladies. I'm excited to hear more about polyglot notebooks. I'm always curious and I always find it fascinating, that topic, and always leave with full of ideas of how I could use that in my world and my day-to-day. So take it away.
Perfect.
Myra.
Excellent. Thank you so much. So to begin with, I guess we could do very brief introductions, and then kind of a roadmap for the conversation today is I'll start off with presenting the most minimal number of slides possible to kind of set the stage for why polyglot notebooks are interesting, kind of the usual suspects in the space today, and then also why .NET Interactive and the .NET Interactive notebook experience within VS Code is so compelling as a Python and R person coming into this community.
Yeah.
Excellent. So Maria, do you want to start with introductions? Or?
Yeah, absolutely. My name is Maria Nagaga. I work on .NET Interactive as well as parts of ASP.NET. So I focus like on .NET minimalism. And .NET Interactive has been a fun experience. Like Paige, I am not an F# developer. But F# is like a huge reason why we need this multi-language notebooks, because we do see it as a really huge push in the .NET ecosystem for data scientists, right? Bringing data science workloads to our users. And unfortunately today, like most of my demos will be slides because I have an incredibly slow machine. So I need an upgrade with that as well. But I do have everything recorded and I hope you enjoy it.
Awesome. Excellent. And my name is Paige. I am a PM based in the Developer Tools division, and I get to work on really interesting projects in the machine learning and data science space. So for example, code spaces, building out the data science story there, as well as machine learning integrations in developer tools. So if you've seen recently some of the interesting stuff around Copilot, around IntelliCode, I get to work with those teams and sort of help test out that functionality and brainstorm new opportunities for machine learning to be impactful in developer tooling. So with that, I will begin presenting my screen, and this is the first time that I've used this software as well. So bear with me if things do not go as planned. So sharing screen, sharing window, and soon you should see VS Code in the background. So I'm assuming that everybody can see my screen. If you can't, feel free to like Maria shout out that you cannot. And
I can see it.
Excellent, beautiful. We have success. So this is VS Code. It is my great pleasure to inform everyone that if you, like me, are perhaps not a fan of slides as done via PowerPoint or slides.google.com, you can totally do slides within VS Code using the MARP extension. So you can see here that I've got Markdown written off to the left and a preview off to the right. And I am going to expand out. And so hopefully you should see kind of a big full screen version of the slides that we'll be presenting today. So this conversation about polyglot notebooks, I think it's important for us to kind of say, well, what are notebooks and why are they useful? and how do they exist today? And what you can see on the screen here is an example of a notebooks-based environment called Jupyter Lab. This is the ArcGIS extension in particular for Jupyter Lab. But it's really a great way to mix data visualization, and descriptions of data all in one place. So it's a really effective communication tool for this kind of work. And when Jupyter Notebooks first started, they were really intended to be, you know, just kind of that, like a fancy REPL with some markdown, some Python code interspersed, and you know, just kind of a way to communicate analysis. But over time, these notebooks have evolved to be many, many different things to people. And so notebooks today are, you perhaps have heard of Jupyter Notebooks, Jupyter Lab, Interact, and many other notebook environments. They're used from everything for automating and running makeshift integration tests with things like NBDev, to preparing, delivering, and checking student coursework with NBGrader, to generating API documentation. So you perhaps have a notebook with Markdown and with code, and you run it nightly as a cron job, and it generates an HTML output that's then doing notebook documentation for your library. And the nice thing is that you can develop tests for that, right? Like, so if you make an API change, and then suddenly all of the code that you have and all of the descriptions in your notebooks break, then that's a great indication to the dev team that, you know, perhaps this notebook, you know, it indicates that the API change was problematic, and we should, you know, roll back. You can also publish books, PDF documents, full websites, slides using notebooks. You can have it as an interactive pseudo IDE for data analysis. You can do large-scale data pre-processing jobs. You can create interactive embedded web content. You have fully featured IDEs. You have automated customer support and troubleshooting guides as runbooks. And you can also create these shareable data analysis artifacts. So there are really just so many different and very creative ways that people have evolved notebooks over time. And today, I really want to focus in on this segment right here, which are you know, Databricks, Polynote, Zeppelin notebooks, and .NET Interactive, that allow you to do multi-language notebooks, and to sort of support these large-scale workflows. And so multi-language notebooks are quite compelling for a number of reasons. And it's largely because, you know, back in the day, I used to be a data scientist and a machine learning engineer. But you would create this beautiful analysis. Perhaps it's using Python or R, and Python and R as languages. You know, they're great at many things, but they also leave a bit to be desired if you're moving into a production context. So I'm not sure if folks on the call are familiar with something called Pandas, but Pandas is a Python library for data preprocessing. If you need to do it on kind of in-memory data sets, you know, it works nicely if you're just doing it on CSVs. If you want to take that model and to move it to work on large-scale streaming data, then Pandas suddenly does not work quite as well. And perhaps you would need to re-architect this experiment where your data input preprocessing steps are in something like C# or in Java or Scala, or, you know, something else that's a bit more performant. And so taking these analyses into production, it can get quite complex. And even if the entire like sort of prototype of a model or a data analysis might be implemented in Python or R, the big broad scheme of things the data validation steps, the data extraction, kind of these ETL pipeline building steps, the steps for building and testing and having pipeline components. All of this gets rewritten into other languages, and sort of your notebook, even though it has to be maintained over time and updated, it gets kind of dismantled and dispersed into these disparate files. And for maintenance purposes, that's terrifying because you don't, yep, and you don't, and I can't see my like the people part. So if I heard, I think I heard something. So if I steamroll ahead, just be like, hey, you know, like. And
this was me agreeing. I was just like it's hard to maintain. I was like, that was
awesome.
nice.
Excellent. And Maria understands it better than anybody else. It's like the sort of breaking apart pieces of a notebook and dismantling it is a nightmare for maintenance purposes, because you end up with all of these disparate files that are managed by perhaps different teams, different people, they're in different languages, when it would really just be lovely to, just say, oh, hey, like this original notebook, here's all of the bit pieces and components that comprise this experiment. And if, later on down the line, you need to update the analysis, the data scientist can say like, okay, well, this pandas logic maps to this Scala logic. And so, Scala person, I made these modifications to the pandas piece, like, please make those same modifications to your Scala piece. And so, yes, so the answer is, how does it go into production? Very painfully, unless you have something like a multi-language solution for notebooks. And with that, I am going to hand it over to Maria to talk a little bit about .NET Interactive notebooks and about some of the really interesting work and experiments her teams have been doing to bring this to VS Code. The visualization that you see here is from a delightful Medium blog post from Andre about F# and how it can be used from data science. But he's going through and kind of using the .NET Interactive functionality in order to visualize and understand his data set. And with that, I will stop sharing and we can go into Maria's demos.
Thank you so much, Paige. So let me go ahead and also share this as well. So I'm just going to share and pick a screen.
Cool.
Let's do that. I know I've done StreamYard before, but I'm always a little bit nervous. So let me know if you can see my screen and what it looks like. Perfect. So I wanted to kind of start by saying that when .NET Interactive, when we first pitched it, when it was pitched to my team as an idea, it was one word. Hey, ML.NET and Spark.NET need Jupyter notebooks, and that was it. So they reached out to our team who built the Try.NET experience, and we're all about how we run code independently and also together. So notebooks actually felt like a natural fit for us. So the first version of .NET Interactive were completely compatible with all the popular Jupyter frontends. So Jupyter Labs, Jupyter Notebooks, .NET Interactive will work the same as it will in VS Code, just minus a few things, like you won't get the same level of IntelliSense that you would get in VS Code as well. But I really wanted to talk about multi-language and why multi-language was important for us as a team. So as I said, we got this, and let me just start my slides. I do not have fancy slides that look like they are in VS Code, but I'll try. So when we were talking to our users and we were talking to the chief data scientist over at Citibank in the United Kingdom, he mentioned all these problems that Paige had shared with you. where you're working with your engineering team that is using something else, and you give them your model in Python, and then they look at it and they're just like, how do I transfer this into C#? How am I able to leverage the libraries that are popular in Python or JavaScript for their visualization? And he told us like the most important thing for us is the ability to use the right language for the job without the need for a wrapper. So .NET Interactive today has F#, C#, PowerShell, SQL, JavaScript, HTML, and I hope so many more languages in the future. So let's jump into what this experience is like. The goal of this experience is to use the best language for the task at hand without a need for a wrapper. So far, we support 6 languages out of the box. C# and F# we announced in 2019. PowerShell in 2020, that was brought in by the PowerShell team. JavaScript and HTML support the same month. This allowed us to open up the doors to create rich visualization without the need for a wrapper. Like, we're just like, just build a wrapper around it. And we're just like, no, if you want to copy and paste a D3.js sample and access a C# variable from there, you should be able to do that. And this year, we introduced SQL support with the SQL team, and we also had the added benefit of richer visualization that didn't require anyone to write any code at all, right? So those are like all these rich experiences. So what does .NET Interactive look like today in VS Code, and what can you expect? Overall, richer tooling experience. So you can see IntelliSense, right? That's really cool. And we also made the need to have an optional Python dependency. So when we initially introduced Jupyter, the biggest feedback that we got specifically from our .NET customers is like, why do I have to install Anaconda and Jupyter Labs and all this stuff and Python in order just to use a .NET notebook? So with VS Code, all you need is VS Code and the .NET Interactive extension, and you are good to go. So what really makes us super cool, like as you said, polyglot, multi-language notebooks are incredibly important, but being the ability to switch from one language to the other is great. But the ability to share a variable from one language to the next between cells is huge. Like in this sample over here, I have the variable x that was defined in C#. I accessed it in HTML while going through JavaScript. And you can also run the exact same multiple languages in a single cell as well, which can make it really good for things like scripting, right? Or plugging in your DevOps pipeline. So we wanted to create these experiences that just felt absolutely natural to the scenarios that even non-data scientists, like people who are in C# developers, would just feel like, oh, I could benefit from this experience. As I mentioned, that we have SQL support. SQL support for me is one of the funnest things that we've done. When we did this, we said, wouldn't it be cool if we got code completion on the SQL schema? So as you're writing in your code and you've accessed the SQL database, you're actually getting code completion. And then you can also quickly scaffold DB context to use LINQ, right? Which is incredibly important for our customers as well. So if you're a C# developer and you want to switch to using EF and using LINQ, you can do that really easily and get the same experience that you'd get, let's say, in VS. And then native JavaScript support. As I mentioned earlier, in this example, we defined a variable in C#, and then we're able to access that exact same variable right within JavaScript using interactive C# get a variable of C#, and then being able to render it using D3.js, right? And then you're able to bounce between the different languages. Like, okay, I'm going to set a task, run it through a range, and you begin to see the visualizations controlled in a language that you feel most native to. And the other thing that I also wanted to make sure that we did is being able to leverage popular ecosystems that exist within the Jupyter space. Like Interact has an amazing data explorer. So we created a way for people to just naturally get the data explorer to display their data with just using a method. So by just simply doing .with Interact Data Explorer, you get this visualization. No extra configuration. You just had to give it an object to work with. And we're also able to do the exact same thing with Sundance, which I think is an incredibly rich library. So everything that we use here is pulled through an extension. You use what you need. So I'm just going to fast forward a bit over here, and you get like cool visualizations like this, right? And you can spin them around, and like the user gets this by just adding an extension. And that's what we wanted for customers. We've also seen people create their own extensions as well that sit on top of .NET Interactive. There's someone in the community who built a Razor extension. We have people building ASP.NET extensions so they can test their APIs instead of using something like Postman. And these are just like things that people are just naturally feeling is a great fit for notebooks. Oh, and this is one of my favorites. So being able to render real-time live stream data is huge. And in this sample, what we're doing over here is that we're getting data from a thermostat, and we're going to actually render it in a pretty cool visualization. So I'm just going to switch over here. And what we're getting over here is that we're able to pull in this JSON file, do all the data processing in C#, and get this really nice 3D beautiful visualization just running in a notebook. You can think of this as a great way for education, a great way for you to build samples and tools. And when I was looking at Houston's demo before, I was just like, oh yeah, Houston could have pumped his data through something like this and get this really cool visualization, which would have both an IoT effect as well as this rich visualization that you get within a notebook. And like that is all I have for the experiences, and I'd really like to have it, open to the floor for questions.
Absolutely. And it's so exciting for me to see this exist. The data science projects that I do usually follow the same general format, which is you're always trying to pull in data with SQL. Yep. Or if you're in Microsoft land, it's Custo. Yes. But you're pulling in the data. You're potentially pre-processing it with R because the tidyverse tools are just beautiful and really sort of intuitive and like standard APIs, really elegantly documented. And then for algorithms, you're probably using one of the great Python libraries. So scikit-learn if you're doing traditional machine learning, or if you're attempting to do deep learning, perhaps PyTorch, TensorFlow, JAX. And then visualizations, like you could either use a Python library or an R library to generate the JavaScript, or you could like fiddle with it yourself. But it's all like this multi-language process. And I'm really, really hopeful that we can get Python and R added to the Omni kernel that your team has created for Jupyter notebooks and for notebooks in VS Code, so that we can open up this to even more user types.
Absolutely. And I was doing a user study today, and it was with a group of students. And they said, I use Python and R, but usually I have to like switch over to RStudio or open up a new notebook and then figure out how to share the data from one place to the other. And I was like, imagine if you could do this, right? Like you had it in a single notebook. And then we showed them the JavaScript support, and they're just like, what? There's JavaScript support in notebooks? I was like, yeah. And it's pretty neat, right? So people are naturally just feeling the need for multi-language notebooks, whether you're a student who's doing AI and machine learning, or you're a person with troubleshoot guides where they're seeing a huge need for multi-language notebooks, and data scientists who are just like, I need to mix all these different languages in order to feel productive in my work, right? So I think there's a huge space opportunity for us here.
Absolutely. And the .NET Interactive experience, it also works in code spaces if folks want to go test it out. So it's and definitely would love to hear feedback about notebooks in VS Code in general, and then in particular the kinds of languages that y'all are interested in seeing.
Hello, ladies. I'm back.
Greetings.
We got one comment from Louise. If you don't know where to start with your data and don't want to write too much code, Sundance is a great way to start.
Very much agree.
I would agree.
didn't know about Sandance before, so I'm always learning.
Yeah, and it's in Microsoft. It's a Microsoft research project, and they are amazing to work with. So try it out, give them feedback. They are listening.
Yep.
Yeah, and I think we like on the Learn to Code page, it would be cool to show that, right, for people that want to get started. So on the .NET side, we have a Learn to Code page. Let me see if I can load that. And so we'll give you all the resources for you. It's like for it will give you the interactive notebooks extensions, and will help you to get started with like installing the Visual Studio and the coding packs for .NET.
Yep. Absolutely. And one of the other quite nice things that I love about .NET Interactive and the Omni kernel is that if you're a VS Code person, it works great there. But if you're also a person who comes from more of the Jupyter side, so Jupyter or Jupyter Lab, it also is supported there. And I think this sort of approach to welcome communities from all angles is very important, and being able to build infrastructure that supports multiple user types and meets them where they are is really, really nice to see.
Yeah. Yes.
We got a question from chat. Is publishing, packaging a notebook as a standalone app and executable a thing?
No, it is not, but it is a frequently asked question, right? So one of the things that we've got a lot of is like, can I add another notebook as a package, right? Yep. We get that a lot. So maybe it's something we can explore. It's not a thing now, right? But it's something that has come up a lot.
Exactly. And it's also quite a frequent ask to be able to take a notebook file, so a .ipynb, and to be able to just have the ability to quickly refactor or to turn it into a Python module. So there are, for Python specific notebooks, there are a couple of open source packages that allow you to attempt to convert it into an importable library, but I don't think, to Maria's point, I don't think there's one available for multi-language notebooks yet, though that would be super interesting.
Not yet.
Yeah.
And do you have a public roadmap, Maria, for the .NET interactive work? Because every time I hear you do a talk, there's always cool stuff being shipped. And so
yeah. So we don't, right? I do believe that once we have the Python, like one of the things that Paige and I are hoping to do is have Python and R support, and then introducing when that will turn on. Another thing that we have built is like a validation kernel that can be used in the classroom that actually checks the students' work as they're looking at it. So I need to just write the roadmap. It's me. I have it in a PowerPoint. I just need to put it on our repo.
I didn't mean to put you on the spot.
No, it's good. I need to be put on the spot. People have been asking for it for months, and I just said, yeah, it's coming. So basically, let's just say by September it will be there.
Okay.
Yeah.
Thank you so much. I'm wrapping up my shift here at .NET Conf, so it was my pleasure to be here with you all. And we're gonna bring Javier, will be our next host. Are you ready to come online?
I am here. Hey, ladies, how's it going?
Pretty good. How are you?
I'm doing great. It was a great presentation, like always, right?
Thank you for having us.
Thank you for speaking, and thank you all of you for watching .NET Conf Focus on F#. We actually have Olia, our next speaker, coming up, so I'm doing the producing and a little bit of hosting here and removing some people. So Maria, I'm going to remove you first, and then Myra, and then Paige. And clicked on the wrong thing. Hey, Olia, how you doing?
Hi, I'm pretty good, thank you. How are you? Thank you for having me.
Great. Thank you. Thank you for doing the presentation. We're right on time for you to start. So if you want to go ahead and share your screen, we can get that going.
Sounds good. Yeah, I was trying to figure out how to share just the deck.
Yeah, if you down, it says share, and then you can just select the window once you have.
All right.
If you already have the PowerPoint up.
Share screen, and then yeah, I have it up.
Perfect.
See if that actually. All right.
Perfect. Go ahead and go start the presentation in full screen. I see it.
Yeah, I think that's gonna happen now.
Yep. Give it a second. No. Oh, I see. It's the wrong screen shared.
Wrong screen. Yeah. I see.
What the joy of doing these things live. So yeah, but anybody, anyway. So if go ahead and get that going. Oh yeah. All of you people watching, remember, ask your questions using the hashtag .NETConf. We have a team of people looking at them and putting into the tag board. So keep them coming. And thank you for, if you've been watching the entire day, like some of you have, I know. Thank you so much. Remember, all of these are going to be recorded and posted on YouTube channel 9 after the conference. It usually takes us a couple days to get it all spliced up because, we'll remove some of the banter, like me talking right now, so you don't see any of that. You just see the great content from our speakers. So also we have on the website, remember we have a swag bag giveaway. So I recommend that you go to focus.netconf.net. Thank you so much. There and /swag, and then sign up and get that going. So that would be great if you can do that. We're planning on giving away the prizes here at the end of the day. So if you want to be part of that group, please go ahead and sign up. So still trying to figure it out?
Yeah. I'm sorry.
It's all good.
It's taken a little bit.
Yep.
Yeah, I guess I'll just share a different screen, whatever one is there.
Yeah, I recommend whatever. Go ahead and start your PowerPoint and get it all going, and then do share in whatever screen that's in full screen. Share that screen.
Sounds good. Okay, I'll try and do that.
Yeah. So the funny thing about, and go ahead, keep doing this. The funny thing about this, I literally am getting a tan because I have a screen here, I have another screen here, all over the place because we need that much stuff.
Screens, yeah.
Yeah.
All right.
It's always great.
It works this time.
Yeah.
Sorry for the delay. Let's see. This should be the one, I believe.
All right.
Yeah, that looks better.
There it is. I'll bring it and I'll mute myself and go take it right away.
All right. Thank you. Okay, so hi everyone, and welcome to my session, and I hope you will enjoy it. So my name is Ola. I'm a software engineer, and I have joined my current company, Dimitrix, almost 2 years ago, and that brought me into two exciting spaces. So one is I made a dive into biotech. This is a domain that's nothing like I've ever had to deal with before. And another thing is getting to code in F# as a full stack programming language, which is something I was sort of prepared for, but I was really excited to do it. And so this has been a really fascinating journey for me. And I would like to share it with you, and mainly focusing on the software part of it. And of course, focusing on F#'s role in all of this, and it being the main tool for building our software. So before I get started with it, I would like to say thanks to all of the software engineers at Dimitrix, all of our people who do data science, IT, all of our scientists, and also a huge thank you to F# community, because it has been incredibly helpful over time. And without all of these people, the things that I'm going to be talking about here wouldn't really be possible. So a tiny bit about me. So I'm a software engineer. The first and like the most part of my career, I was a classical .NET developer, mainly coding in C# and doing some F# in my spare time. And since recently, I have been a full stack F# dev and have been enjoying it. And here you can see some of my interests in tech, and here's my contact info. So as for the plan for the talk, first we'll take a quick look at biotech and how cool it is. Then I'll tell you about Dimitrix and what we do, challenges we face, We'll take a look at our zoo of technologies, the software we built, and then the role F# plays there, problem solutions, lessons learned, and hopefully we'll get to Q&A as well. So the biotech world. So when you start looking at it, exploring it, it kind of makes you feel like you're in some kind of a science fiction novel. There are so many things that are possible currently, and this sphere really keeps developing really fast nowadays. And for example, a cool project in the medical domain is malaria medicine manufactured with yeast. There are a bunch of interesting things going on in the environmental space. So scientists figured out how to biosynthesize various construction materials like cement, or biosynthesize things like leather. Also, there is a cool project in the food space, Impossible Foods. So what they did, they discovered that heme molecule is basically the molecule that's responsible for a lot of the meat's properties. And so using it, you can sort of replicate the meat. And so they, just like Emrys for the medicine, they modified yeast genetically to make it produce that heme molecule and set up a process to produce impossible meats or impossible burgers with those meats. There are some weirder use cases, like people are trying to use DNA as a data storage and store data in DNA, like catalog DNA. And there are some fun products like Z-Biotics, which is a biosynthesized probiotic that eats acetaldehyde, which is something that causes hangover. And so before I just talk too much about it, let's actually move on to Dmitrix and what does it do in the biotech space. As for Dmitrix, similarly to some of the examples that I talked about, we're in the space of metabolic engineering, and we genetically modify yeast and kind of put the metabolism of a plant into yeast, and using fermentation, make it produce the compounds that we need, just like the plant would do. And so the current focus of Dmitrix is on synthesis of rare cannabinoids that are safe, legal, useful, and good for health and wellness. And you would think, why would you do it instead of just extracting those from the plant? So the thing is, especially for the rare cannabinoids, it wouldn't be really efficient because you would have to waste a lot of plant material to do that. And yeast itself, it's easy to grow, and therefore, based on yeast, you can build a nice and scalable platform. And you just have more control over things like making your process cleaner, more efficient, which is pretty great. And that might sound a bit easy, though I'm telling it, and you might think, oh, I can just set up a lab at home and just do the same thing as Dmitrix does, but not really. There is devil is in the details, and you'll see it soon enough as I'll be showing you how the process looks like and how the software that supports it looks like. So at the kind of very high level view, there are two main avenues that are necessary for things to work. So one is the R&D and strain engineering, which is basically focused on designing optimal yeast strains and all the things around it. And the other one is manufacturing and process engineering, which is focused on all things related to and around the fermentation. And this is all not easy because you can't really just make a perfect strain of yeast from the first attempt. You have to make a lot of experiments, do a lot of testing, analysis, and you need to optimize things too. And then fermentation is also not that easy because you need to figure out how to make it consistent, how to make it scalable and robust, and how to make the strains perform optimally, ensure that they don't die or anything. And also you need to extract and purify and preserve your resulting products. And for all of those things, you need processes set up in your lab. And for each process, you need a team to run it and enhance it and maintain it. Let's see. And this is bits of what it looks like in real world in the lab. So you see some of the robots here and some of the lab setup, and it's only a small part of what's actually there. And so as you imagine, those robots produce a lot of data that you need to work with and make sense of. And for all of the experiments, you need to capture all the relevant information. And you also need to orchestrate between the different groups in terms of timing of things to happen, given all the dependencies that are there, and keeping the possible issues in mind, like something breaking or going wrong. And of course, given all of that, for a lab to be efficient, you need some good software to support and make this process optimal. And you probably won't be able to just get away with spreadsheets. Well, I mean, you can, but you won't really be efficient or scalable. So if we look at the logical view of it, this is actually a view that was generated by my coworker Heen when she was doing user story mapping sessions with all of the scientists. So here, only some of the parts are shown, and you can see the complexity. And if you further zoom in, some of those little squares would also become complicated workflows. And so we actually need to build a model of all of this, of the real world. And we need to make sure that we don't make it too complicated, because then you'll just drown in complexity and won't be efficient. And if you go too abstract, you'll just lose some valuable data and insights. And you need to care about things like the software being extensible, scalable, et cetera, and of course have a nice user interface for the scientists to be happy. So that leads to some of the challenges that we face. So there are some challenges that are specific to our world listed here, and there are also the challenges that are pretty much common for any software developer out there, like hosting your application, testing it, setting up CI, logging stuff, choosing a good source of, choosing a good place to store data. And so all of this combined is a lot to deal with, and like we'll take anything that will help us to save us some headaches. And the thing that will help a lot is the right choice of technology, because that can really make a lot of things easier. And so let's actually look at our technical landscape and what's there. So as you see that at the very heart of it, we have full stack F#. So we have Giraffe as the web server sitting on top of ASP.NET Core. We have Fable, Elmish for the front-end stuff. And the rest is pretty standard. Like we host things on AWS and we use PostgreSQL as our database. And if we look at our applications, we have three main ones. The core one is LIMS, which is Lab Information Management System. And then we have a commercial app that's in the works. And then we have a data warehouse with an app for visualizing some things, and Grafana that is hooked up to the warehouse. And besides that, we also have smaller apps and scripts developed by software engineers, scientists. Not all of them are written in F#. Some of them are in Python and R. Excuse me. And they also need to talk to LIMS. And so in order to achieve that, F# has been really helpful. And I mean, having F# as a language that is everywhere. Because then you can share a lot of the code across your front end and back end. And that includes some of your types. That includes code that helps you deal with the control your code flow. and things like logging, which is pretty great. And looking at an individual app, you see that we have an API layer here. It's just an HTTP RESTful API, and that is something that external apps and like non-F# apps can easily talk to. So an important thing that we need to deal with is the language of scientists. So we have lots of different groups. Every one of them has its own language, and sometimes there are some ambiguities in terms of terms, and so we need to address that, make sure everyone understands each other. And so the way we deal with it is through ontologies. So it's a central place where all of the terms are stored hierarchically, and here you can see the database schema for that. So at the top level you have domain, then you have namespaces within the domain, then you have your tags, and you have things to manage relationships and to assign those tags to objects. So let's look at the apps and the front-end stuff. So LIMS is hosted as one large application, and it has a set of kind of federated Fable applications inside of it. The first one we're going to look at is DNA Designer. A neat thing about it is that inside it uses a special language that scientists can work with to define their DNA. And if you want to learn more about the language itself, you can check out this article, and you can look at the Dimitrix's talk by Darren from 2017, which focuses just on this language. Pretty interesting. And so, yeah, scientists define DNA here, compile, making sure everything is good, and then they access it here and take different pieces that are available, build the resulting sequence, save it, and once they're done, they can actually build it in the real world, and then they need to make sure that it is good and it is constructed as expected. So it goes through sequencing, and here you can see the result of quality control. And these little red sections, they show deviations. Another important thing that we need to do is to keep track of everything. When, for example, you put something into a freezer, you need to know exactly where it is when you come back for it later. And so scientists at Dimitrix, before going to the freezer, they first look things up in LIMS, find the exact location of like the plate or whatever it was, and then go get it. Another important aspect, as I mentioned before, is to be able to coordinate between humans, robots, different groups, and make sure that things are handed off at the right times. And so here you can see some of the software that helps with that. Here is the schedule of submissions for analytics processing. And on the right, you can see a sort of a visualization of experiment process. So on the left here, you see what's planned. On the right, like what's actually executed, and all kinds of associated data and like structure stages of the experiment. This is an interactive way for users to set their layouts for the experiments, to define what is inside the plates and in which locations. Very nice and convenient. And this is built in Elmish with an underlying React component, and there's lots of SVG magic going on under the hood. And another thing is data visualization. So we have a lot of data coming from various robots and like a lot of fermentation data specifically. And for fermentation, scientists need to track a lot of different parameters as the yeast just grows, does its thing. And this is a way to reason about this data, analyze it, compare different runs and such. And this was built using a nice open source library of Elise Plotly, which is a Fable wrapper around Plotly.js that is a port of Python's Plotly. So this is an example view of Grafana that we have set up and connected to our warehouse. And this is something that our scientists use to build their own dashboards and to just play with data as they please without really having to write code for it. And the last app is Dasware Linter. It makes the setup of reactors easier. So for some kinds of reactors, people need to write basic scripts, and this helps them with the syntax and sanity checking. There is this on hover information, and also there is some magic in the right panel that, so basically the app uses set points parsed from the script in order to predict titers using a deep learning model trained on previous fermentation runs. And yeah, now let's actually move to F#, and what is its role in all of this. So if you think about what makes building software enjoyable, when you start modeling your domain and working with some data, you really want it to be just easy and natural. You don't want to think about it different from the way you think about it when you whiteboard your solution. You don't want to spend a lot of time on error hunting, and you really want to focus on solving problems and not on just kind of related boilerplate ceremonies. And you don't want to feel stupid when you do async and parallel programming. You just want it to work and to have nice primitives for it. And of course, you need good tooling that covers your needs. And a great bonus is a supportive tech community. And it becomes vital, especially for smaller companies that don't have their dedicated competency centers or experts that are willing to help if you cannot find your answers on Stack Overflow or something. So let's see how F# will help us with some of that, and is helping. Excuse me. So one thing that is really great for modeling your domain that F# provides is the type system. Things like records or end types, discriminated unions or types, a cool thing, single case unions that help you to differentiate between primitives across domains, like for you not to accidentally get a vessel by using a tag ID or something like that. And of course, good collections and functions helping to process those collections, and pipe operator. All of this combined for a C# developer might feel like a better version of LINQ. So in terms of error hunting, so previously I feel like I spent way too much time on it, but here I mainly do it if something goes wrong when I'm doing some integration work, or maybe if it's an error related to issues with some JavaScript component that I'm using, but not as much troubleshooting of our own code base. And why is that? So one thing is the compiler. Really, the compiler has become my friend. It really helps me where I forget things or miss things. Type safety is pretty great. And immutability by default helps a lot. And the good thing is that if you really need to have things mutable, you can do it for like performance reasons and such. Then another good thing is option types that helps you to avoid null reference exceptions and such, and to encapsulate your existing data in sum, and if you have nothing, you just say none. Units of measure help you not to confuse, like, I don't know, liters and meters or something like that. And last but not least is the approach called railway-oriented programming. So here you see a picture that sort of shows it. So the idea is to have your bits of code to kind of exit paths, depending on whether your function succeeded or failed, and then you can connect those pieces together in the right, like, based on the flow that you're going into. And I'll show an actual code example of it next. So here you see a type of result that we have defined in our code base. So it's either a success containing some data, or it is a specific failure message. And when you use this, you actually don't even have to write any special code every time. So here, computation expressions help you. They encapsulate this. And so when you write a function like this, you basically wrap your output, which is like experiment in this case, in a result type. And that helps you control your code flow and not have any like boilerplate to write every time you want to do error handling and such. And we actually open sourced our control flow library, and so you can find it if you follow this link. So as for async and parallel programming, here again, computation expressions help a lot. It's nice and easy to do it, and also you have a lot of helper functions that can help you build hierarchies of your async computations or run them in parallel, stuff like that. And here are some links for you to learn more about that part. As for tooling, I think currently, or at least based on my experience here, it seems to be pretty much covering all of our needs when it comes to working with data, working with web, infrastructure-related things, and other stuff. And a cool thing is that we also have all of the bigger .NET World tools available to us, and also through Fable, we have a lot of the JavaScript goodness available for us too. And the F# community is just awesome. They will help you to solve your technical problems. They will help you find a job if you're looking for your first F# job. And if you want to learn F# in a structured way, you can sign up for a mentorship program and do it this way. So yeah, it's pretty awesome. So here, let's look at the front-end part of things. So it is a short example of model view update and how it works in Elmish. So here we have this little file upload component. So the model holds all the data. The view is basically all of your HTML elements represented as lists, which gives you a lot of flexibility to compose them and such. And then you have your messages, and the update function updates the model based on your messages, and your view gets re-rendered. So it's a very good approach to building UIs, and you can build complex things without too much headache using it. So if you look at the web server and API, it is pretty straightforward. So we have a thin proxy layer for the APIs to talk to them. And then here you can see what our endpoint dispatching looks like. So basically, we have authorization here, and we have like handling of the JSON parameters here. And actually, the web API the web API implementation is open source too, so you can check it out and try to use it. So data, we have two ways of working with the database. One is for when we have just static queries with parameters, and for that you just use the type provider that we built. And if you have dynamic queries that are generated based on like optional filters, it's Dapper plus our own custom query builder that is also open source, and the link is here. So is there any room for improvement? So, well, of course, we live in the real world, so there are some things that we hope that would be better. So we would be a bit happier if there was a native task support in F#, and I know there is work going on in that area, and so I'm excited to finally see it in the language. And then another thing is tooling. It is pretty great, and even though we're our team works across different setups and different OSs, everyone is using either Rider or VS Code, switching between them. Sometimes we do hit performance issues because, you know, our code base is pretty big for F#, and so yeah, it gets a bit rough. And of course, whenever it comes to integrations and specifically like interacting with native JavaScript, things can get rough. And yeah, then scientists who try to do scripting, they report that it's a bit harder than it should be sometimes, but over time, there is improvement, which is great. And sort of related thing, some of the people have tried using Jupyter notebooks with F# and have built some nice POCs and such. But for people who come from Python world, some things are missing, like interactive widgets, for example. And so with that conclusion, basically biotech is really a very tough ultimate test for a programming language and the ecosystem surrounded. And F#, I think in our case, has passed this test successfully. And it has been a joy to work with on the back end and the front end. And it removes a lot of headaches and PTSD when you're trying to refactor. And the resulting code is maintainable and reliable, and it can be delivered quickly. This has been helping us be productive a lot. The learning curve for new people is a little bit steep, but manageable, and people get over that and make valuable contributions to our code base, and that includes interns who didn't have any prior F# experience and not much programming experience before, and also scientists who come from various backgrounds, including people who don't have any prior coding experience at all. And I think that's all. Thank you for listening to me, and I hope you enjoyed the session.
Perfect. Thank you so much. It was a great session. So I was going to say we're right on time, so we don't have any questions we can ask right now. So if you want to go to Twitter and answer those questions, that will be great.
Oh yeah, I'll be happy to answer them.
Excellent. Well, thank you, everybody. Thank you, Olia, for taking the time to present for us at .NET Conf. I see that we have Alfonso ready here for the next presentation. So let me get starts rolling here, and we can get going. All right. Thank you, Olia. All right. Let me remove here. Oh, great. I think Alfonso's having some issues from the looks of it. So this is, again, the wonders and the joys of doing a live show, everybody. Mr. Fritz, are you around? Not sure if you are around, if you're being haunted by tornadoes still or not. Hopefully not. Hopefully you're
back.
safe.
Yes, I'm
Hey,
here.
there you
I'm
are.
lurking. So, hello. Oh my goodness. Yes, the treasures of producing a live show. Occasionally, folks have technical issues and they've got to reboot.
Right. I was going to say, I see Alfonso just joined again. So
There he is.
sweet. Let me bring him on so we can kind of, ta-da, there he is.
Yeah. So sorry for
Hey.
that. Yeah. We had a baby emergency because the baby just woke up, so
Oh,
I had to, to change the room very quickly. Sorry.
You know what? Everybody, this is what makes these sort of conferences great, because you never know what's going to happen. And obviously, thank you and your family for making that quick switch and giving a presentation and sharing it with a wonderful community. So I was going to say, so what are you talking about?
So we are going to talk about the Fable. You know, this Fable is a compiler from F# to JavaScript. It just takes your F# code and then turns into JavaScript.
Perfect. So let me ask you this. So several years ago, I know, obviously I know JavaScript, and it's been around for a while now. So we have many different compilers in the past to take, JavaScript and do something with it. So why another compiler for JavaScript?
Yeah, that's true. It's true that there used to be like a CoffeeScript and these many compilers, but now the JavaScript is evolving very quickly, and also we have TypeScript. You are just missing static types. But the thing is that I think it's still valuable to compile F# to JavaScript, because as we've been talking in this conference, F# is a succinct, robust, and performant language, and these are properties that are valuable anywhere. And by the way, this change of focus from functional, it's a big change for the F# community, because especially for non-native speakers, because now we need to learn how to pronounce section in English, which is not that easy.
Yes.
But yeah, there's also obviously if you want to make a full stack application in F#, you need to be able to compile to JavaScript, and it's not. You can do that now in JavaScript using Node.js server, but if you want to use a .NET server, you need to be able to compile a .NET language to JavaScript. And also with Fable, you can use these APIs like .NET APIs, not all of them, but some of the most important ones, and also F# core, which can boost your productivity because you don't have to learn different paradigms or use different code patterns depending on whether you are programming for the backend or the front end. And actually, let me show you, because there's I think I'm gonna share my screen. Okay.
Yep. As soon as you bring it in, as soon as you bring it, I'll share it. It's all good.
Okay, we have it.
Hey, there it is. 1 second. Go ahead and show your code. There you go. I'm going to bring it in.
Okay. Can you see the web page? Yep. The fable.io. Okay. This is the fable.io. I want to talk to you about, just show you very quickly about the Safe Stack, which is an initiative by Isaac and others to make it easier to create this kind of full stack F# web apps. And I think Isaac has already talked about this. So you can take this Safe Stack, just Google it. It's very easily. And you get a lot of recipes here to how to be able to program F# both for backend server and also for the front end. And something very interesting that I think not other compiled to JavaScript compilers have is that F# Fable can also support some reflection, not the whole reflection in .NET, but some reflection. And this has enabled some interesting tools from the community. One of the most interesting ones is this Fable Remoting by Zaid Ajag. And this one allows you to, using for example, this Safe Stack or a SWAF or Giraffe or Saturn server, you can just declare an F# record, and this will automatically build an HTTP API based on this record, and this will be a type safe API. And also we have we have this thought JSON by Maxime. This also a JSON serializer, and the serializer is it follows it's composable, which is very interesting. But if you don't want to write everything by hand using reflection, it's also possible to create automatic decoders directly with just one line. And the important thing about this is that these decoders are going to validate your JSON. It's not like you are doing, for example, from JavaScript or TypeScript that you just use JSON parse and you get something, but you don't know exactly if this what you were expecting or not. So
right.
And the next thing is that actually quite surprisingly, because I guess that Don and other F# designers, they weren't thinking about it at the beginning, but it happens that F# is a really good language to declare UIs in the same way as React does, for example. And we have a very good example here in Feliz. This API to declare UI is also by Zaid. And
it's very happy, I can tell, right?
Yes. Feliz, yeah. I think he was. I think this was homage to Spanish in Spanish origin of Fable. But yeah, it's super nice. And yeah, it's a way to declare to use React to create web applications in F#. And there are other ways to do Fable apps, but this is one of the most common used ones. So it's super nice, not only because of the clean syntax in F# that you can see here, that you don't need so many brackets. There have been some attempts to do this something similar in C#, but you get a lot of brackets and it's not as easy to read. But not only this, it's also that, so if we go here to the syntax, you just need to Google for Felid Zaid. Maybe you see a happy Zaid, but yeah, probably you will get to this page. And
wow.
And this the thing is that because F# also supports overloading. You can just so for example, you see here we have the same helper div, but if you just pass an string, this will be the same that you don't need to do everything to just you don't need to have the full parent element properties and attributes.
Gotcha. Yeah.
You can just so this is just like a shortcut, okay?
Right.
So yeah, just writing div, you can pass in what you are expecting to have there. The compiler will type check, will use the appropriate overload, and everything is also type safe. Okay.
Very nice. Very nice.
And this is also a great tool created here, HTML2 Feliz. So you can see some examples in
wow.
HTML. So you can see HTML and how it looks in F# using this Feliz API. And actually, as you can see, it's really, really clean. It's yeah, it's not as compact as in HTML, but yeah, it's still quite easy to read.
Right.
Mm-hmm. Okay, so yeah. So maybe okay, we have the and there's also something very interesting I want to show you, which is this this project by Jordan Marr, which is called Fable.grouping panel, and this one is also using yet another feature from F#, which is the computation expressions. So
oh wow,
for people who know about computation expression, this was originally the mechanism used for F# by to use async programming. So it's something like async await in C#. But yeah, it's so flexible that you can use it for multiple purposes, and in this case, it's being used to generate UIs, and yeah, it's a really interesting use case. So as you can see here, this grouping panel by Jordan Marr. Also from Maxime, we have this Fable form, which is a way to the same way we saw this thought JSON decoders that we could compose. So here you'll see that there's a possibility of combining your forms. So maybe you want to see.
Yeah, I was going to say I would love to see it all work in action. Can we get a demo?
No, sorry, I didn't prepare. No, yeah, for sure.
That's great.
I have something for you. Okay, so now we are going to go to where the real stuff is. So here's we are in Visual Studio Code. So we are going to start this little project, and yeah, maybe well, it's starting. I think it will take like 5 minutes. So. Okay. We can talk about something else and maybe have a coffee.
Yeah. Well, the thing I find interesting was with the Fable forms was how it, in JavaScript and you're doing HTML.
Oh, no, sorry. It's already finished. Sorry.
Oh, wow. That was fast.
It's too fast. It's always, I hate that. It's because I'm always expecting to have a break, but it's too fast. Sorry, but I just interrupted you.
No, it's all good.
me.
Please, people care more about the demo than me talking. Go ahead.
No, it was just a joke. Sorry. So yeah, we have here because we have this very interesting thing that is forms to sign up. That probably is not the most interesting thing here in this planet, but it's the thing that we have to do all the time. Okay.
Yeah.
So we have forms here. I'm just using this. I think it's pronounced Vitma. It's a tool to it's a new bundler to create a development server in JavaScript. So the nice thing, make it public. So just check this and check this, and I'm saving the code. This is going to change automatically. Okay. Back. Oops. .com. I cannot type. Sorry. And I was going to say that this is going to save the state, but as usual, it's not happening in the demo, right? Because I was just trying 5 minutes ago and it was working, but yeah, in the demo it doesn't work.
because you're doing it live in front of everybody. And that's how it goes.
Yes. Anyways, sorry, but yeah, it's actually this React component. I cannot go into the details about the React now, but this React component happening here. And this is super nice. This API created by Maxime, because you can just compose your form. So as you can see here, I'm composing my form using an email field, a name field, and a password field, and also this repeat password field.
Right.
So I can just okay, see, so for example, I just if I don't want to have the repeat password field, I can just change the composition. But the nice thing is that as you've seen, that this is going to fail compilation. This is going to fail type checking if we modify things, because we are. So if you have a close look to this on submit function, this is going to take the validated fields, so the email, the name, the password, make public, and so only when everything is valid, we are going to be able to use the sign up button. So just see here. I can write something like my email.
I will say I've written JavaScript to do that, and it is not as clean as this.
No. This super nice. I actually, it was released recently, but yeah, when everything is good to go, yeah, we can put that. And yeah, it's quite simple. But I invite everybody to have a look, and yeah, I will share this later. But as you can see, the code is really. It's very, very clean. We can also have a look at this dynamic form. This dynamic form is just using a select function here.
Wow.
That depending on the function. So you see here, this is my view function. So I'm just generating the form. And in this form, we are creating the select field here.
Right.
And this is going to, depending on whether I'm choosing a student or teacher, this is going to show one form or the other. Okay, in this case, it's a simple example. They look very similar. But the thing is that there will be, you can do some more complex forms with this. And yeah, everything is also type safe, because I'm using this user type here, which is a student or teacher. And then I can pattern branch on this to select the form that I'm going to show next. Okay. And this is something, actually, I just wrote it yesterday, because I'm using reflection here as well to create the create. So if I'm going to add a new field, first I'm going to get some some warnings from F#, which is super nice because the compiler will tell me in which places I'm forgetting to.
I was going to say you have a pop-up.
Yes, yes. Actually, you can make it an error as well if you want to.
Gotcha. Wow.
But you can see here that I'm automatically I'm adding this
very nice.
this assistant here, and this is using reflection also to generate the select. This is not in the Fable form in the Fable form library because Maxime doesn't like reflection. So yeah, my mission in this life is just adding reflection to the libraries created by Maxime. So yeah. Just to finish, I wanted to show because the other thing that we are doing all the time in web applications is just taking data from a server and displaying it. And so I was thinking of using this pedestore public API, but I need to write the code for that. So we still have 1 hour, right, for the presentation. No,
we do not. Unfortunately.
Okay. So let me cheat because I'm going to use this another project by Zaid, which is called Hawaii. It's a bit disappointing because if I type Zaid Hawaii, I was expecting to see some pictures of Zaid in Hawaii, but I'm getting this this project, which is also cool, and I have it installed. So if you have a schema like this. A schema is just something very, very simple. Right. It's just telling the tool that we should be using this schema. And then we have this .NET tool. I type in Hawaii. We're going to see here. This is going to generate. Okay. So now we have a project here. Okay. A full project. This tool is generating to interact with and now we can just call this.
Right.
So this is what we are going to do because I'm going to add a reference. File here.
Very nice.
So now. Okay, so now we have this. Let me check if this is compiling. Okay. So yeah, basically this we are going to use a very simple structure to show the a list of items, and then we are able to filter them and also sort them.
Gotcha.
So we can see it here. Okay, so we have the beds here that we got from the API.
Yeah.
So we are getting them from this API here. I can show you the network tab, but yeah, just take my word because we need to finish this quickly. So this is not super exciting. So just a list of items here. So let's make something a bit nicer, which is a table. Okay. Now we have this table here, and now we have this things. And let's say that we want to be able to sort this, so we can take our header, model, dispatch, this name. Now we can sort.
Very nice.
By name, and then we can do the same with category. Okay.
Wow.
And if we want to have, yeah, it's I will post the link later, but yeah, this very simple. There's a couple of types here. There's this making the comparison here for a shortcut, and then this filter. We can have this filter here. So let's also activate the filter with this. We can say have this here, or have dogs, cats, and surprisingly, there's even lions in the as pets in this which is quite interesting. So yeah, that's it. That's the demo I want to show you.
Perfect. So let me ask you this. So, which I think might be a really important question. If Maxime and said did all of these tools, then why are you doing the talk?
I know, right? I know. I just wrote the boring part. I just wrote the compiler, and so I should be talking with Don Simon about the important stuff like stacking monads on top of end of functors or things like this. But yeah. Anyways, it's
that's great. That's great. So I was gonna say, so as a so why would you pick F# with Fable over TypeScript? I'm just, I'm a web developer, so I'm just trying, just wondering why would you do it that way?
So yeah, it's for the reasons that we've seen, but it's not maybe not all the time. Not all the time. Maybe it's Fable the best fit because, for example, if you need to interrupt a lot with JavaScript, we have ways. So if you go to Fable documentation, you can have here the call.js from Fable. We have some things here. We have this tool as well, which is used to generate. For example, here Monaco. Let's see. This can generate, as you probably know, that in TypeScript you have these TypeScript definitions to be able to use JavaScript libraries in a tape-safe way. So we can use this tool to translate this into F# in a way that Fable can understand this. And we can use this, but it's difficult to match the capability of TypeScript. So if you really want to interrupt with many JavaScript libraries, so maybe TypeScript is the way to go.
Gotcha. So I have a question. Actually, the biggest question I have, since we're almost out of time here, we have about 3 minutes left. I was going to say, what is next for Fable? What are you guys working on to make it great?
So yeah, if we say next for Fable, it's also next for oh no, sorry, I want to stop. Yeah, sorry. So if we want to talk about what next for Fable, is the same as what's next for F# beyond JavaScript, beyond .NET, but also beyond JavaScript, because we are working. And by we, actually, I mean not me. Some other contributors are working in expanding Fable to other target languages. So we have, thanks to Jeremy Shashan and Doug Bradley, the next version of Fable is going to be able to compile to PHP and also to Python. So this work in the progress at the moment, but yeah, we'll be able very soon too.
And who's working on the Python part?
Doug Bradley. Doug Bradley.
Look at that!
Oh my! It's here.
We need to say his name 3 times, and he just appears out of anywhere. Hey, Dag, thank you so much for coming to the presentation.
Hi, nice to be here.
So you want to show us a little bit of the work you've been doing?
Yes, let me
awesome.
Share my screen.
Great, thank you so much.
And so we just have a few minutes, but
yeah, we do. Perfect.
Let's go through this. So I have this slide here, F# loves Python, and I'm a software developer at Cognite. And so the thing is, can Python do anything that F# can do? And we will see about that. We have this code in progress, almost 500 unit tests of 2,000 working. Why are we doing this? There's a lot of fun stuff to do. Perhaps run SafeStack with Flask web server, and let's do some demo. So I have here an F# program, and I have split it in 3 windows. So this is a JavaScript file. This is a Python file. We can save this, and we see immediately that it compiles to the JavaScript. We can see what it looks like in Python. And perhaps we could say that main equals like this. And we can see how it transforms the program into the equivalent JavaScript and Python. So I've also prepared a little other demo, which is actually a Jupyter Notebook running on a Python kernel. So this is just a POC. I'll run it in presentation mode so we can see it better. How does that look for you? Yeah, that's fine.
Perfect. Wow.
Let's run the code. I'm importing the Cognite Python SDK. So I'm making some stub types here. So you can see that there's an import line here. And running that. And then I need to use an API key and I don't want to expose it. So I'm importing the get environment function from Python, from the OS module.
Nice.
Let me see if that runs. Yes. Oh, sorry. That was a bit too quick. We can now make the client and try some to see. And we actually got the data points or the time series imported over the net. We can go straight to see if we can do some plotting here. Oh, yes, sorry, we need to do this one. Need to retrieve the time series. Let's see if we got it. Yes, and now we can try that plot again and see what happens. Yes, we have. So this is a POC that we can actually run Python transpile F# code into a Python kernel in Jupyter. So there's a lot of work to be done, but I think it looks promising. So that concludes my demo.
I love that. We transpile Python into a F# Jupyter. It's just that those words are just awesome. That's great. Well, I was going to say, gentlemen, we're right on time. And thank you so much for taking the time to do this presentation. We're going to take all the content and all the stuff and post it out on our GitHub page for everybody to have. So they will, Alfonso and Dag will give me all this information and will be available for you to check out. So thank you so much for taking the time to present at .NET Conf.
Thank you.
Thank you so much. All right. So I see that my other speaker is here. So let me get this stuff set up. Hey, Aaron, how you doing, sir?
I'm doing well, thanks. Hopefully my internet holds out. I've been having some Wi-Fi issues all morning, and it's perfectly timed for when you have to give a presentation, isn't it?
It's what keeps us going, right? Oh, yeah, that is a bit of a
lag. Fingers crossed.
Yeah, I was going to say we do have a pretty significant lag. So let me bring your slides here, and let's get going and see if we have any more issues. You may want to shut off your camera.
Hopefully not.
Just to save some bandwidth.
That's probably a good idea.
Yeah.
Yeah, that might be a good one. So you can listen to the lovely sound of my voice, but not my audio. Oh, sorry, not my face. That's all right.
That's all right.
Yeah, that's the button I wanted. Excellent. So
Take it away,
we're now in audio mode only. Yeah, excellent. And fingers crossed that this goes a bit more smoothly than that little intro there, because I would think I was running at about 2 frames a second. Anyway, thanks for having me. I'm here to talk about Cosmos DB and F#. My name's Aaron Powell. I'm someone who can't work out how to use a clicker in PowerPoint to navigate through slides, but you'd think I'd be better at that given that my job is a developer advocate at Microsoft. I've been doing web for kind of 15 plus years now. I have like all kinds of programming languages on the client and the server. I actually really enjoyed that last talk about Feliz and Fable and compiling F# to JavaScript, because as a web developer, I know just how painful JavaScript can be. I always look for how can we make it a little bit less painful. So I really like the direction of Fable, and I think it's a great tool. Also, if you want to get in touch with me after the session, if you got any questions or anything like that, you'll find my social media links and whatnot on the slide there. But you're not here to learn about me and how you can talk to me and stuff like that. You're actually here to learn about Cosmos DB and F#. So I thought that before we get started into like the F# specific section of the talk, I'll just make sure that everyone is familiar with Cosmos DB and basically get us all on the same page, because there's no point in talking about how we can use Cosmos DB with F# if you don't actually know the role that Cosmos DB can play. So here is a quick rundown of Cosmos DB. Cosmos DB, it's a service inside of Azure that is designed as it's a non-relational database. So you can think of this as NoSQL, I guess, but it's a bit more nuanced than just what we tend to think of as a NoSQL database. It's designed for massive amount of geo-distribution. So whether you're working with data in a region, I'm in Australia, that's why the internet's so slow, because I'm a long way from everyone else. So whether you're doing geo-distributed data, you don't necessarily want to have to think about how you do replication and stuff like that. Cosmos gives you that out of the box. It's designed for that geo-distributed replicated data sets. And because of its NoSQL design, it's actually really well set up for that kind of approach. It's also designed for storing really large scale amounts of data. So whether you're building a small application, and we'll have a look at a couple of small demo applications today in this talk, or you're dealing with petabytes worth of data, Cosmos is designed to scale with your application for that. So you can start with it when you're only a small organization or solving a small problem, and it can grow with you without you having to redesign your data sets, redesign your database architecture, redesign how you work with databases. So with Cosmos DB, another thing that I really like about it is that we can work with it in multiple different ways. So while it is a NoSQL engine, it does have a SQL-like query interface. So we can use the SQL semantics that we're familiar with from SQL-based data engines, selects, wheres, joins, and things like that. But instead of doing joins across multiple tables, we do joins with inside of a partition, and joins with inside of the data sets that we're working with. So a partition is and anyone that's a Cosmos DB fan that's watching the stream will probably like rock back in their chair and go, that's not what it means. But a partition is kind of analogous to a table. At least that's the way I like to think about it anyway. We put particular data structures into a partition. That helps with the way it's sharded and things like that. But it's then how we can optimize access for a particular data structure. So we can do that with a SQL query engine. And for the stuff that we're actually going to look from a demo standpoint, we'll use the SQL API. But you can actually use a bunch of different other database engines to connect to it. So if you're working with, you're building an application and it's maybe porting from like a Mongo engine or something like that, you can actually use MongoDB's query language to query Cosmos DB. Or maybe you're building an application that a graph data model is a better suited approach. Well, you can use Gremlin for that. So you can actually model it with nodes and vertices and work with Gremlin to do graph-based queries against Cosmos DB. Or maybe you're working with more streaming data and something like that. So Cassandra might be a better option. So these are ways that it's all the same database that you're working with, but you can query with it different ways, and you just choose which engine you want to use when you set up the Cosmos DB instance, and that helps optimize for the style of storage and style of querying. We have SDKs in most of the common languages, whether you're doing .NET or JavaScript or Python or Java, etc. It's part of the Azure SDK, so you've got a bunch of different ways to query that, or you can go directly via the REST API. So it's really flexible and can be really adapted into pretty much any application model that you've got. And one thing that I really like is that it's got direct bindings with Azure Functions. We're going to have a look at that in a moment. But what this means is that if I'm building a serverless application and I want to store data in Cosmos DB, or just store data in general, I don't have to think about, well, how do I do connection management, particularly when you've got this dynamic scale out that we've got with Cosmos DB, so with serverless. I don't have to think about that sort of stuff. Azure Functions can just take care of that for me. We'll see that in a demo in a moment. But also, we can subscribe to change feeds. So when data changes with inside of Cosmos DB, let's say that we want to do something with that data. We want to make a view of it, to like remodel some data once it's inserted or whatever that might be, pull it out for a reporting engine. Well, we can process that as a chain feed. Again, like to use a kind of a broken SQL analogy, this is sort of like having an insert trigger and stuff like that. So we can do that. And again, we can do that with inside of Azure Functions. So Azure Functions, I find this is like the easiest way to get into working with Cosmos DB and F#. I've got a blog post. I'm pretty sure I've got the link at the end about how we can get started with F# and Azure Functions, and how we can get started with F#, Azure Functions, and Cosmos DB. But as I said, we can do direct bindings for F# into Cosmos DB from Azure Functions, so we don't have to think about how we build our queries. We don't have to think about how we do connection management and all that sort of stuff. We just end up with the magic power of scalability through serverless. We can also use the change feeds from within inside of Azure Functions, so we can have our serverless applications triggered by what's happening when you insert data into Cosmos DB. But that's enough slides for a minute. Let's jump over and have a look at how we can use F#, Cosmos DB, and Azure Functions together. Now, you don't have to forgive me, I also got a new keyboard this week. It's a very different keyboard layout to what I'm used to. So you're going to see a lot of very slow typing as I try and remember exactly where every single key I need is. There we go. Okay, so this is the VS Code instance that I was actually looking for. I've got multiple of them open. This is an application, interestingly enough, it's actually using Feliz. So it was good following on from that last talk, and like I said, I really enjoyed that kind of stuff. So this is an application. It's got a React, or Feliz front end, compiled to React that runs in the browser with an Azure Functions backend. So a very serverless web application. We can have a look at this application. It's a trivia game. We can start a new game. And so this is then hitting Azure Functions, and we're going through a whole bunch of different steps. So let's do a trivia game. We'll join as me, and then it's going to ask a bunch of questions that will submit the data through to our server. I won't go through and actually play the game. There's a link to this blog post at the end, so you can have a look and play with the code and actually run the application yourself. We're not interested in how the game works. We're interested in how the code that makes that happen exists. So inside of VS Code, I've got a bunch of Azure Functions written here. We'll start with create game. So this is, and let's just move the sidebar off there, so we've got a bit more space for code. So this is an Azure function. It's bound to a HTTP trigger. So that's indicated here. So this is going to accept an incoming web request. But then we have a Cosmos DB trigger. I'm saying that I want to connect to a database called Trivia with a container called Game in my Cosmos DB instance using this particular connection string. Here is the SQL query. Oh, and one thing about the Azure Functions support for Cosmos DB is you must use the SQL query language. It doesn't support Mongo or anything like that because it can only understand one approach. So we have a SQL query here. So I'm just selecting ID from blah, blah, blah. And then we're binding that as an anonymous record sequence. So that's the output that we're going to get. So now, like, there's nothing here that is tying us to Cosmos DB. We're working with just F# primitives. If I want to write some data back out, I have an outref of a record type that I've got inside of my application. We'll see that that game, if I can find that one, that is in my shared code with the client and the server. We'll see that game is just a record type that I've got here with just standard .NET primitives. So then we get back our sequence of question IDs. We're going to scramble them. I've just got a little function that randomizes them so we don't get the same 10 questions every time. And then we're going to pop out the IDs, create a new record, put that into the outref, and then we're going to return an object result. So here we're working with Cosmos DB. This is something that, wait, how did we connect? And I don't really know. Like, the connection was handled by Azure Functions. We had a SQL query that we initially wrote, but we don't have to think much more about it than that is being mapped into an object model. If we wanted to do something maybe a bit more complex, or add a player to a game. So here we've now got a couple of input bindings, which are stretching the ability of my screen to show this very zoomed in code. We've got a couple of input bindings of Cosmos DB. Well, we're getting a sequence of existing players, but you'll notice that I'm also taking in some parameters from the URL that's been passed. So this URL has a bunch of parameter segments, game ID and name. So we're putting that player into that game. And we can then inject that into the SQL query that's being called for Azure Functions. We don't have to we don't have to write that query ourselves. Azure Functions will take care of that for us, and then gives us back a sequence of player objects, which again is just a record type that we've got. And then we've got some more outrefs to write data back out. And then it's just standard F# code working with F# primitives. And lastly, let's say that we were doing something that did require some async operations. We've done everything synchronously so far, but if we were doing something asynchronously, like maybe we had to read the body of the request that's come in to unpack that as JSON, we can do that. So again, we've got a Cosmos DB binding here where we're getting back a game. And this time I want a game based off of its ID. So I don't have to write a SQL query. I can just tell the Cosmos binding for Azure Functions, I want that ID. Here's the game ID. It's going to come in as a URL segment. Just give me that game. Done. No SQL queries written, no connection management. It just no worrying about how do I extract an ID out of a URL. It's just bound for us. And then this is going to need to use. We're using an async block here because we're doing an async operation. We're reading out the stream. We're reading that to the end and unpacking that as JSON. So because this is async, we can't use an outref. Instead, we use an iasync collector. So here is it's an asynchronous collection where we can push items in, and we can do multiple add events, which unfortunately this returns a task, a non-generic task, so we have to just kind of ignore that result. But creating a new record, pushing it in, that writes it across to Cosmos DB. And again, I haven't had to think of what is the insert or update or anything like that statements that I might have to write for working with Cosmos DB. I'm just working with .NET objects and strongly typed objects. So that's how we can work with Azure Functions and Cosmos DB. As I said, I'll put a link to this code sample at the end if you want to have a bit more of an explore of it. But not every application is going to be applicable for working with serverless. So what do we do if we're working with just the Cosmos DB SDK that we get, just the standard one for working with SQL operations? Well, let's have a look at this code sample. So this is the Azure SDK for Cosmos DB, and here's how we can get back an item or a series of items from a parameterized query. We create a query definition, we pass it through a SQL statement, we're adding a parameter to it, and then we're using an await for each because this is giving us an iasync enumerable back that we have to iterate over. Now, from a C# standpoint, this is fairly expressive code. This is what we're familiar with from running C#. But from F#, it's a little bit more cumbersome. We don't really have this await for each in F# because, well, the notion of a for each loop is not really something that's happening with inside of F#. We would tend to use the appropriate iterator functions off the collection type that we're working with. And also, when we're calling the with parameter section on the query definition, are we mutating the existing query definition, or are we creating a new query definition? So there's a bit of opacity, at least from my standpoint, of what's happening here, particularly when we're looking at it from an F# lens of how we would tend to work with expressive code. This it works, we can do it, but it doesn't feel quite right. So how can we make this feel a bit more like F#? And how can we make this work in a more F# expressive manner? So time for another demo and for me to work out where Alt-Tab is on my keyboard. All right, so here is another example application. Again, this is working with that same trivia database backend. And this is, I'm going to walk through the fundamentals of this code, but this is a code base that I actually presented for Cosmos DB conference earlier in the year. So you can go back and actually watch that presentation if you want to see how we can build this whole application throughout the course of that talk. But what we've got, again, just standard record types. We're not having to create classes or anything like that, but we're importing a new namespace, which is fsharp.cosmosdb. So this is an open source project that I created for making it easy to work with Cosmos DB from F#. Now we need to tell our record, or annotate our record type in 2 ways so that we can work better with it. We need to tell what field of that record type is going to be the ID field, so the unique identifier for our records that go into Cosmos DB. And the other is the partition key. How are we slicing and dicing the data that goes in? So we have two attributes that we put onto our members with inside of our record types, and that's what we end up with here. So we end up with a partition key. So question has ID and model type is the partition, and similar for game is somewhere inside of here. I have a type that represents that as well somewhere. Now, when we go ahead and create connections and stuff like that with the Cosmos DB SDK, we need to create a Cosmos connection, and then we connect to the data, we get the database back from that, and then finally we can get a container so that we can query against a specific set of the data with inside of that database, inside of that Cosmos DB instance. And this is, again, it's cumbersome. It's using chaining style operators, so chaining method calls in C#, which is, again, I'm not saying that that's a bad pattern or anything like that, but that's very familiar from a C# standpoint, but it doesn't really translate as nicely to F#. So the library that I've created, I've introduced more of an F# idiomatic approach where we go Cosmos DB from connection string. So we take a connection string, and then this gives us something that we can pipe forward into the other methods. So we can do cosmos.database, what's the database name, and then we're going to take that connection that was established, and then we can pass that database into our Cosmos container. So this is the same as if we were doing Cosmos connection.getDatabase.getContainer. This then gives us a connection operation that we can pass into, say, where we want to perform a query. So we're doing a cosmos.query, we're giving it a SQL statement query that we're executing, and again, this we can pipe into our connection operation. And then if we come down a little bit further and have a look at how we can use that, we'll skip over the boilerplate code for setting up local config and things like that. And the other thing is that this is then going to use the F# async model for doing asynchronous programming rather than the task stack that is what the Cosmos DB SDK will actually use under the hood. But we can establish a connection from our connection string. We can then get a game by calling get connections, which is the function that we had just before for performing the SQL operation. We're going to execute that asynchronously and then strongly type it as a question. And then this gives us back an async seek, because under the hood, this is an async enumerable, which we can translate to an asynchronous sequence inside of F#. So we use async seek, we get that back here, and then this is, we're folding over that, so we're folding over each question and playing the game that way. Finally, we get back our game record, which we can then pass to Cosmos insert. Again, we execute that asynchronously, and then I'm just async iterating over that, outputting just a printfn statement, and then we complete our application. So let's have a look at this one in action. So we'll do a .NET run. Give this a moment to start up. Drum roll, please. There we go. So this has gone, it's pulled back a bunch of questions from Cosmos DB. It's popped them up. Unfortunately, it hasn't taken care of HTML encoding and unescaping those. So we have the less than and greater thans and things like that. But yeah, so this is now a series of questions that we can go through and answer. And yeah, bang, ta-da, and we have a console application that's playing that same game that we just had playing with inside of the browser. Not interested in seeing how the game actually plays out, and also I don't want to get a question wrong when it's on stream and have forever that recorded of the fact that I should have known the answers to the questions that I have in my own data set. And okay, so that's really good, and I think this makes it a lot nicer to work with common operations inside of Cosmos DB. Like we're querying for data, performing inserts, deleting data, and things like that. But one thing that I love about the F# ecosystem is just how much work has gone into making the tooling really optimized for the sorts of things that we're doing in F#. I'm going to jump through to the final VS Code instance that I've got open here. So this is actually the source code for the Cosmos DB wrapper that I've created. And if we come into the program here, we'll see a bit more of what we can do. We can perform inserts. We can get back individual items. We can perform updates. And all of these are just written as little functions that I've got here inside of my F# application, queries, etc. But it looks like that we've got some little red squigglies appearing up here. Let's jump up to that. So we'll start with the red squigglies. One thing about writing SQL statements or like any kind of database query statements like this is, well, you kind of don't know until runtime whether or not you've got them correct. Well, that's where we can take advantage of the F# analyzers that we have with Inide. So I'm using Inide inside of VS Code, and analyzers can give us some insights. So if I hover over this, I always forget that when you're creating a parameter to pass through to an F#, through to a Cosmos DB query for a parameterized value into the SQL statement, we have to prefix it with @ All right, well, it's telling me that, well, I need to have an @ symbol in there. So let's put an @ in. And then it's telling me the same for last name, so we can add that in. Cool. But now it's saying, well, hang on a sec, we've got age, but it's been defined as a parameter, but we've never used it. It turns out that I've written age with all caps. So we can change that, and then there goes that squiggly. Similarly, last name, that should have been name. And then that will get rid of those squigglies. Even up here, it's detected that I have a connection string inside of my app.settings.development.json file. It's tried to connect to that database, that Cosmos DB instance, and gone, well, hang on a sec, the database that you've got there, well, that wasn't found. And then because that wasn't found, there was no container found for that. So, well, it should have been family. So we'll go family, update that, and then that will get rid of that squiggly. And these are sorts of things that you wouldn't detect until runtime. For some reason, it's not giving me quick fixes. It should have quick fixes, so I could do Control Dot and would list out all the containers and all the databases and things like that, so you could select from them. But I'm not quite sure why the quick fixes have stopped working. That's a problem that I'm going to have to deal with after this talk. But yeah, the idea is that you could just do Control Dot, enter, and quickly add that back in, which I think this sort of stuff, it's runtime, it's detecting things that you would probably have runtime errors if you didn't realize that they were there. Well, I think we're nearly out of time. So let's just kind of wrap up with a couple of links that I think could be useful. As I said, I had some of those demos. You can go check those out afterwards. If you want to learn a bit more about using F#, Azure Functions, and Cosmos DB together, I've written a blog post on that. I'll post these links on my Twitter feed after the fact, or you can use the QR codes that I put on the slides to scan them. Mostly the blog URLs were really long, so I didn't want to try and put them in there and someone's madly typing them down and I've gone to the next slide and you've missed it. So use the QR code or check out my Twitter feed shortly. And if you want to check out that trivia application that runs in the browser, you can check that out on my GitHub, and that has a link to the blog post and to the live stream where we went through that in a bit more details. And as for working with F# and the Cosmos DB SDK, so if you're doing a non-serverless application, you'll find the source code for that at on my GitHub, aaronpower.com, github.com/aaronpower/F#CosmosDB. Again, QR codes. And if you want to check out the Cosmos DB console application that works with the F#, works with F# and the F#.cosmosdb wrapper library, you can check that out as well on my GitHub, and that has a link. At least I think it has a link to the talk that I gave at Cosmos DB conference. If not, I will quickly go and fix that while you're madly writing down or waiting for me to post these links on Twitter. But as I said, I think we're just about out of time. So thanks everyone for having me to show a bit of why I think Cosmos DB and F# are a great match for building applications. I think there's a lot of value you can get out of those, and I think that they can work really nicely together, whether you're building a serverless application or working with the Azure SDK, and even if you're using my little wrapper library to make it a bit more F# friendly. Thanks for having me. Feel free to shout out with any questions, or ping me on social media, email, etc. if you want to ask anything I don't get to cover off when my Wi-Fi invariably fails in a few minutes.
It's all good. Like I said, it's the joys of doing conference talks. So thank you, Aaron. Oh, perfect. There you are, sir.
I'll stop my screen share because that should give me a little bit of space back. Oh, and sorry, I forgot to finish.
Such a perfect job. Thank you so much again, sir, for doing the presentation.
Can't hear an audience, so you better bring your own.
That's right. All right. Well, we have Beth and Alan coming up next. So I'm going to do this little change here of speakers. So I'll see you later, sir. Thank you so much. All right. Bringing in Beth and bringing in Alan. How are you doing?
Hey, how are you doing?
Thanks for having us.
Hey, no, thank you for doing this with us. So we have a Q&A, right, of the F# Foundation and .NET Foundation.
That's right. We got a few slides we'll walk through first, just to kind of, tell everybody what each foundation is kind of up to. So we'll kind of roll through a few slides. I'm sharing my screen, I think.
Yep.
And then we'll open it up to questions. And Javier, you're also on the board of directors of the
I am.
So you can ask us questions too.
Perfect. Sounds good. I'm going to share. I'm going to drop out of here, and then I'm going to share your slides, Beth, and we are off. Take it away.
All right. Cool. All right, so here we are. My name is Beth Massey. As I mentioned, I'm on the board of directors for the .NET Foundation, and I'm also the director of marketing for the .NET platform here at Microsoft. Alan?
Hey, yeah. So I'm on the board of the F# Software Foundation, and I look forward to talking about it. So.
All right. Okay, so first, me and Alan wanted to kind of walk through sort of memory lane on .NET's sort of open source journey, and sort of like the series of kind of events since 2001 of how kind of .NET became open source, starting with actually F#. Okay, so it's very apropos that we are at an F# conference and we are talking about .NET open source and F# leading the way. ECMA 335 was the first spec, I guess, released as open source, right, for the common language infrastructure, which was really about like multi-languages on the same runtime, which is what .NET's all about. And at the same time, Mono project began, right? So Microsoft took and implemented ECMA 335 for Windows specifically. Mono project began fully in the open source world as an implementation for Linux. But with 2005, the F# language was released, invented and released open source with the Apache 2.0 license. It wasn't until like 3 years later where the ASP.NET web team at Microsoft started releasing parts of the ASP.NET framework open source. MVC web platform became open source. And then in 2012, Alan, there you go, the F# Software Foundation. Why don't you talk a little bit about that?
Well, it was founded in 2012. I don't have that much more to say. It's just a really exciting event because it started kicking off community building in open source and .NET in particular. So it's really awesome.
So the F# Software Foundation was founded really for around building that community, right? So in 2014, in April 2014, the compiler platform, .NET compiler platform, the Roslyn team had been building this compiler as a service for VB and C# for a few years, actually. It was released in 2014 as open source, and that was the year that the .NET Foundation was also founded. Now, the .NET Foundation was founded to really not just for the community and the ecosystem, but also to support open source projects built on .NET as well. So we do a lot of project support services as well, in addition to the community and ecosystem building. And then you can kind of see from there, you know, in November 2014, the .NET Core project began. That was literally like a kind of copy paste rewrite of the .NET framework, the source open but not open source framework at the time, and a kind of a restart and a reboot of a cross-platform open source .NET. Mono project actually joined the foundation in 2016. That's also when Microsoft purchased Xamarin. So the kind of the family kind of joined back together. And since then, you kind of have seen .NET evolve to become, you know, more and more unified. Okay, so in November last year, we released .NET 5, and we dropped the core to signify the unification of the platform itself. Okay, and that means all the great stuff from .NET Framework coming into .NET Core, all the great stuff from Mono and Xamarin coming into .NET Core to create just one .NET. And you know, in November this year, we'll release .NET 6, and we'll have the completion of that unification with Mono finally. Okay, so it's just a little history lesson of kind of where we are. So the F# Software Foundation actually existed 2 years before the .NET Foundation did. So Alan, why don't you give a little spiel about what the F# Software Foundation is all about?
Yeah, so if you go to the next slide, we have our mission statement, which I really want to just kind of take a moment to focus on. Our mission is to grow, support, and educate a diverse community around the F# programming language ecosystem. And there's a lot of little components there, right? So we have the F# programming language ecosystem. So it's not just the language itself, it's the tooling, it's the, you know, projects like Fable or Elmish, or, you know, so it's a lot of fun. We help maintain some of those projects through community building and working with people. And so that's where the grow and support kind of comes in. And education is really important, because if you don't have people learning, then you're not building your base. And of course, diversity is it helps prevent fragility, right? So it's not just a moral goal, it's also a stability goal. If you have a very narrow cultural lens, you're going to fail to really, if something came up, it could cause you to not see the whole picture. So diversity is a really critical component, and I personally view it as a critical component to long-term success. So if we go to the next slide, it'll kind of have some of our leadership team. We've got Kevin and myself and Pim and Elliot, Philip, Dave, Jeanne, and Reed. Reed is the president, I believe is the term for that. He's a selected position.
Executive director, or
executive director, yes.
Yeah.
And we were all elected as board members, and I believe there's going to be a new election this fall. So
cool.
That'll be fun. So we have several initiatives, and some of them are more just social, and some of them are more about meeting that goal, that sort of mission statement. Firstly, I'd like to talk about the Foundation Slack. If you're not a member and you're just starting to get into F#, go to the Slack first. Don't go to Stack Overflow. Don't go to the Slack, because there's people there who are available 24/7 as a result of being in every continent. You know, we have people around the clock, and it's really helpful to get back and forth advice rather than a sort of, here's your answer. Wait, that didn't quite answer my question. So, and we also have a forums on the fsharp.org site that you can go to, ask questions, and you're going to get community answers. So we really recommend the Slack as a first place to get started. And it's a private Slack, so you do have to go to fsharp.org and sign up as a member. And then we let you in. That helps us maintain the community and prevent spam and so forth. We have a mentorship program. This is like one of our big ones that I'm really excited about. We connect developers to an existing F# project maintainer, and they mentor them in the same way that you would think like an internship. It's really awesome. We've had tremendous results. People have been very happy with it, and I think it's one of our strongest programs that both meets our diversity goals and are trying to help you know, because we're a 501c3. One of our targets is to help marginalized, underrepresented, you know, economically disadvantaged groups to kind of get in there. And so that's one of the things that really helps that is if you can get people some job experience, that's really helpful, and it helps our community, it helps open source. So I really support that.
Actually, just attending this conference today, I just interrupt real quick. It's just been amazing to see the how much everybody helps each other. So I really admire that about the F# community and the mentoring that you guys all do. Very open community, which is great. You're open to new questions and learning, and that's awesome. And you know, all the best and success. And if anybody out there, right, wants to help with being a mentor or, you know, a mentee, we might have a lot of people wanting to learn F# after this event. This would be a great program to look into, right?
That's right. Yeah. And if you're interested, you just go in the Slack and you let us know through the FSSF channel. So it's like hashtag FSSF in the Slack. And just let us know that you're interested, and we'll sort of set you up and try and pair you with a mentee the next time we're doing the mentorship program. So it's really awesome. We love it. As far as the community diversity program, that's where we're kind of helping people who normally aren't necessarily might be overlooked or not sort of put up to the challenge to attend conferences, training courses, community events. Similarly with our down there, the speakers program, but really for this specific program, it's about attendance and training. And I think it's a good program, and I think it's been pretty cool. We've got various user groups, and one of the things I was thinking about talking about here is we do have user groups. I have one I run in Raleigh, North Carolina, and it's kind of funny because it's virtual now as a result of COVID. We've been getting people from San Francisco and Florida, and it's really funny. But one of the things I was thinking about when I was talking to Beth is, well, really, we should also maybe talk about pairing up with some of the .NET user groups that exist. I know in the Triangle we have Trinug, and it would be awesome. And I know Jamie Dixon was running one at one Trinug previous year, but it'd be really awesome if we put more effort into maybe roping more .NET developers to cross-pollinate and have that understanding of F# and having more of a back and forth and a relationship and a conversation. So that's sort of what I was hoping with talking with Beth. It made me think, well, you know, I think I like that we have our F# focus groups because we can focus on things that matter to us. But I also thought, oh, it'd be cool if we collaborated more, we partnered more, or maybe even spoke at .NET user groups more. So
yeah, I mean, we have a whole Meetup Pro group, the .NET group, over 300 groups worldwide. So, you know, if you, and we have groups that are specific, like Xamarin, for instance, so specific frameworks and, you know, applications and app models under .NET. So different language groups are absolutely welcome as well, for sure. We just look for active communities that, you know, we are willing to help, you know, build that network for sure.
Yeah. And one of the ones is the speaker program. So one of the speaker program is to help support speakers for events and meetup groups. And that's where we sort of pay to help people get to those groups. And I know with everything virtual, that's been less of a hurdle. So we've been a little less active on that front. But once things start to calm down, the hope would be to sort of ramp that up again and start getting more people out there and talking. And we've had, I know in my own meetup group, it's been really awesome to have members of the community come by and give a talk. So I think it'd be good, and it might help sort of inject some enthusiasm.
Absolutely.
And then finally, for sort of our initiatives, our major initiatives anyway, we have events, and one of those was the Applied F# Challenge, which was a couple years back, and that was where we set up a list of sort of targets and tried to get practical applied, you know, F#, you know, because a lot of people like to write F# to do little scripts or fun things, but they don't get to do it at work, right? Their workplace isn't currently using F#. So they use it for, I know in my own work, I use it for small scripts that are transient but not necessarily checked in, right? But it's really nice to see practical, pragmatic applications of F# to solve real world problems. That was an awesome challenge. We wanted to run it this year, and we had some challenges getting judges as a result of just sort of everyone's time being spread thin. But I'm hoping in the future we'll be able to start that up again. And we saw some awesome submissions for the Applied F# Challenge.
Cool.
I think, go ahead, Beth.
I think it was cool. Like we've the .NET Foundation also has looked into like, Summer of Code and Hacktoberfest and that sort of thing as well. So I know our outreach committee has worked through a lot of little things and logistics. It's just been tough with the pandemic, so we kind of understand like some of these events are just hard to execute. This one completely, is sponsored by the F# Software Foundation, so thank you, and the .NET Foundation. These virtual events is sort of where we've had to go, but I think they're pretty effective too. So
yeah, and I guess that puts to mind something that I forgot to add to this slide. Yeah, we do sponsor events like this. Like I know before I was a board member, they sponsored my Southern Fried F#, which was hosted at Red Hat, and Red Hat graciously offered this space. I know like we've sponsored various conferences and so forth, especially ones that don't charge ticket price. And then we've also done the outreachy program, which is where we try and help people contribute and write some code, some F# code. And then finally this week we're running the F# Game Jam. It's not too late to write some F# this weekend. I can always extend the deadline if I get a whole bunch of people saying, please give me 3 more days.
cool. That's it. Whoever's watching right now wants to get into F#, this might be your chance right now. Yeah. Alan will extend the deadline.
And there's a lot of ways to do it. You can use Fable and Web Canvas, right? You can use Monogame, things that people traditionally think of as C#. They work great with F#. I know because I've done it myself. I think if you're looking for like more experimental approaches, Aardvark is really exciting and interesting. So there's a lot of different approaches that have been sort of tread for indie game development. So if you're excited about that, come see it. It's on itch. I can link to it. So
cool.
And it's just called F# Jam. Yeah, so how to get involved. So say you're reading this, you're like, oh, I'd love to really contribute to the F# Software Foundation. First step, join the Slack, because that's where a lot of our communication happens, and that's where a lot of our community building happens. And it's also where we get most of our feedback, right? So the F# Software Foundation Slack, the FSSF, little tongue twister. We love to hear from you, and you might decide after being there for a year, you want to be on the board. That could be a great way to contribute. We're always looking for people. Now there is a sort of expectation of at least 10 or 15 hours a month of contribution, and we meet twice a month. But if that's exciting to you, then we might be interested in having you join. You can join one of our programs. Just hit us up in the Slack, which you have already joined, and let us know in the FSSF channel that you're interested in contributing or guiding or even leading one of our programs. It doesn't have to be led by a board member. That's just been done because, board members tend to be excited and want to put their elbow grease in. But anyone can work on
board as well. So very boots on the ground kind of boards. Sounds like both of these foundations. It's great.
Yeah, but we would love, I know I would love to have more, if you're a member and you just want to contribute and you don't want to vote or make decisions, we're more than happy to have you help.
We always want volunteers. Absolutely. Yeah. Absolutely.
And the easiest one is being a mentor or mentee, right? I don't mean easiest in terms of effort, but in terms of how much planning you need to do. You just get them on board, come up with a sort of, this is how we get started. It's going to help you write your docs, right? So if you're a maintainer of an open source library and you're like, it seems like people aren't getting it, and they're not telling me that they're not getting it, mentoring is an excellent way to improve your documentation. Your people are going to tell you, hey, I'm struggling with this and I don't know how to move forward. A lot of times, if you don't mentor someone, they hit that snag and they walk away. They don't tell you. They just keep it to themselves because they feel embarrassed that they don't understand it. But if you're mentoring them, there's a bit of an obligation that, hey, I don't understand this, right? They somewhat expected to speak up. And so it actually provides a lot of value, not just the labor that mentee is going to do, but also helping sort of slipstream your onboarding process and slipstream your process for contributions. So it's really, I think it has a reciprocal help. It's not just the mentee, it's the mentor that also really benefits.
Cool. So I just wanted to talk just a little bit about some of the .NET Foundation initiatives. If we're just going to roll through really fast, I know it was really important to get, to the F# Software Foundation, since this is an F# event. But there is a relationship here. So, maybe people aren't really super familiar with either foundation, but, the .NET Foundation is a little bit different. We do a lot of the same types of stuff as Alan was talking about, like building the ecosystem. We have a speaker, you can sign up like a speaker bureau. Basically, you could sign up. Speakers can put their names in. They can sign up for events. We have the meetup groups. So we are doing a lot of the community outreach and diversity and that sort of thing through our outreach committee. But it really is like the .NET Foundation is a little bit more. It also is like the center of gravity for really like open development and collaboration around .NET. So its mission is really to support an innovative and commercially friendly open source ecosystem around the development platform. So we have over 100 projects and repos under its stewardship. And so the open source software foundations typically provide protection, legal services, support services, and best practices for helping these projects be successful and to grow the software and these open source ecosystems too. And that takes a lot of funding. So we have a ton of corporate sponsors that donate to the .NET Foundation to keep it going. It's not just the individuals, it's large companies that are invested in the future of .NET all up. So .NET is bigger than just Microsoft. Microsoft's one of the corporate sponsors, but we have Engine, DevExpress, AWS, Octopus Deploy, Okta, Progress, Uno Platform, VMware, and Volsoft now, all as corporate sponsors donating money to help us support all of these projects and grow our ecosystem. So thank you so much for all of those sponsors. Our leadership team is elected. So this is a board of passionate .NET community members. Javier, you saw him on the broadcast earlier, is also on the board with me. This is the elected board. They were elected in July 2020, except for me. I am actually appointed by Microsoft. Microsoft created and stood up the .NET Foundation, and in the bylaws, has one appointed board member. Bill Wagner is also from Microsoft, was elected. And Claire Novotny is now our executive director, who came from the community Insight and now also works for Microsoft as well. So this is our leadership team, and we are very much boots on the ground and also run each of us chair one of these committees. So our projects committee is not chaired by a board member directly. That's Sean Walker, who everybody's probably known from the open source ecosystem. He's now lead maintainer of a project called Octane. So he is our chair. They're really in charge of bringing new projects, bringing those projects to the board for consideration for coming into the .NET Foundation. Outreach, they like I mentioned, support community activities and diversity programs. So Alan, I think there'd probably be a lot of connection between our two foundations there that we should probably look into a little bit more. And by the way, we should just say that we have been collaborating a little bit more lately, especially as we tried to pull this event together, so that I think there's a lot of connection points both the foundations can make. We have our sponsorship committee, which really just brings in the funding, organizes the technical steering committee, and really like provides benefits to our sponsors. Member support benefits, they're also in charge of creating the nominating committee, which brings in the nominations of the new board as well, and then they provide all the benefits and managing of our membership. Marketing, I'm the chair of the marketing committee, so that's all PR, go to market for the projects, events, web presence, social communication, so all the fun stuff, and maybe the boring stuff behind the scenes of marketing. Education is one of our new committees, and that's really where, Alan, we connected you and Kevin to Brian, who Brian is also not on the board, but a passionate volunteer who's created a set of curriculum for .NET, and we've created a .NET Foundation Academy, and he's ready to launch it, and really needs some volunteers. I think this is where we could, the F# community could contribute some F# curriculum here as well.
Absolutely.
Absolutely.
Yeah.
So I think there's a lot of opportunities there. Just really quick, here's some of the project services that I kind of mentioned. Don't need to get into it a lot, but really it's about providing all these services for projects so that they can just focus on writing code. So some projects take advantage of a lot of services, and some don't need all of these support, but they're available. And we did mention the meetups. So happy to have F# groups who are active apply to be a member of our Meetup Pro. That means we pay for all your meetup fees. So and connect you to this network of speakers. Elections are here. I wanted to just make this PSA. Any member can run for the board. If you're not a member, you go to the dotnetfoundation.org and get to be a member. You can apply to be a member. They are here. They take place August 4th through 18th. And then you can check out exactly who's running. I'm very excited to see some of the nominations and read through everybody's pitch. So. Also, I mentioned the academy. So Brian is, creating this, higher education aimed at higher education computer science software students. So like college level, and they're looking for partnership opportunities with the F#. So if anybody is interested out there, take a look at the working group out on our .NET Foundation GitHub org there. Brian would love to have you out there. Finally, just to how to get involved with us, there's a lot of things you can do. Even if you don't want to necessarily become a member, you can still sign up for the newsletter. You can contribute to a project. You can, nominate your meetup, find a meetup. There's a lot of things you can do. Anyways, I don't want to take up all of the time here, but I just want to leave it for some Q&A. I think Jeff said that there was some comments out there, so I want to leave a little time for Q&A.
Yes, they are.
All right.
I'm going to bring him up here if you give me 1 second. So the best one, there was this gentleman. His name is Don. Do you guys know him? He said, Alan Ball's doing a great job for the F# org at .NET Conf. Really good voice for the foundation. So nice tip of the hat there. Right. So that's awesome. So thank you, Don, for doing that. Obviously, we all know who Don is.
Well, thanks for inventing F#. So
there you go. Perfect. It's
like, right.
And back to you, sir. No, I'm kidding. So we have a couple call outs here to Paige and Maria when they were doing the killer presentation of .NET notebooks. A lot of cool stuff happening there. So they're looking forward to seeing that. There were several about here. Here's the best one. It's like I'm 26 hours awake. Watched a lot of great presentations. Thank you, F#org. Good night. It is 4 a.m. That is some hardcore .NET and F# viewing. That's amazing.
It's hard to pick the right time to start a virtual event. It really is.
Always, always. So I love that. So we have our dear friend Jeremy Sinclair. Oh, Alan just brought up linking up with some of the .NET user groups. Trust that I will be all for seeing more .NET user group sessions. I can tell you the .NET Foundation virtual user group team would love to produce and host meetups to bring more visibility. So it goes back to that work between the two foundations, right?
Yeah.
Which
And
we want more of.
Amazing. Jeremy's awesome. He spoke at the last .NET Conf. I love Jeremy. I think he was live tweeting the whole event today. So thank you, Jeremy. Appreciate it.
He is a machine. That's what he is. And in the background, I see our dear friend, Mr. Jeff Fritz. What are you doing back there, Jeff? Uh-oh.
Uh-oh.
He looks like a robot because the refreshing of everything.
Yeah, I think we're almost ready to announce some winners of the swag bag prize.
I don't want to do that. I want to do it like this. Yeah. So, I mean, I was going to say, obviously, it was you guys were going through the presentation and everything. It was great.
Were there any other questions for the foundation?
No, that was it. It was a lot more comments than actual questions, right? Because people wanted to learn more about it. And the biggest thing is that I think Alan mentioned is like it's a lot of hard work. There's not a lot of glamour to it. It's the background things that need to happen. Like the .NET Foundation doesn't say you got to do this with .NET. The F# Foundation doesn't say you got to do this. We got to keep the community alive, and that's what the foundations are there for. So, Mr. Fritz, you joined.
Hello. Yeah. Oh my goodness. It has been a fantastic day. Oh my goodness.
You guys are like my two partners in crime here to execute this event. I mean, thank you to all the speakers, the content, all that is amazing. But like, you know, there's a lot of things like just logistics, and you guys are like rock stars on that. So thank you so much. And to all the hosts, to Myra and Jamie, like great job today as well.
Well, also to the great speakers, because obviously, you know, that's the background job.
Without the speakers, of course.
Exactly. Yeah. Yeah. I was going to say I had a lot of fun doing the session with Alfonso, and actually even Don liked it as well. I think there was a tweet about it, which was great.
Yeah.
Oh, wait a minute. I think if we say his name one more time, he will show up. Hey, Don.
Hey, Don. Thank you so much for being the sponsor. Big deal to have you like just drive all of this. It's just been so fantastic getting to know you as well.
My job is to say a huge thank you to Yavia, Beth, and Jeff for everything you've done in putting this together. I think it's been a breakthrough moment for .NET to sort of integrate F# and the .NET Foundation communities, and in such a positive event. And it's just been really a wonderful time. It's been wonderful working with you all in preparing this, and you know, a big thank you to all three of you for everything you've done. And that's not just for myself, but on behalf of the entire F# community and the .NET community in general.
I have a question for you, Don. So when you started in the keynote, there was light coming out of that window. Now there is no light. What time is it at home?
It's 1 a.m. here.
Wow.
Not as I think I don't have his name, but who just joined, I think is John from Persia, from Iran, if I correctly. And it's always been great. It is how worldwide the F# and .NET communities are.
That's great. Yeah.
Awesome.
Yeah,
absolutely. It's been a pleasure this whole week. The past 2 weeks that we've been working with the last minute tech checks and getting speakers all settled. The recording that we did last week. The run up to this event is always such a rush, and you know, huge thanks to everybody for their help.
We also want to thank our sponsors as well that make this happen, right? So you know, I've got a slide of their logos, and these guys have been super generous to donate all of the swag giveaways that we've got giving away in a moment. There you go, including the F# Software Foundation. So thank you, Alan, for the swag. These guys really, PyTop, I actually want to call out because they're giving away a donation to a school of your choice to give them software for building on top of the PyTop. So there's a whole bunch of lessons to learn C# and F# and Python, and like this is like kind of cool. It's more of a donation kind of. I just wanted to call them out. They're very, very generous. Everybody else has like some super fun stuff though. So like over $2,000 for each swag bag you'll be winning.
Wow.
Oh my gosh.
That's amazing. Yeah. That's really incredible.
Yeah. So
you know, the swag we're used to from F# events is like stickers. So this is
well,
we're a bit of a shock to the system.
If you don't win, we still have some great digital swag. So you can mod the .NET bot, like Jeff announced in the beginning of the day. Go ahead and check that out. You can create your own coding companion, and they'll basically, you know, make him like look exactly how you would like. There's also like .NET Foundation store. You could show your support. It is like a donation to us. You know, if you buy some stuff on the store. We have belts, t-shirts, glasses, all kinds of fun stuff out there. And yes, Don, we do have sticker packs as well. And we have F Sharp t-shirts. We do. I didn't put a picture there. We have F Sharp t-shirts.
If I am correct, there's actually an F Sharp foundation. On the fsharp.org you can find an F Sharp foundation store with some things you can
I think that's exactly what the giveaway is something from that store, from the Sharp Software Foundation. So yeah. All right, so drum roll. So Javier has randomly selected out of all the folks that signed up over the course of the day today, 20 winners, and we'll be showing your names here. You will be contacted directly by each of the sponsors via the email address that you left. And here they are. So congratulations, all of you folks, if you're still watching. If you're not, that's okay. You don't have to be present here to win. But congratulations.
That is really great, and one thing I'm really makes me happy, I actually don't know any of these names. So we've got, you got new people coming into the community.
It's not rigged.
It is not. Yeah, it's not rigged. So welcome everyone who's the swag bag giveaway winners, and welcome to the F Sharp community if you've not been participating before, and great to have you along.
All right. So thank you, everybody.
Thank you all again. And next big event, F Sharp Exchange coming up. So the F Sharp Game Jam running right now.
Yeah.
Get involved right now.
Yes.
I'll put the link on Twitter.
Yeah, and I'm gonna probably extend the deadline, and we'll be doing more of these. The nice thing about the Game Jam, so we used itch.io as our little host, and the nice thing about that host is the contestants themselves vote, and so it reduces the administrative overhead, so we can do more of them. It's really quite easy. So
it's great.
It'll be a lot of fun.
Let's amplify the matter. Okay.
Yeah.
Thanks, everyone.
Thank you.
Good night.
Good night.
Good night.
Bye.
Bye.
I'll hit the button. Goodbye, everybody.
It's like, are you going to hit the button? Am I going to hit the button?